Hi everyone, welcome to PrepFusion. So we have been studying about signals and systems. So last we studied about convolution. So convolution was an operator that we studied in continuous time and discrete time. Now we need to start our chapter, that is systems. So now we will see the classifications of system: linear, non-linear, time variant, time invariant, causal, non-causal, static, dynamic, invertible, non-invertible. So these kind of types we need to see. But before that, one simple point I want to deliver here. Okay, you can take it as a basics of signal or whatever you want to take it. This is a some important points are there which I want to deliver, which I forgot in the basics of signal. So those points I will deliver here, and after that we will start our systems. Okay. So have we seen integration in continuous time? Yes. What was the integration? Yt equals to, if I call this a integration, sorry, what was the integration? We used to take the running integration minus infinity to t, and we used to change the axis x of tau d tau, right? So this kind of integration we have seen. Now integration in continuous time was similar to the summation in discrete time, right? So it was similar to integration in continuous time is similar to summation is in a discrete time, that we have already seen, right? So how do we use to take the summation? K goes from minus infinity to n. This is how we used to take the summation. Have we seen differentiation in continuous time? Yes, very easily. Yt equals to, just a second, yt equals to dxt by dt, right? This was the differentiation. But what will be the differentiation in discrete time? So differentiation in discrete time is known as difference. Okay, the word used is difference. So differentiation in continuous time, like integration is called in continuous time, summation is called in discrete time, differentiation goes for continuous time, and difference, the difference word goes for discrete time. So that is shown by delta of xn. Basically here it was dt by yt was equals to d by dt of xt. So similarly here y of n will be equals to delta of xn. This is how it is shown. Okay, and that is equals to x of n minus x of n minus 1. How did this formula come? Let's check that out. Okay, so let's go here. d by dt of xt, how you can write it down? I can write it down in this manner, no? Minus x of t minus del t divided by t minus del t. Basically, if this is a function, and I need to take the differentiation of this particular function at a particular point, so what do? I find the value of xt at that particular point, and then I take a point just before this, that is t minus delta t minus t minus delta t divided by, these are the values of y, these are the values of y axis, these are the values of y axis, divided by the values of x axis, t minus delta t. So t minus delta t is equals to delta t only. Divided by delta t, and considering the fact that limit is limit delta t tending to 0. So this is how we define our differentiation in continuous time. This you would have seen in mathematics, right? So in the similar manner, I am defining my differentiation in a discrete time as well. So this is a discrete time function x of n. Random function is there, some random function is there. Let's just say this point is n. This is axis of n only. So how will I define my differentiation? What I will do, x of n minus, here what did I do? X of t minus just before it. So x of n minus, just before this particular sample, what sample is there? Let's just say this is n equals to 2. So what would be here? This would be n equals to 1. In continuous time, you can say that, okay, you are having some value here, just before this there would be another value. But in discrete time, there is some value here. The next value will be at the first sample only. This is the second sample. The next value will be at first sample only. If I call this as n, what this would be? N minus 1. So the next value, or you can say just previous value, is x of n minus 1 divided by n minus n minus 1. So what is n minus n minus 1? That is 1 only. So there you go. This is the formula we are getting. So this is the formula of differentiation in discrete time. You don't need to remember the derivation. I told you the derivation just in worst case if you forget it, then you should have an idea that what is the meaning of a difference in discrete time. So that sample at that particular time, minus the previous sample, sample at a particular time, or you can say a particular sample minus the previous sample. That's it. This is the meaning of differentiation in discrete time, or the word that is used is difference in discrete time. Okay. So very, very important point. If they want to frame a very good question in signals and system, then they will frame some question from here only. Okay. A very, very good point. So how do we define the second order differentiation in a continuous time? In continuous time, how do we define the second order differentiation? So this is how we write down the second order differentiation. Can I write it down in this manner? D by dt. First you do the differentiation of xt with respect to t, and then again you do the differentiation. So here also we are going to do the same thing. What I need to do? Del square of xn. Basically 2 time differentiation I need to do. So first I will do the differentiation of xn. Then whatever the value I am getting, I will again do the differentiation. First I will do this differentiation. What does this differentiation says? What is the value of del xn? That means the sample, the current sample minus the previous sample. Right? So what does this del do? What does this del say? That whatever that is written here, that will come as it is. Whatever that is written in this bracket, that will come as it is. Whatever that is written here, first that will come as it is. So this del is saying that whatever that is written inside, first that will come as it is. Minus the previous sample. That means minus, in place of n, you put n minus 1. Are you getting this point? What does the del say? Whatever that has been written here, that will come as it is, minus, in place of n, you put n minus 1. That means you take the previous sample. So whatever that has been written here, that will come as it is, minus, you will take the previous sample. That means in place of n, you will put n minus 1. In place of n, you will put n minus 1. So it would be n minus 2. Right? So what you are getting? X of n minus 2x of n minus 1 plus x of n minus 2. So this is how you define del square of xn. You don't need to remember all these things. Okay? You don't need to mug up all these things. You are not going to mug up these formulas, but you can derive it in the examination hall. And when we study Z transform, I will relate all these things with the Z transform as well. Okay, all these things like convolution and whatever that we are studying, that will come back when we study Laplace transform, Fourier transform and Z transform. Whenever we study transform, all these things will come back. So by the end of the chapter signals and system, you will be having at least 2 ways of solving one particular problem. What I am saying, by the end of this subject, you will have at least 2 ways of solving one particular problem. Whether it is based on convolution, whether it is based on power, whether it is based on energy, at least 2 ways would be there to solve one particular question. So you need to wait till the end. As of now, we are learning what we can study from a particular chapter, right? So you would have been clear with the concept of a difference in discrete time. The concept of difference in discrete time says that you need to get the particular sample minus the previous sample. That's it. Okay. And if you need to do it 2 times, if you need to do the double second order differentiation, then this is how you will do it. All good? Okay. Let's solve this question. What you need to find? You need to find del of delta of xn. So basically your y of n is x of n minus x of n minus 1. So what is your x of n? X of n is 2, 3, 4, 1 minus 1. So what will be your x of n minus 1? X of n minus 1 means the complete sequence will be shifted towards this side, right? So it would be 2, 3, 4, 1 minus 1 and arrow comes here, right? Complete sequence is shifted. But what is the rule? The rule says that sample to sample will be subtracted. Zeroth sample will be subtracted from zeroth sample. First sample will be subtracted from first sample. So what I need to do is that I need to write it down in this manner, because this is going from, this was your n equals to -1. This was your -1 sample. This was 0, first, second, third. So this was your n equals to 3. Now here, this is your n equals to -1 now. 0, 1, 2, 3, 4. So here also I need to write down 4 samples. Here also I need to write down 4 samples. Okay. So here 4 and here 5 samples are, here 6 samples are there, and here also 3, 3, 6, right? And here also 6 samples are there. Well and good. So 6 samples are there. So let's subtract one by one. So 2 minus 0 will be 0. 3 minus 2 will be 1. 4 minus 3 will be 1. 1 minus 1 will be, sorry, 4 minus 3 will be 1. 1 minus 4 will be -3. -1 will be -2, and 0 minus 1 will be 1. So this is the differentiation. Okay. This is the difference of xn. This is the differentiation. Basically the current sample minus the previous sample. 2 minus 0, 3 minus 2, 4 minus 3, 1 minus 4, -1 minus 1, and then 0 minus of -1, then 1. Current sample minus the previous sample. Current sample minus the previous sample. Current sample minus the previous sample. This is how we are moving ahead. Okay, so this is the differentiation of x, or you can say difference of xn. It will be used somewhere when we study signal system. It will be used in a very good question. Okay, we will frame a very good question based on this particular concept. Let's see more concept now. If x of n is given, that is u of n, then find the difference of xn. Basically you need to find this particular thing, difference of un. What that would be? Un minus u of n minus 1. What do you think? What will be the answer? Un, what is the graph of un? This is the graph of un. What is the graph of u of n minus 1? This is the graph of u of n minus 1. This is subtracted, this particular thing is subtracted from this. So all these will cancel out. This, all these will cancel out. What will remain? Only this particular thing will remain. And what is this? Delta of n. So this is your impulse sequence, right? So what did you get to know? That difference of un is equals to delta of n. A very good point we are getting. What will be your difference of Rn? Try it on your own without watching the solution. You can do it. Okay. Difference of Rn. Difference of Rn. What is that? Rn minus R of n minus 1. Can I write down Rn as n-un? Yes. Can I write down R of n minus 1 as n minus 1 u of n minus 1? And if you closely remember, what did I tell you? That Rn can be written as n-un. Also it can be written as n un minus 1. Right? I hope you remember. In the last lecture only, when we studied discrete time convolution, this was the first thing that we studied. Rn is n-un. It could be equals to n-un minus 1 as well. So n-un minus 1. Why we are doing so? Because I need to take common. Un minus 1 I need to take common. That's why we are doing so. So what we are getting from here? U of n minus 1, right? If you take, basically, if you take, what you need to take? U of n minus 1, if you take common, then n minus 1. Yeah, so you are getting u of n minus 1. I hope this calculation is easy for you, right? Rn is n-un, then you can subtract 1 from here. This is n minus 1, un minus 1 only. You can write down n minus 2 as well, but why do we write down n minus 2? This is not something that I require. What I want everything to be in terms of u of n minus 1, so that I can take it common, and then from n minus 1 is subtracted from n. So what I will get? 1 only, right? So the answer we are getting is u of n minus 1. So what we are getting here? Difference of Rn is equals to u of n minus 1. So difference of Rn plus 1, what that would be? U of n plus 1 minus 1, right? N plus 1 minus 1. Basically, whatever that is written here, it will be converted into u n minus 1. So whatever that is written here, it would be converted into u n plus 1 minus 1. So n plus 1 minus 1, that would be equals to u of n only. So what this would be equals to u of n. Say yes or no. So basically what I should have written here in the conclusion, what I should write, what is the conclusion? That if you are having un and you want to go to delta of n, how will you go? Simple differentiation. What you will do? Simple difference you will do and you will get delta of n, right? But if you do the difference of Rn, what you are going to get? U, it will be converted into u, but u of n minus 1. And if you want u of n, that means you need to do the differentiation of, or you can say you need to take the difference of r of n plus 1. That would be your u of n. Is that clear to you or not? And can you relate it with running integration? If you remember this particular thing. In the last lecture, when we studied continuous time convolution, when we studied discrete time convolution, there we took the running integration of step sequence, right? Running integration, if you remember, k goes from minus infinity to n, u of k. What was the answer? What was the answer? R of n? No, it was r of n plus 1. And then we wrote it down as n plus 1 un. So you take the differentiation of this particular thing, you will get u of n. And you take the integration of u of n, you will get r of n plus 1. Although it is known as summation and the differentiation is known as difference. But just to relate the things, I can call this as integration and the other one as differentiation. So I hope you are able to connect the dots now, right? So all these things you will be able to keep in mind that what was the thing? Delta of t. Here if I relate with the ut and delta t, I don't need to relate it because differentiation of ut is delta t, differentiation of rt is ut. But here difference of un is delta n, but difference of rn is un minus 1. Let's do the running summation now. If you remember this particular summation, right? I hope you remember. For n less than 0, how do we use to solve it? Let's call it y of n. Let's call it y of n. Although it will be equals to u of n, I hope you should be able to solve it. For n less than 0, if you do the summation, what will happen? For n less than 0, because the impulse is at k equals to 0 only. So if your n is less than 0, let's just say it is minus 1. So summation will go from minus infinity to minus 1. So what will be the answer? Summation will be 0. And for n greater than 0, so delta k value will be 1. For n greater than 0, delta k value will be 1 because at n equals to 0, you will have the sequence. So what will be the value? Y of n will be equals to 1. So for n less than 0, y of n is 0. For n greater than 0, y of n is equals to 1. This we have already seen in the basics of signal. That's why I am writing it in a quick manner. I hope you are able to understand this particular thing. I hope you are able to write down this particular thing. So from here what we will get? So this summation, what is this equals to? This is your un only. Basically here it should be n less than 0, not equals to 0. If your n is less than 0, that means still minus 1. From minus infinity to minus 1. If your n less than 0, then y of n is 0. And if n is greater than or equals to 0, then y of n is equals to 1. So what this is equivalent to? This is equivalent to u of n. So running summation of impulse sequence will give you step sequence. But running summation of your, what is this? Step sequence. Running summation of a step sequence gives you, what does it give you? Not ramp sequence, but ramp n plus 1. What is this? Can I write it down in this manner? U of n convolution with u of n. Anything convolved with u of n is equals to running summation of that particular function. Anything convolved with u of n is equals to the running summation of that particular function. U of n convolution with u of n. If you remember in the last lecture we have done it. What was the answer? R of n plus 1. So what you are getting? That running summation of your step sequence is equals to the ramp sequence but plus 1. So this is not the pure ramp sequence, this is R of n plus 1. If you need R of n, then what you need to do? Here in place of k I need to put k minus 1, or I can say in place of n I need to put n minus 1. Are you getting this point? So as of now you just write it down, as of now you just remember this particular thing, that so k goes from minus infinity to n, u of k is equals to r of n plus 1. All good? So let's write down the things. So in continuous time, if I need to go from delta t to ut, what I need to do? Integration. Ut to rt, integration. Rt to ut, differentiation. Ut to delta t, differentiation. Right? Here also there is an error, because the scene is, if you do the differentiation of r of n, you get to u of n minus 1. So you need to do the differentiation of r of n plus 1. You need to do the differentiation of r of n plus 1. Then you will get un, and if you do the differentiation of un, then you will get delta n. So there is clear relation between un and delta n. Simple difference. But here r of n plus 1 would be there. So this is something that I would recommend you to remember, that running integration of u of n is equals to r of n plus 1. It is not equals to r of n. So if you remember this particular thing, that means kind of integration is equals to r of n plus 1. So this also you will be able to remember, that r of n plus 1 difference would give you un, right? And what will be the difference of rn? If you take the difference of rn, then what you will get? You will get u of n minus 1, just one less. Now what about the integration? If you take the running summation of delta n, what you will get? U of n. But if you take the running summation of un, what you will get? R of n plus 1. Say yes or no? Well and good. And if you take the running summation of u of n minus 1, what you will get? What do you think? Running summation of un is giving you r of n plus 1. So running summation of un minus 1 will give you n minus 1 plus 1. Say yes or no? Whatever that is written inside, plus 1. So whatever that is written inside, plus 1. What that would be? R of n only. Are these things tough to remember? No, you don't need to remember anything actually. Un and delta n, clear relation. Differentiation and summation, clear relation. There is just some ambiguity with un and rn. If you take the summation of un, just remember this particular thing. Okay, I am highlighting it as well. If you remember only this particular thing, then you will be able to remember all the things. Because if you go from here to here, then what will happen? R of n plus 1 differentiation will give you un. Un summation will give you r of n plus 1. Only you need to remember this particular thing, and that you can remember from this as well. That un convolve with un, that means running integration of un will give you r of n plus 1. I don't think it is that tough to remember. Well and good. Okay, so only one thing that I am asking you to remember, we will frame a very good question based on this. Once we are done studying the systems, once we are done studying the LTI system, we will frame a very good question. Okay, that would be very good question, and if they want to frame a good question from this particular chapter, then they will frame in this direction only, because a lot of students would think that okay, running summation of un will be r of n only, and they don't even know the meaning of difference actually. This is not taught anywhere, like what is the meaning of differentiation in a discrete time. Okay, although all these things are related with jet transform, but without even using the jet transform, how do we solve the problem? Just by the basic concept of signals and systems that we are learning here. In the jet transform as well, I will relate all these things. So it would be very easy for you in the examination hall. But as of now, we are learning with respect to systems only. All good? So now we need to get started with our chapter, that is systems. Okay, so now we need to study systems. So first I will give you the basic definition, then I will take some break, and then we will get started with our chapter. So have we seen this circuit anywhere? Yes. When we started our complete subject, when we started the first lecture of signals, there we saw this particular circuit. What did we do here? There, I applied 5 volt here, and what was the output that I will get? So this is a simple network analysis circuit. This is known as potential divider circuit. Okay, this is a potential divider circuit. So what will be your output? 5 into 2r upon 2r plus r. So that would be 5 into 2 divided by 3. So output will be 10 by 3 volt. So what did I tell you? That this is a signal. This was your input signal, right? And this was your output signal. This is what I told you, right? This is your output signal. So this was the basic definition of signal, that it is a piece of information. Now this piece of information you applied somewhere, and this piece of information you applied somewhere, and something gave you some another piece of information. The input piece of information was 5 volt, the output piece of information is 10 by 3 volt. So where did you apply that particular thing? To this particular system. So this is known as system. Okay. So in a system you applied some input signal. In a system you applied some input signal and you received some output signal. So this is known as system. In our system we are using two resistor. You can use anything: resistor, capacitor, inductor, AND gate, NAND gate, NOR gate. If you have heard these words, so you can use anything. In this particular system we are using only two resistor. You can use anything. So what is a system? It is an interconnection of network elements. It is an interconnection of network elements that will process some input signal and will produce some output signal. That's it. This is the basic definition of system. So if anyone asks you in any viva, in any college viva, if they ask you what is the meaning of signal and system, then you will draw this diagram and let them know that this is the input signal, this is the input piece of information, we are receiving output piece of information. So these are the signals and we are applying it to a particular system. So a system is an interconnection of network elements which will receive some input information and will give some output information. That's it. This is the basic definition of your system. So there is some input information, or you can say input signal, and you will receive some output signal. Okay. So rather than focusing on words, what is the word that is written? A system is combination of interconnected components or circuit that will process electric signal to perform a specific operation. So here what kind of operation they are performing? If you are applying 5 volt, you are getting 5 into 2 by 3 volt, right? If you applied 5 volt, you are getting 5 into 2 by 3 volt. So whatever the input that you apply, that will be 2 by 3 times. So this is the operation this system is performing. What operation this system is performing? Whatever the input that you apply, that will be made 2 by 3 times. I am applying 5 volt, I am getting 5 into 2 by 3. If I apply 10 volt, what I will get? 10 into 2 by 3. Say yes or no. If I apply 15 volt, I will get 15 into 2 by 3. So the job of this system is to multiply the input signal with 2 by 3. That's it. This is the job of this particular system. So now you can again read the definition, but rather than focusing on the definition, we need to understand the concept. The definition says that a system is a combination of interconnected components or circuits that will process an electric signal to perform a specific operation. So the operation that is performed is multiplying the input signal by 2 by 3. Okay. So now we need to solve this particular question, and from these questions we will make some conclusion. Okay. So this question is given, you can try it on your own. This is very basic question, you will be able to solve it, but we need to make some conclusion out of it. Okay, what we need to do, we need to make some conclusion out of it. So a system is given, the same system is given, whatever the system that we took here, the same system is given here, R to R xt yt. Xt is the input, yt is the output. So this is how I am representing the system. Xt is the input, yt is the output. You need to find the output for the following inputs. That means first I am applying the input to be 5 ut, then 15 ut, then I am doing x1t plus x2t, that means 5 ut plus 15 ut, that would be 20 ut, and then I am doing 2x1t, that means 10 ut I am applying. So what will be the output? From these outputs we will make some interesting conclusion. Okay, so do it on your own and then I will come back. So I need to drink some water, then I will come back. Okay. Okay, so let's see it. So xt, what is the relation between yt and xt? So yt is simply equals to xt into 2r divided by 2r plus r, that would be 3r. So yt is equals to 2xt by 3. Say yes or no. This is your yt. Yt is equals to 2xt by 3. So what I am doing, I am making the system now and I am applying the inputs. So if I apply the input xt, what is the output I am receiving? 2 by 3 xt. What is the output I am receiving? 2 by 3 xt. If I apply the input 5 ut, if I apply the input 5 ut, what output I am receiving? That output would be 2 by 3 into 5 ut, so that would be 10 by 3 ut. Next I am applying the input to be 15 ut. Okay, 15 ut. So what is my output? My output is 2 by 3 into 15 ut. So that is 10 ut, right? 10 ut. Next I am applying x1t plus x2t. What is x1t plus x2t? That is 20, right? So next my input is 20 ut. 20 ut. What is the output I am getting? 2 by 3 into 20 ut. That would be 40 by 3 ut. This output I am calling as y1t, this I am calling as y2t, this I am calling as y3t. So 40 by 3 ut, 40 by 3 ut. Can this be written as 10 ut plus 10 by 3 ut? Can this be written in this manner? 10 ut plus 10 by 3 ut. What is 10 ut? 10 ut is y2t. And what is your 10 by 3 ut? That is y1t. What was your input? 20 ut, and 20 ut can be written as x1t plus x2t, right? x1t plus x2t. So this can be written as x1t plus x2t. So when you applied the input x1t plus x2t, what output you are getting? y1t plus y2t, right? Let's add another page and write down the output for the next system. So last one was, what is the input? Input is 2x1t, that means input is 10 ut. So if your input is 10 ut, what will be the output you will be receiving? I am calling it y4t. y4t. So 10 ut into 2 by 3, that would be 20 by 3 ut. Can I write it down in this manner? 2 into 10 by 3 ut. 2 into 10 by 3 ut. Can I write it down in this manner? Yes. So can this be, what was this input? This input was 2 x1t, right? 2x1t. The input was 2x1t. Input was 2x1t. Can I write down the output as 2 into, what is 10 by 3 ut? 10 by 3 ut is y1t. So output can be written as 2 y1t. 2 y1t. So what did you notice here? When you applied x1t, you are receiving output y1t. When you applied x2t, you are receiving the output y2t. When you applied x1t plus x2t, what output you are receiving? y1t plus, basically addition of these two output. When your input was added, your output are also added, y1t plus y2t. And when your input is multiplied with the factor of 2, then your output is also multiplied with the factor of 2. Such system are known as linear system. Okay, so this system is an example of linear system. So what did we do? First we find out from here that yt is equals to 2 by 3 xt. Then for different input we saw the output. We got to know that when I am applying x1t, I am receiving a particular output y1t. When I am applying x2t, I am receiving a particular output, that is y2t. When I am applying x1t plus x2t, I am getting the summation of my output y1t plus y2t. And when I am applying 2x1t, I am getting my output to be 2y1t. But it will always not be possible. Okay, this is possible only for this particular system. There could be other system as well where it is possible, but there could be some system where it is not possible. Let's take that kind of example. So this system is there. xt is equals to, xt is the input, yt is equals to e to the power xt. Basically, whatever the input that you will apply, that will go into the exponential term. Whatever the input that you will apply, that will go into the exponential term. So I am applying x1t. So what will be my output y1t? Whatever the input that I am applying, that will go into the exponential term. If I am applying x2t, so whatever the input that I am applying, it will go into the exponential term. What will be your y3t? Your y3t would be equals to whatever the input that you are applying, that will go into the exponential term. So x1t plus x2t. You just let me know, is it equals to y1t plus y2t? What is y1t plus y2t? y1t is e to the power x1t plus what is y2t? E to the power x2t. So here your y3t, this is certainly not equals to this is your y1t plus y2t. So these are not equal, right? So here y3t is not equals to y1t plus y2t. So here only the condition is failing. Okay, here only the condition is failing. That means this is not a linear system. This is known as non-linear system. Okay, non-linear system. Another one I will check, that is 2x1t. So what I will do? What will be my y4t? That would be e to the power, whatever the input is applied, that will go into exponential term. Is it equals to 2y1t? What is y1t? This is y1t, 2 into e to the power x1t. Are both of them equal? Absolutely not. So they are not equal. That means y4t is not equals to 2y1t. Say yes or no. So this condition is also failing. So if any one of the condition fails, either this condition or this condition, then the system will be non-linear. Okay. So let's write down all these things in words. So what all are the words are there? So linear and non-linear system we need to study. So yt is equals to alpha xt. Yt equals to alpha xt. Alpha could be any value. It could be 2 by 3, 4 by 3. So that was our linear system. And exponential was our non-linear system. Non-linear system. So a linear system will follow two properties. What all are those properties? Additive properties. First one is known as additive. Additive property. What is the meaning of this? That this is a system. If I apply x1t, I will receive y1t. If I apply x2t, I will receive y2t. And if I apply x1t plus x2t, I will receive y1t plus y2t. Okay, so this is known as additive property. So a linear system has to follow the additive property. So this is the first condition, additive, and second condition is known as homogeneity. What it is known as? Homogeneity. Okay, homogeneity. So if you apply x1t, what you are receiving? y1t. But if you multiply this with the particular factor, any factor a, if I am multiplying my input with any particular factor a, then my output will also be multiplied with that particular factor a. So these two properties my system has to follow. If they are following this property, then it is known as linear system. And what if I combine both of the properties, additive plus homogeneity? That means if I am combining both of the properties, what is the meaning of that? That I am applying x1t, I am receiving y1t. I am applying x2t, I am receiving y2t. Now if I apply alpha into x1t, that means multiplying x1t with the particular factor plus multiplying x2t with the particular factor and then adding both of them. So what output I should receive? x1t was multiplied with alpha, so y1t should also be multiplied with alpha. Then there is plus sign, plus sign. x2t is multiplied with alpha, that means y2t should also be multiplied with, x2t is multiplied with beta, so y2t should also be multiplied with beta. So if this kind of property is being followed, then your system is linear, otherwise it is non-linear. So your system has to follow both of the properties, additive and homogeneity. Then only it will be known as linear system. All good? We have seen two examples as well. This was the first example that we saw. Here our input was just multiplied with 2 by 3. So first x1t was multiplied with 2 by 3. Here we can see x1t was multiplied with 2 by 3, then x2t was multiplied with 2 by 3, then we applied x1t plus x2t. So 2 by 3 into x1t plus x2t we got, and then we applied 2x1t, so we got 2 by 3 into 2x1t. But in this particular example, in exponential example, what we saw here is that I applied x1t, I got e to the power x1t, x2t e to the power x2t, x1t plus x2t, so we got e to the power x1t plus x2t. That is certainly not equals to e to the power x1t plus e to the power x2t. So certainly it is not following the additive property. So here only I can say that it is non-linear system. I checked the homogeneity property as well, that if I multiply my function with 2, will my output be multiplied with 2? So absolutely not. It is being not multiplied with 2, it is coming out to be something else. So it is not following the homogeneity property as well. That means it is non-linear system. For getting the non-linear system, if your additivity fails or your homogeneity fails, only one condition needs to fail. If only one condition is failing, that means it is non-linear system. So a linear system will follow both of the properties, additive and homogeneity. Let's check more examples now. What will be the procedure? Procedure would be that first I will apply x1t, then I will apply x2t, then I will apply x1t plus x2t, and then I will apply any random value a x1t. Okay, any value a into x1t, and then I will check the outputs. What output I am receiving, what output I am receiving, what output I am receiving, and what output I am receiving. I will check the output, and then I will check whether the condition of additivity and homogeneity is performed or not. Okay, so let's see it with the example. Yt is equals to 5xt. So first what I need to apply? If I apply xt, what I am getting? If I apply xt, I am getting 5xt, right? If I apply x1t, what will happen? Whatever the input that you are applying, that will be multiplied with 5. So whatever the input that I am applying, that will be multiplied with 5. If I apply x2t, what I will get? I will get 5x2t. If I apply x1t plus x2t, x1t plus x2t. So whatever the input that you are applying, that will be multiplied with 5. So 5x1t plus x2t. So that can be written as 5x1t plus 5x2t. Is this thing equal to the previous two output? Is this thing equal to the addition of previous two output? Yes. So additivity is performed. Whatever the output that you are getting here, is this equals to the addition of previous two output? Yes. That means your condition is satisfied. Additivity condition is satisfied. Next, what I need to do? I will multiply with that particular factor. What I am going to apply now? I am going to apply, let's just say I am going to apply 2x1t. I am going to apply 2x1t. So what will happen? Whatever the input is there, that will be multiplied with 5. So 5 into 2x1t, that will be written as 10x1t. Is it 2 times of this particular signal? Yes. If you are applying x1t, you are getting 5x1t. If you are applying 2x1t, you are getting 2 times of x1t. Sorry, 2 times of this particular output. Basically, you are getting 10x1t. If you are applying x1t, you are getting 5x1t. If you are applying 2 times of x1t, then you are getting the 2 times of this particular output. That means 10x1t. Right? So here also the condition is satisfied. Input 2 times, output also 2 times. Output also 2 times. So additivity and homogeneity, both conditions are satisfied. That means it is a linear system. Okay. So this is a linear system. Well and good. Let's go to the next one. Xt plus 5. Okay. The next system is xt plus 5. So if I apply x1t, or first let's get started with xt. So if I apply xt, what will happen? The same signal will come, but it will have a DC value as well. If I apply x1t, what will happen? The same signal will come, but it will have a DC value as well. If I apply x2t, what will happen? The same signal will come, but it will have a DC value as well. If I apply x1t plus x2t, what will happen? Whatever the input that you are applying, the same input will come, but added with 5. So what input I am applying? x1t plus x2t. The same signal will come, but added with 5. Is this equal to the addition of these two? Is this equals to the addition of these two? What will be the addition of these two? x1t plus 5 plus x2t plus 5. No. Right? This is not equal to the addition of these two. And if it is not equal, what does that mean? That here additivity fails. Additivity fails. And if additivity is failing, it is non-linear. Okay. So here only you can say that it is non-linear, but let's check other points as well. What we are going to check? We are going to check the homogeneity as well. So how will I check homogeneity? What I will do? I will multiply 2x1t. So whatever the input that you are applying, that will be added with 5. Whatever the input that you are applying, that will be added with 5. Is it equals to the 2 times of this particular output? What will be 2 times of this particular output? Here what we are doing, whatever the input that you are applying, that will come same, but added with 5. So this is the actual output we are receiving. But is it equals to this 2 times of this particular output, because here we are doing the 2 times of input. So are we getting the 2 times of this particular output? 2 into x1t plus 5. Are we getting what we are getting? 2x1t plus 10. So certainly both are not equal. So here what is failing? Homogeneity is also failing. Homogeneity fails. So what is this? This is a non-linear system. Okay, non-linear system. So from now onwards, I will write linear as L and non-linear as NL. Okay. xt plus ft. Try doing it on your own. Ft is a random function of time. So what will happen? Is it linear or non-linear? So if you are applying xt, what will happen? So whatever the input that you are applying, just a random signal ft will be added. So if I apply x1t, so if you just follow the process, then it will be very easy. Otherwise, this particular topic is very tough for the students. They find it very tough to determine whether it is linear or non-linear. So just follow the process, whatever that I am telling. If you just follow the process, if you do it in this manner only in the examination hall, there is no one who can get you wrong there. Okay, so just follow in this manner only. If I am applying x1t, whatever the input that I am applying, that will be added with ft. Whatever the input that you are applying, that would be added with ft. Whatever the input, now which input I will apply? Addition of these two. So whatever the input that you are applying, that would be added with ft. Is it equals to the addition of these two? Is it equals to the addition of these two? x1t plus ft plus x2t plus ft? Absolutely not. So in xt, if any of the term is added, yt is equals to xt, but if any of the term is added, that will make it non-linear. So here additivity fails. Additivity fails. And here only I can tell that it is non-linear. Okay, I can check the homogeneity as well. What I will do, I will multiply my this input signal, I will multiply with 2. This is how I can do it. This input signal I will multiply with 2. So whatever the input that you apply, that will be added with ft. So whatever the input that I am applying, that will be added with ft. Is it equals to your 2 times of this particular signal? Is it equals to 2 times of x1t plus ft? Absolutely not. So both are not equals. So here homogeneity also fails. Homogeneity also fails. So any of the condition you can check, both are failing here. That means it is non-linear. So this is how you need to check. Check this one, sin t into xt. Sin t into xt. So if I apply xt, what I am getting? Sin t into xt. If I apply x1t, what I will get? Sin t into x1t. If I apply x2t, what I will get? Sin t into x2t. If I apply addition of both of them, so what I will get? So what is happening here? Whatever the input is there, that will be multiplied with sin t. Whatever the input is there, that will be multiplied with sin t. So whatever the input is there, that will be multiplied with sin t. x1t plus x2t. Right? And I can open it in this manner. Sin t into x1t plus sin t into x2t. Is it equals to the addition of these two? Addition of these two is equals to this one, right? Sin t into x1t plus sin t into x2t. Yes. So here additivity is fine. Additivity works. But we need to check homogeneity as well. So what I need to do, I will multiply this particular thing with 2 or 3 or anything you can multiply with. Okay. So what does it say? Whatever the input is there, that will be multiplied with sin t. So whatever the input is there, that will be multiplied with sin t to x1t. And I can write it in this manner, 2 sin t into x1t. So this is equals to the 2 times of this particular thing, 2 times of this particular thing. So if your input is doubled, if your input is doubled, If your input is double, then your output is also double. So yes, homogeneity also fine. Okay. X into sin t. Sorry, x not into sin t. Sorry, x sin t. X sin t. X sin t. So how will you read it? Whatever the input that you are applying, in the input in place of t, you will put sin t. Whatever the input that you are applying, in the input in place of t, you will put sin t. That is the output. So if I apply x1 t, so whatever the input that you are applying, x1 remains as it is. In place of t, what you will put? Sin t. If you apply x2 t, whatever that you are applying, that remains as it is. X2 remains as it is. In place of t, I need to put sin t. That's it. Nothing else. If I am applying x1 t plus x2 t, what does that mean? X1, x2 remains as it is. In place of t, you need to put sin t. That's it. In place of t, I need to put sin t. So that is equal to the summation of these two. Right? This is equal to the summation of these two. X1 sin t plus x2 sin t. So this is equal to summation of these two. Yes, this is equal to the summation of these two. What does that mean? That this follow additivity. So no issue with the additivity. What about your homogeneity? So let's check the homogeneity. So that will also be followed, right? 2x1t. What I am doing? I am just doing the double of this input. So whatever the input that I am applying, that will remain as it is. Just in place of t, you will put sin t. In place of t, you will put sin t. Is this equals to the double of this particular thing? Yes, this is equals to the double of this particular thing. That means homogeneity is also there. Homogeneity is also there. That means this is linear, right? So this was also linear. Linear. Well and good. Let's see more example. X of f3t plus g sin t. What I am doing, just a random thing. So what does that mean? That whatever the input that you are applying, let's just say I am applying xt. So x remains as it is. In place of t, you are going to put this particular thing. In place of t, what you are going to put? f3t plus g sin t. Nothing else. The point is, inside x you can do anything. This will also be linear only. You can see it, right? If I apply x1t, what does that mean? x1. Inside t is there. In place of t, what you will put? f3t plus g sin t. Okay. Next, what I will do, I will just copy and paste. What I need to apply? Now I need to apply x2t. So if I apply x2t, what will happen? x2 remains as it is. In place of t, you need to put f3t plus g sin t. Now next, what I need to apply? I need to apply x1t plus x2t. x1t plus x2t. x1t plus x2t. So whatever that I have applied, that will remain as it is. In place of t, you need to put f3t plus g sin t. f3t plus g sin t. Is this equal to the summation of these two? Summation of these two. Is this equal? Yes. That means additivity is fine. What about homogeneity? What about homogeneity? So if I apply 2x1t, what will happen? Whatever the input that you have applied, that will remain as it is. Just in place of t, you need to put this particular thing, right? So is it equals to 2 times of this particular thing? Yes, it is equals to 2 times of this particular thing. So that means here homogeneity is also fine. That means it is linear. So what did you understand from here? That x of ft, x of no matter whatever that is there inside, will always be linear. So all these things we will write down. No need to worry about that. Now check out this one. There is a minus sign. Will the minus sign make any change? I am just asking, will there be any impact of minus sign? No. What is the meaning of this particular thing? that if I apply xt, if you apply xt, what you will get? One minus sign you need to take. Basically, this signal will be multiplied with -1, and in place of t, you need to put -t. If I apply x1t, this signal will be multiplied with -1. In place of t, you need to put -t. If I apply x2t, the signal will be multiplied with -1. In place of t, I need to put -t. x1t plus x2t. So what will happen? Whatever the signal that you have applied, that will be multiplied with -1. But in place of t, you need to put -t. Whatever the input that you have applied, that will be multiplied with -1. And in place of t, you need to put -t. In place of t, you need to put -t. So what that can be written as? Minus x1t minus x2t. Is this equals to the summation of these two? Yes. Right? This is equals to the summation of these two. So linearity, sorry, what do we say? Additivity is followed. What about the homogeneity? So if I multiply this with the 2x1t, so what I will get? Whatever the input is applied, that will be multiplied with -1, and in place of t, you need to put -t. Right? So is this equals to the 2 times of minus x1t? Yes, 2 times of this particular output. It is equals to 2 times of this particular output. That means homogeneity is also there. So additivity and homogeneity both are there. What does that mean? That it is linear. Okay, so it is linear. Right? So negative sign, like if you multiply the output with negative sign, that would not matter much. Okay, that would not make any impact on linearity. Well and good, all good. X square t, try doing it on your own. This is very easy. So this example you do it on your own. This example also, this is very good example. This is conjugate. Okay, what is this? This is conjugate. So do this one on your own. I will take a break. Conjugate, and then try these examples. F of xt, gt, x, ft. Try these examples, and then later on we will see all these kind of signals. Like we will comment on all these kind of signals, because these are just the standard examples. In the examination, if any example would be coming, that would be coming from these particular examples only. Okay, and then we will see differentiator, integrator, then this particular integrator, and then some properties about linearity. Okay, and then finally these examples, and this piecewise defined or segmented defined by t. And yeah, later on we will see some graph, and then we will see some more problems. So in that manner we will proceed in the lecture. So as of now, what is your target? Your target is you tell about x square t, whether it is linear or non-linear. Okay, so do it on your own and tell me. Okay, so let's start. If you apply xt, what you will get? X square t. That means whatever the input that you are applying, that will be squared, right? Whatever the input that I am applying, that will be squared. So if I apply x1t, what I will get? So whatever the input that I have applied, that will be squared. If I apply x2t, what I will get? Whatever the input that I am applying, that will be squared. If I apply x1t plus x2t, what I will get? So whatever the input that you are applying, that will be squared. Okay. So how will you open it up? Will you open it in this manner? X1 square plus x2 square plus x1 x2 conjugate plus x1 conjugate x2. Will you open in this manner? No. This we open when there is a mode, right? I hope you remember. In power or in sorry, not in power, in energy we studied it. When there is a mode, we will open mode of x1 square plus mode of x2 square plus x1 x2 conjugate plus x2 x1 conjugate. So when there is a mode, but here there is a simple bracket. So how will you open it up? X1 square t plus x2 square t plus 2x1t x2t. Okay, so that will work only when there is a mode. If there is no mode, so this is how you will be opening it up. Okay, is this equals to the addition of these two? Addition of these two, is this equals to that? Absolutely not. So what does that mean? It is not equals to that. What does that mean? That here additivity fails. So from here only you can see addition of these two is not equal to this, because this will be x1 square t plus x2 square t, but this is x1 square t plus x2 square t plus 2x1 xt, 2x1 t x2 t. So that's why here additivity fails. additivity fails. What about homogeneity? If additivity is failing, it will be non-linear only, but what about homogeneity? So 3x1t if I apply, whatever the input is applied, that will be squared. Whatever the input is there, that will be squared. So what this is coming out to be? 9x1 square t. This is not equals to, input is done 3 times. So output should have also been done 3 times. So this is not equals to 3x1 square t. Both are not equal, that means homogeneity also fails. Homogeneity also fails. If this is also failing, what does that mean? Here we can say that this is non-linear. Try the next one on your own. Try this one on your own. If I apply xt, what happens? Just I will get the conjugate. If I apply x1t, I will get the conjugate. If I apply x2t, I will get the conjugate. If I apply x1t plus x2t, so whatever the input signal that you are applying, that will get the conjugate. Can you open it up? Yes, conjugate can be opened up. A plus B conjugate can be written as A conjugate plus B conjugate, and AB conjugate can be written as A conjugate dot B conjugate. Basically it can be opened up. So here x1t conjugate plus x2t conjugate. So is this equal to the addition of these two? Yes. So here there is no issue with additivity. Additivity is fine. Additivity. So additivity is fine. What about homogeneity? So here I was multiplying with 3, 2, here also 2. Let's multiply with A now. Okay, what I am doing, I am multiplying with A because this is conjugate is there, no? And conjugate has relation with the complex number. So it's not necessary that always you need to multiply with a real number only. You can multiply with complex number as well. So let's multiply with A. So AX1T. If I apply AX1T, so what output I will get? Whatever the input is applied, that will be conjugate. How I can open it up? A conjugate X conjugate T. Now if A was real, then A conjugate would have been equals to A. What I am saying, if A was real, then A conjugate have been equals to A. But what if A is imaginary or it is complex? If it is imaginary or complex, then A conjugate will not be equals to A. Say yes or no? This thing I know, right? This is a very basic thing. Conjugate means plus J will be replaced with minus J. So both will not be equal if A is complex or imaginary. So what does this mean? That this is not equals to A x1 conjugate T. Basically, if your input is multiplied with A, so this should also have been multiplied with A only, no? But this is not happening. This is multiplied with A conjugate. This output is multiplied with A conjugate, and A conjugate is not necessarily equals to A. That means here homogeneity fails. And if one of them is failing, homogeneity fails. If one of them is failing, what does that mean? That means homogeneity fails. What does that mean? That means it is non-linear. Non-linear. Okay. Understood? Let's go to the next one. GT into XFT. You can do it on your own very easily. GT into XFT. So let's try first one. If I apply XT, what will happen? GT will be coming as it is. Whatever the input signal is there, that will come as it is, but T will be replaced with FT. Whatever the input signal is there, that will come as it is, T will be replaced with FT, and it will be multiplied with GT. If I apply X1T, what will happen? The signal will be multiplied with GT. The signal will come as it is, T will be replaced with FT. If I apply X2T, what will happen? the signal will be multiplied with gt. This remains as it is, t will be replaced with ft. If I apply x1t plus x2t, what will happen? The signal will be multiplied with gt, t will be replaced with signal will be multiplied with gt, signal will be multiplied with gt. Whatever that you have applied, that will remain as it is, but just t will be replaced with ft. Just your t will be replaced with ft, right? How you can open it up? gt into x1 t is replaced with ft plus gt into x2 t is replaced with ft. Are you able to understand this point? Signal is multiplied with gt, t is replaced with ft, t is replaced with ft. So what is happening? gt goes inside, so gt into x1 ft plus gt into x2 ft. Is this equals to the addition of these two? Yes. gt into x1 ft, gt into x2 ft. Is this equals to the addition of these two? Yes. So additivity is fine. What about the homogeneity? In homogeneity, what I am gonna do? 3x1t. So gt will be there as it is. Whatever the input that you have applied, in place of t, what you need to put? ft. In place of t, what you need to put? ft. So what I can write it down? 3 gt into, in place of t, what I am putting? ft. 3 into 3 I can take outside, no, 3 is common. In place of t, I am putting ft. So is this equals to the 3 times of this particular signal? If your input is being 3 times, then your output should also be 3 times. Is it being 3 times? Yes. That means here your homogeneity is also fine. That means this is a linear system. So here in place of gt, ft, any random thing could be there, right? And this f of xt we have already seen. Should we see it again? Let's see it again. Second example, b, yt is equals to f of xt. So what is the conclusion here? If you don't do anything with this x, then it is fine. Then it will be linear. Nothing should be done with this x. Then it would be linear. It would be fine. You can just think it in the examination hall. x1 ft would come, x2 ft would come. Then I will add them up. What will happen? gt will be there with both of them. So yeah, addition is fine. What about homogeneity? I will just multiply with the 3. Okay, multiply with 3. 3 can come outside. So yeah, output is being multiplied with 3. So homogeneity is also fine. Additivity, homogeneity, both are fine, linear. You won't have to do all this process in the examination hall. If you get confused, then you can do this process. Otherwise, by the language only you will be able to tell that yes, here additivity is fine. That means it would be linear. Are you getting this point? Right? F of xt. Right? So if I apply xt, what I will get? Whatever the signal is there, that will go inside of f. If I apply x1t, whatever the signal is there, that will go inside of f. If I apply x2t, whatever the signal is there, that will go inside of f. If I apply x1t plus x2t, so whatever the signal is there, that will go inside of f. Is it equals to the addition of these two? Basically, is it necessary that you can open this addition like this? x1t plus f of x2t. No, it is not necessary, right? Not necessarily this can be opened like this. So this is not necessary. That means additivity fails here. Additivity fails. So certainly it is non-linear. Let's check homogeneity as well. If I multiply with 2, what will happen? Whatever the signal is there, that will go inside of f. Can I open it like this? That 2 come outside f x1t? Not necessarily. This is not necessary. So here your homogeneity also fails. So what does this mean? This is your non-linear. Okay, so you don't need to mug up these examples. Only 2 kind of examples will be there. Whatever the example that we have seen, they were based on these two examples only. Let's check that out. What is this? There is a function called conjugation. Basically, it is your function of xt. What is this function? This function is conjugate. So this was your f of xt, and if f of xt is there, non-linear. What was this? Again, the function is there. What is that function? The function is square. You are doing something on xt. If you are doing something on xt, then there is an issue. Keep xt as it is. What is this? There is a sign of -1. Can I call it ft? What is ft? ft is -1, or let's call it gt, because there we have shown by gt. So what is gt? gt is -1. Then x as it is. In place of t, what we are putting? -t. So this is a function of t as well again. So gt into x ft. Is there any issue? What is ft? ft is -t. gt into x ft. gt into x ft. What was that? Linear. So in the examination hall, you don't need to mug up that gt into x ft is linear. In that manner, you don't need to mug it up. You will do there. You will do the analysis there. That first you will apply x1t, x2t, x1t plus x2t. Then you will get to know additivity is fine, homogeneity is also fine. Let's see this example. Here x f3t plus g sin t. So this is again a function only, function of t. So I can write it down this as x of capital Ft. So again this is a function of t only, right? So this is a different function of t. So x of Ft. And what is gt here? gt is 1. I can write it down in this manner. This is equals to gt into x of capital Ft, because small ft is already used here, and gt also I cannot write down. So I will use here capital gt. Capital gt plus x of capital Ft. So what is capital gt? Capital gt is 1. And what is Ft? Ft is this particular thing. So again this is linear. What about this one? This is your gt into x of Ft. What is gt here? gt is 1. What is Ft here? Ft is equals to sin t here. Right? So again it was linear. What is this? This is your again gt into x of Ft. What is gt here? gt is sin t. And what is Ft here? Ft is t only. Again it was linear. What about this one? Here xt plus Ft, a different signal is added. So this is a different kind of category. So with xt, if you add anything, it will be non-linear. Okay. Here I am again writing in big words. With xt, if you add anything, xt plus Ft if you do, this will be non-linear only. So this is a different kind of category. Why it will be non-linear? Because Ft will be added once only, but it should be added twice. So here your additivity fails. Additivity fails. Along with that, homogeneity also fails, because if I apply 2x1t, that means Ft will be directly added, but I want it to be multiplied by 2. So that is not happening. That's why it would be non-linear. Okay. So here also xt plus 5. Here also something is added. Right? xt plus 5. If something is added, it will be non-linear. Here what is the scene? Again it is gt into x of Ft only. So what is gt here? gt is 5. And what is Ft here? Ft is simply t. So it was a linear system. So are you getting the point? Are you able to understand the thing? So again I am saying you don't need to mug up these results, but you should be aware in the examination hall that I should be able to solve these kind of problems. If this is coming, then what you will do? You will see that okay, Ft, or you can say gt into x Ft. So if I apply x1t, no issue. If I apply x2t, no issue. If I add both of them, then this thing will be again added. So no issue, I can take it common. Again it would be added. So additivity is fine. What about homogeneity? Homogeneity, if I multiply my input with 3, so the whole signal will be multiplied with 3 as well. So homogeneity is also fine. That means it is linear. What about this one? I will apply x1t, what I will get? Ln x1t. If I apply x2t, what I will get? Ln x2t. If I apply x1t plus x2t, what I will get? Ln x1t plus x2t. And certainly this is not equals to ln x1t plus ln x2t. So if both are not equal, that means it is non-linear, right? All good? In that manner you will check, or you can directly see that it is f of xt. What is this? F of xt. Here also it is f of xt. What is f here? f is the mode. Here what is f? F is the ln. Here f is mode. What you can check here, but you don't need to think all these things in the examination hall. What you will do, I will apply x1t, x2t, then I will apply x1t plus x2t. Can I open the mode like this? No, absolutely not. That means additivity is failing here as well, non-linear. Similar thing here as well, I will apply x1t, x2t, then I will apply x1t plus x2t. So whatever the input is there, that will come in the bracket of signum. Can this signum be opened like this? Signum x1t plus signum x2t. Can this be opened like this? Absolutely not. So you cannot open it like this. So this is also non-linear. Same goes for under root as well. Under root x1t plus x2t. Can this be opened? Under root x1t plus under root x2t. No. So this is also non-linear. Same goes for u as well. Can it be opened? U of x1t plus u of x2t. No. It cannot be opened like this. Same goes for r as well. Right? What about this one? What about the last one? If only 3txt was given, if only 3txt was given, then it was fine. This would have been linear. Why is that so? I will apply x1t, I will apply x2t, then what I will apply x1t plus x2t. So what I am getting? 3t plus 3t. Yes, so this was with respect to x1t, this was with respect to x2t. So yeah, additivity is fine. What about homogeneity? If I multiply the input signal with 3, so what I will get? 3t into 3xt, and this can be written as 3 into 3txt. So if I multiply my input signal with 3, then my output signal is also multiplied with 3. So yes, homogeneity is also fine. So if only this was there, then it was fine, but it is added with some value. It could be DC value, it could be function of t, it could be anything. But if it is added with that particular value, then it will be non-linear. Or what you can think in the examination hall, it would be non-linear. That you will apply x1t, you will apply x2t. When you apply x1t plus x2t, so in place of xt, what you need to put? x1t plus x2t. But this sin t will come only one time. This sin t will come only one time. 2 sin t will come only one time. But in x1t, 3t x1t plus sin t, it will come once, and 3t x2t plus sin t, it will again come once. So when you add both of them, here 2 sin t was there, here also 2 sin t was there. So when you add both of them, it will become 4 sin t. But here only 2 sin t is there. So again, additivity is failing. This is also non-linear. So this is how I will be checking in the examination hall. Okay, I am not mugging up these results. C also I can write down that yt equals to gt x ft. This is your linear part, right? This is your linear part. But in addition to this, if anything is there, g f h, not h, let's write down alpha t. In addition to this, if anything is there, what this will be? This will be non-linear. What was this? This was also non-linear. And what was this? This was linear. So when you revise it, you just need to see this particular thing. That's it. You will just see this page and everything will be revised. And then you will see these pages, linear, non-linear, everything will be revised. All good? What about the differentiator? So what differentiator does? If I apply xt, what it will do? It will add d by dt. Or you can say it will multiply with d by dt, or basically it will differentiate. If I apply x1t, what will happen? D by dt of x1t. If I apply x2t, what will happen? D by dt of x2t. If I apply x1t plus x2t, what will happen? D by dt of x1t plus x2t. Right? Can this be opened like this? D by dt of x1t plus d by dt of x2t. It can be opened like this, right? So here additivity is fine. Now someone will say that, sir, this is also example of yt is equals to d by d xt. So this can also be example of f of xt, where f is d by dt. Say yes or no. I can write it down in this manner. But here, sir, you said that f of xt is non-linear. It will be non-linear if you cannot open the function like this. But here you can open the function, no? Here I can open the function. In differentiation, you would know the property that you can open the function like this. This we have studied in 11th, 12th classes only. So yeah, I can open the function now. That's why this is additivity is fine. Let's check the homogeneity. Additivity is fine. Let's check homogeneity. 3x1t if I am applying. So dy dt 3x1t. What I can do? I can take 3 is a constant value. I can take this outside. So dy dt x1t. Okay. So is it equals to the 3 times of this? Yes, it is equals to 3 times of this. That means homogeneity is also fine. So what does that mean? That your differentiator is a linear operator. Differentiator is linear operator. Okay. What about the integrator? So try doing it on your own. If I apply xt, what will happen? It will take the integration from minus infinity to t, but it will change the axis. If I apply x1t, what will happen? It will take the integration, changing the axis. If I apply x2t, what will happen? Again, it will do the integration, changing the axis. If I apply x1t plus x2t, what will happen? x1 to plus x2 to d2. And can I open it in this manner? Minus infinity to t x1 to d2 plus minus infinity to t x2 to d2. Right? That means this is equals to addition of these two. So additivity is fine here. Additivity is fine. What about the homogeneity? If I multiply my input with 3 times, so what will happen? Integration will also take like this only, 3 x1 to d2. Okay, so 3 can come outward. So this is equals to, basically, if I call this as y1t, so this is just 3 times of this particular thing. So 3 can come outward. So here this 3 can come outward. 3 can come outward. If 3 is coming outward, then yes, this is equals to 3 times of this particular thing. That means here your homogeneity is also fine. Now I hope no one will have the doubt that, sir, in place of 3 if you put 3t, or in place of 3 you put t only, sir, then t cannot come outward. I cannot put t here. I can either put real number or I can put imaginary number. It cannot be a function of t. When I check homogeneity, I will put a number here. It could be real or complex, but it cannot be a function of t. It cannot be ft. Are you getting this point? It cannot be a function of t. It has to be a constant number. It could be real or imaginary. Whatever you want to put here, that you can put. But no one will say that, sir, here you can put t. No. First thing is that addition, x1t plus x2t, and second thing is that here this number has to be real or imaginary, or I would say it is a constant number. So here when I go back to our first slide, when we studied the basics, so here we studied alpha beta. So these alpha and beta are constant number. Alpha beta are constant number. Okay. So these are the constants. Just like you are our constant subscriber and a constant student as well. So these are constants like you. Okay. Let's see this particular question. This is not the standard integrator, right? This is not standard. Here minus infinity to t square is there. So what do you think? Will it be linear or not? It will be linear only. You can try it on your own. Simple thing again. x1t, x2t. x1t I will apply minus infinity to t square. What this limit will not change with respect to the input. Limit will be minus infinity to t square only. Whatever the input is there, that will be differentiated. Sorry, that will be integrated. So whatever the input is there, that will be integrated. This limit will not change. So whatever the input is there, that will be integrated. So this can be broken into two parts as well. You can open the limits, right? You can open the limits, you will get to know that this is equal to the addition of these two. And what about the 3x1t? If I multiply with 3, then this will also be multiplied with 3 only. Minus infinity to t square x1 to d2. Basically, whatever the input is there, that is being multiplied with 3. So 3 can come outward. So if 3 comes outward, this will come like this. So this is 3 times of this particular thing. What does this mean? That here additivity is also fine, homogeneity is also fine. That means it is linear. So after all these examples, I hope you should be able to understand these kind of things at least. This should have been solved by you. Okay, because here t square doesn't make any impact. Here in place of t square it could be anything. Here I am just writing it is ft. In place of t square it could be any function of t. That doesn't even matter, right? It could be any function of t. That doesn't matter, right? Now let's see this question. So there is a system, first system is there, yt is equals to xt. Then another system is there, yt is equals to x conjugate t. Now both of these systems are added. Basically both of these systems are connected in parallel. So what will happen? From here xt would come, what it will give you? Xt only. Here yt is giving you directly xt. Nothing is doing, nothing this system is doing. Directly it is giving xt only. The system is simply a closed switch. The system is simply a wire. The system is nothing but it is a simple wire. So whatever the input that you are applying, the same output you are receiving. Okay, yt is equals to xt. What this system is doing? This system is doing the conjugate. System 2 is doing the conjugate. And then both are added. So what will be your final output? x1t plus x conjugate t. So this is a new system. A new system is made. A new system is made. And what this new system is saying? That this is your input, this is your output. This is your new system. Okay. So new system is saying that whatever the input that you will apply, whatever the input that you will apply, in the output you will have the same input plus the conjugate input. This is what this new system is saying. So this was a linear system, right? You can directly check. And this is a non-linear system. Now can you comment on this particular system, whether it is linear or non-linear? This is linear or non-linear? Just comment on this. So let's do it. If applied input is xt, what I will get? Stable. If applied input is xt, what I will get? Xt plus x conjugate t. If applied input is x1t, what I will get? x1t plus x1 conjugate t. If applied input is x2t, what I will get? x2t plus x2t conjugate t. If I apply the input x1t plus x2t, what I will get? Whatever the signal is there, that will come as it is. Whatever the signal is there, that will come as it is, plus the signal is there, that will come as it is, plus the signal will be conjugated as well. The signal will be conjugated as well. So can I open it up? Yes. x1t plus x2t plus x1 conjugate t plus x2 conjugate t. So is this equals to addition of these two? Addition of these two. Yes. That means additivity is fine. What about homogeneity? Multiply this with any random number a. Whenever there is a conjugate, I will do this thing only. I will multiply this with any random number a. Okay. So whatever the signal is there, that will come as it is. Along with that, it will be conjugated as well. So how this conjugate will open? A x1t plus this conjugate will open as a conjugate x1 conjugate t. So this is not equals to, you cannot take a common like this, x1t plus x1 conjugate t, right? This is not equals to a times of this particular thing. If it is not equals to a times of this particular thing, that means here homogeneity fails. Homogeneity fails. That means this is non-linear. So from here, what did you get to know? This was a linear system, this was a non-linear system. When you are adding a linear with non-linear, your answer will be non-linear only. So linear plus minus non-linear. You could have subtracted as well. What I told you, negative sign will make no impact. We have seen this example of minus x minus t. So negative sign will make no impact. So if negative sign is making no impact, what does that mean? That linear plus minus non-linear will be non-linear only. Linear plus linear will always be linear. You can take any example. Linear plus linear will always be linear. You can take any example. Let's just say example of linear. Example of linear was x of sin t plus other example of linear. You can take x of e to the power t. X of ft I am taking, or simply I write x of ft. X of ft. So this is also linear, this is also linear. So this complete will be linear only. What you will do? x1 sin t plus x1 ft, x2 sin t plus x2 ft. So whatever the input that you are applying, once t is replaced with sin t, other time the t is replaced with ft. What does that mean? Whatever the input that you are applying, once t will be replaced with sin t, the second time the t will be replaced with ft, and both are added. So if I apply x1t plus x2t, what will happen? Whatever the input that you are applying, 1 sin t, then ft plus x2 sin t plus x2 ft. Right? Is this equal to the addition of the previous ones? Yes. And same goes for 3 times as well. If I find 3xt, what will happen? Whatever the input that you are applying, 3 is a constant number only, so this will be multiplied with 3 only. T will be replaced with sin t and t will be replaced with ft, and both are added. So yeah, it is equal to 3 times as well. So directly you can see that it is linear. So linear plus minus linear will always be linear only. But non-linear plus minus non-linear, you cannot comment. Non-linear, what is the example of non-linear? Sin xt plus e to the power xt. This is non-linear, this is also non-linear, and this is also non-linear only. Completely this will be non-linear only. You can see it. If I throw x1t, then I will throw x2t, then I will throw x1t plus x2t. Will I get the same thing? Absolutely not. So this is non-linear. But what if my signal was something like this? x1t plus sin t, sorry, yt was xt plus sin t and yt was xt minus sin t. So these were the two kind of systems were there. Then I added them in this particular configuration, that both are added. So what I will get? If I add both of them, so my new system will be, this is my new system. New system. This was your system 1. This was your system 1. And this was your system 2. Now new system, what that would be? Just added both of them. That would be equals to 2xt. And what is this? Linear. Right? And the other thing, what is the next example I took? Yt equals to sin of xt. What is this? Non-linear. What is this? This was non-linear, right? Xt added with anything, non-linear. What was this? Non-linear. Non-linear added with non-linear, giving you linear. Here, non-linear added with non-linear. Non-linear added with non-linear is giving you non-linear. So anything could be there. Here what you can see, non-linear added with non-linear. Non-linear added with non-linear is giving you linear. Okay. And here non-linear added with non-linear is giving you non-linear only. So you cannot comment whether it will be linear or non-linear, but here you can comment. So try doing all of these on your own. You can be able to do it very easily. Even part of xt, odd part of xt, conjugate symmetric part of xt, conjugate anti-symmetric part of xt, real part of xt, imaginary part of xt. So try doing all these on your own. You will be able to do it. It is very, very easy. Okay, no need to worry about that. It is very, very easy. You will be able to do all of them. All 6 of them you will be able to do. And then try this one as well and this one as well. Okay, try these 2 questions, and here 3 and 3 6 questions. So try these 8 questions on your own. Okay, so even part of xt. What is even part of xt? Even part of xt is, in basics of signal we have studied all these kind of things. So x of t plus x of minus t divided by 2. Is this linear? Yes. X of minus t, this is linear? Yes. What does that mean? This would be linear only. And you can check by the other method as well. x1t I will apply, x2t I will apply, then x1t plus x2t I will do. Even if it is divided by a factor of 2, that doesn't matter. And then I will multiply 3x1t. So same thing I will get. You can check there as well. Okay, very easily you can check. Next one, odd x1t minus, sorry, xt minus of x minus t divided by 2. So this is the odd part of xt. Again, this is linear. Plus minus doesn't matter. It would be linear only. What about the conjugate symmetry part? What is conjugate symmetry part? xt plus x conjugate minus t divided by 2. Is this linear? Yes. Is this linear? No. This is non-linear. Conjugate is there, no? So it would be non-linear. What about this one? xt minus x conjugate of minus t divided by 2. Linear, but this is non-linear. Now, what do you mean by real part of xt? So we can see it here. So what is, let's just say your xt is at plus jbt. So this is the real part of xt. And just 1 second. This is the real part of xt and this is the imaginary part of xt, right? So if I do x conjugate t, what I will get? At in place of j I will replace minus j. Now if I add both of them, what I will get? If I add both of them, xt plus x conjugate t, what I am getting? 2at, right? And 2 I can take downward, divided by 2. What is this? 80. And what this is equivalent to? Real part of xt. So what is real part of xt? xt plus x conjugate t divided by 2. And if I need to get imaginary part, what I need to do? xt minus x conjugate t. What I will get? 2j bt, right? So what will be my imaginary part of xt? What will be the imaginary part of xt? That would be xt minus x conjugate t divided by 2j. That would be the imaginary part of xt. So this is the real part of xt, this is the imaginary part of xt. So real part of xt is xt plus x conjugate, xt plus, I also forgot, xt plus x conjugate t divided by 2. So all these things you don't need to remember in the examination hall, you can derive it there as well. Like even odd, conjugate symmetry, conjugate antisymmetry, that you will remember. But if you forget real part of xt, all these things you can derive it as well in the examination hall. So what this will be? This will be again non-linear because this is the non-linear part. What about this one? This would be xt minus x conjugate t divided by 2j. So this is just a constant number, that doesn't matter. Linear, but this is non-linear. So total it would be non-linear. Okay. So non-linear, only these are the linear, even part and odd part. This question, this particular question. This is known as segmented signal, you can say, or piecewise defined signal, you can say. Okay. Piecewise defined system, I will say, not signal. Piecewise defined system or segmented system, you can say. So we will use segmented system. Segmented means for t less than 0 it is working different, for t greater than 0 it is working different, or for t less than 2 it is working different, for t greater than 2 it is working different. So for different kind of domain it is working different. So we can call it segmented system. Okay. Segmented system. So is it linear or non-linear? Let's check that out. So what is this part? This part is linear. Say yes or no? X sin t, linear. And what about this part? E to the power t sin t, ft x gt. ft x gt, or you can say gt x ft. Can I write it down in this manner? gt x ft. So this is also linear, or you can say x1t I will apply, x2t I will apply, x1t plus x2t I will apply, and then 3x1t I will apply. So certainly this is also linear. So both parts are linear. This is also linear and this is also linear. So certainly it will completely be linear only. That's it. Right? It will be linear only. For t greater than 0, you get the linear part. For t less than 0 as well, you will get the linear part. So all part is linear. So completely it will be linear. That's it. Right? What about this one? For t less than equals to 2, what is this? Is this linear or non-linear? This is your non-linear. Right? Mode of xt. Is it linear? No. Because x1t I will apply, x2t I will apply, but when I apply x1t plus x2t, then additivity fails. So this is non-linear. What about this one? This is linear. I will apply x1t, I will apply x2t, x1t plus x2t I will apply. In place of t, I will put ln t only. So yes, additivity is also fine and homogeneity is also fine. So yeah, this is linear. So complete part is not linear. If any one of the part is non-linear, then complete signal will be non-linear only. Oh, sorry, not signal, complete system will be non-linear only. Right? One of the part is non-linear, no? So completely it is not linear. So if any of the part is non-linear, then it would be non-linear only. And what if it was somewhat like this? What if the equation was like this? Both parts were non-linear. xt plus sin t, xt plus sin t for t less than equals to 2. Or here I can put 7 and xt minus sin t for t greater than 7. So this part is non-linear and this part also non-linear. So complete function is non-linear. Right? Everything is non-linear. So both part has to be linear, then only completely it will be linear. If one of them is non-linear, then it will be completely non-linear. Okay? One of them is non-linear, then completely non-linear. With the graph, how you can check? Okay? With the graph, how you can check whether it is linear or non-linear. So the graph between yt and xt. What is yt? Yt is the output. Yt is the output and xt is the input. So for a linear system, the graph between output and input is the straight line passing through origin with the same slope. Again I am saying, for the linear system, we will prove it as well. We will see it with respect to example as well. Okay. So for a linear system, the graph between yt and xt, the graph between input and output signal will be a straight line passing through origin with the same slope. Here the slope is m. Here also the slope is m. Slope could be anything, but always the slope is m. So yeah, this is linear. This is your linear. Here initially the slope was m, but here it got changed to 0. Always the slope has to be m and it should pass through origin. Passing through origin, a straight line, it was fine, but here the slope became 0. Here the slope became 0. So what is this? Non-linear. Everything was fine, but again the graph became 0. This is also non-linear. What about this one? Yeah, here the slope is negative. Again it is passing through origin. Yes, slope is negative. Yeah, slope is negative, but always it is passing through origin. Always it is passing through origin, but with the same slope. If here the slope is m, here also the slope is m. So slope is same, line is passing through origin. Yeah, all conditions are satisfied, linear. What about this one? Yeah, passing through origin, but the slope is not same. Here the slope is infinity, here the slope is something different. So this is non-linear. What about this one? Passing through origin, straight line is also there, but here the slope is m1 and here the slope is m2. So non-linear. So passing through origin, a straight line should be there, but with the same slope, linear. Linear. Here slope was m, but again became 0. Slope was m, but became 0. So non-linear. Okay. Let's check some previous examples. One of the example we can check. Let's check this one. Yt equals to 5xt. Can you draw the graph? Yes. Yt equals to 5xt. So slope will be 5. Yt equals to 5xt. Slope will be 5. This is the graph, right? Here one example was there. Yt equals to e to the power xt. What was the scene? Yt equals to e to the power xt. Can you draw the graph between yt and xt? Where you are drawing the graph between yt and xt? Yt and xt. So if xt equals to 0, then what will be the value of yt? When xt is equals to 0, the value of yt would be e to the power 0, that would be 1. When xt is equals to infinity, what will be the value of yt? E to the power infinity, that would be infinity. When xt is equals to minus infinity, what will be the value of yt? E to the power minus infinity, that would be equals to 0. So what kind of graph we are getting? This kind of graph we will be getting. So what is this? This is non-linear again, right? This is non-linear. Forget it. For linear, this kind of graph we should have. Which kind of graph? This kind of graph we should have. Okay, let's see more examples. Let's see the example that I have written here. This example. Yt equals to sin t xt. Is this linear? Yes. We know that this is a linear function. What is this? This is your gt into x of ft. So yeah, I know that this is linear, but let's explain it with respect to the graph. Can I explain it with respect to the graph? Yes. What I am doing? I am drawing the graph of yt versus xt. What I am drawing? Yt versus xt. Yt versus xt. So here for me, sin t is a constant value. Are you getting this point or not? Yt is equals to sin t xt. Now you will say that, sir, xt is a function of t, yt is a function of t, and sin t is also a function of t. So how you can say it is constant? With respect to yt and xt, it is constant for me, no? Are you getting this point? What I mean to say is that if my xt is equals to 0, what will be the value of yt? 0 only. If my xt is equals to 1, xt is equals to 0, yt is 0. xt is equals to 1. If my xt is equals to 1, then what will be the value of yt? That would be equals to sin t. I don't know what is the value of sin t. I don't know about that. If xt is equals to 2, then what will be the value of sin t? Sorry, what will be the value of yt? That would be 2 sin t. Are you getting this point? If I say this is sin t, if I say this value is sin t, so when xt is equals to 1, the value is sin t. When xt is equals to 2, the value will be 2 sin t. When xt is equals to 3, value will be 3 sin t. When xt is equals to minus 1, when xt is equals to minus 1, the value will be minus sin t. When xt is equals to minus 2, the value will be minus 2 sin t. In that manner, the values will keep on going. That means it will be again a straight line only. Straight line passing through origin. And what is the slope here? What is the slope? What is the slope? What do you think? What is the slope? Slope m. 2 sin t minus sin t will be sin t. Divided by 2 minus 1, that would be 1. So what is the slope here? Slope is sin t. So here the slope is sin t. Are you getting this point? To make it a function of t, we need to get another axis. 3 axes has to be there. What I am drawing? I am drawing yt versus xt. I am not drawing yt versus xt versus t. 3 axes are not there. When we drew the complex exponential, what we did there? Real, imaginary, and the axis of t. 3 axes were there. But here what I am doing? Yt, xt, that's it. There is no axis of t. So between yt and xt you are getting a straight line only. So yes, it is again a linear function only, or you should say again it is a linear system only. Okay. So yeah, it is a linear system, and this is how we can define it. The slope is sin t. Linear. Well and good. Okay. So for a system, this particular thing is given that if you are applying as input t, your output is t sin t. what is given, if I am applying an input t, if I applied an input t, my output is t sin t. Okay, so is this system certainly linear? So different guys will say different things here. Let's just say there is one guy, guy 1, guy 1. What he will say that, sir, my yt is equals to t into sin xt. Is this guy wrong? No. He can be true as well, because when you applied xt equals to t, when you applied xt equals to t, what was your output? Output would have been t sin whatever the input is there, t sin t. Yes, it is matching. So one guy is saying that, sir, yt equals to t sin t. What the other guy will say? Guy 2. What he will say? That, sir, yt is equals to xt into sin t. Say yes or no? Because what is xt? Xt is equals to t. So, sir, whatever the input that you have applied into sin t. So this guy is also not wrong. And what the third guy will say? Third guy will say that, sir, yt is equals to xt into sin xt. So whatever the input that you are applying, that will be t, and it will come in the sin as well. So all three kind of systems can give you this particular output. So just by looking at one input only, just by looking at only this one input, you cannot tell whether the yt xt relation will be this, yt xt relation will be this, or yt xt relation will be this. You cannot tell just by looking at one input. If another input was given, let's just say for 2t it was giving you the output of 2t sin t, then you could have written that, sir, yes, it is 2xt into sin t, right? This is how you could have written it, because you could get to know that sin t is becoming constant here as well, here as well. So sin t is remaining constant as it is. So that means if this t was there, that came as it is. That means this 2t was there, this came as it is. So it has to be, sorry, not 2xt, it has to be xt sin t. If two things were given, that if t was there, so t sin t. If 2t was there, so 2t sin t. What does that mean? That input is directly coming here, 2t, 2t. This input is directly coming here, and that is being multiplied with sin t. So here I could have commented that, yes, this is my only possible input output relationship. But here there are three kind of input output relationships possible. Say yes or no. So just by looking at one input, you will never ever comment. In the examination, these kind of questions have come. Okay, that's why I picked this particular question. That I am talking about complete signal system. Whenever you face a question of signal system, you take all kind of cases, all kind of possible cases. Like let's just say if somewhere sign of minus t is written. So this would be the first cases. This would be the first case. The second case would be sign of minus t can be written as minus sin t. So this could be the second case. So you take all kind of cases, and if a particular thing is satisfied with all kind of cases, then only confidently you will mark the answer. Okay, so these kind of questions are asked in signal systems a lot of times, because here a lot of cases are possible. So three different kind of cases are possible. So can you say that it is a linear system? No. Why is that so? Because this guy is saying that, sir, my output input relationship is something like this. Is it a linear system? No, this is non-linear, right? This is non-linear, right? Because this is your gt into f of xt. F of xt you are getting here. If you are getting f of xt, that means what you will do? You will apply x1t, you will apply x2t, then you will apply x1t plus x2t. So sinusoid cannot be opened. Sinusoid cannot be opened, so that's why it is non-linear. What about this one? Sir, yeah, this is linear. And what about this one? This is also non-linear. Because here as well, what you are getting inside, you are getting something. So if you get anything inside, then there is an issue, right? F of xt if you are getting, then there is an issue. F of xt, because f of x1t plus x2t will not be opened as f of x1t plus f of x2t, right? What I mean to say is that f of x1t plus x2t is not necessarily equals to f of x1t plus f of x2t, right? So here this is the case, so that's why it is non-linear. So someone is saying that it is linear, someone is saying that it is non-linear. So you cannot say that is this system certainly linear? No. It is not necessary that this system is certainly linear. It could be non-linear as well. Okay. So in example, what in exam what they will do? They will frame 4 options like this. Okay, and then they will ask which of the system is certainly linear. So people will say that they will ask it in MSQ. So they will think that okay, this is also linear, because in the examination it might happen that someone would say okay, t xt sin t linear. But no, you need to consider all the possible cases. So when I consider all the possible cases, I got to know that non-linear, linear, and then non-linear. Okay, let's solve this question. So the point is, whatever the concept that we have studied for continuous time, that will go with the discrete time as well. Did to same concept is there. Did to exactly the same concept is there. In place of t, you replace n, and exactly everything would be the same. Okay, so even part of xn, x of n plus x of minus n divided by 2. Linear? Yes. Linear? Yes. This will be linear. Conjugate antisymmetry, x of n minus x conjugate of minus n divided by 2. Linear? Yes. This will be non-linear, right? X conjugate of minus n. So x conjugate of minus t. You think in terms of t only. So did to same concept will go with the discrete time as well. So non-linear. Now what do you think? What is this? This is your integrator, right? Or you can say this is summation, kind of integrator you can say. So what you will do? You will apply x1k, or you can say x1n I will apply. So what will happen? K goes from minus infinity to n, x1k. You will apply x2k, k goes from minus infinity to n, x2k. You will apply, then what you will do? You will apply x1k plus x2k. So can you break this summation? Yes, summation I can break very easily. Summation, if there is like 2 plus 3, so separately I can break, no? Summation I can break separately. So this and this will be separated. So additivity is fine. And what about the homogeneity? So you will multiply with 3. So here also it will be multiply with 3. 3 is a constant value, so that can come outward. So homogeneity is also fine. So what does that mean? This is linear, right? So this is similar to integrator. And what about this? This is similar to differentiator. Or you can say that, is this linear? Yes. Is this linear? This is also linear, right? Or you can very simply you can check x1n I will put, x2n I will put, then what I will do? x1n plus x2n. So whatever the n is there, that will come as it is. N minus 1 will also come. So yeah, addition is also fine and multiplication will also be fine. That means additivity is also fine and homogeneity is also fine. So both linear are there, so this will be linear. And what about this one? Will this be linear? Yes, this is integration only, but here the limit is going from minus infinity to any function of n. So no matter whatever the function of n would be written here, you will put x1k, you will put x2k, then you will put x1k plus x2k. This limit could be anything, that doesn't matter. Do you remember this example? Minus infinity to t square x of tau d tau. What we did? x1 tau we put, x2 tau we put, x1 tau plus x2 tau we put. Then what happened? Again it can be broken, and then 3x1 tau I put. So 3 can be taken outside. So same thing I need to do here. x1k I will put, x2k I will put, x1k plus x2k I will put. Again it can be broken, and then 3x1k I will put. So 3 can be taken outward. In that manner I will see that this is our linear system again. Okay. So this is also linear. Although all these are equals to y of n. Okay. All these are equals to y of n. All these functions are equals to y of n. So this is the input output relationship. Y of n is equals to even xn. Y of n is equals to conjugate antisymmetry xn. Y of n is equals to running summation. Y of n is equals to difference. Y of n is equals to running summation. So y of n is equals to these kind of signals. Okay, so input output relation was given and you need to tell linear, non-linear, linear, non-linear. So did to same concept, whatever that we have seen for our continuous time, the same kind of concept we are seeing here for discrete time as well. Well and good, all fine. Okay, So that's it. That's the end of linearity. Next, we need to study about time variant and time invariant. So in this lecture of 2 hours, what we studied? First, we studied that basic concept, differentiation, integration, difference and running summation. And then we studied about linearity. Very simple thing is there in linearity. x1t I will put, x2t I will put, x1t plus x2t I will put, and then I will put 3x1t, 2x1t, and if there is conjugate, then I will take the imaginary part as well. In that manner, I will proceed. Is that okay for you? All good? So yeah, thank you very much. Let's meet in the next lecture. There we will study about time variant and time invariant. Thank you. Hi everyone, welcome to PrepFusion. So in the last video we studied about linearity, right? Now we need to study about time variance, time variant and time invariant system. So forget about the name, let's solve the example. So there is this simple potential divider circuit. We already know what is yt. Yt is equals to 2xt by 3. So this circuit we have already seen. So this example always we are taking. Now what I need to do, I will apply this 5 volt voltage here at the input, then what will be my output? So until 0 volt is there, like for t less than 0, there is 0 volt. So if xt is 0, yt will also be 0. For t less than 0, there was 0 volt only, so yt was also 0. For t greater than 0, what happened? 5 volt was applied. And if xt is 5 volt, then output yt will be 10 by 3, right? Because 5 into 2 by 3. So output y will be 10 by 3 volt. What about this particular input? For t less than 1, xt was 0, so yt will also be 0. For t less than 1, xt was 0, so yt will also be 0. For t greater than 1, xt was 5 volt, so yt will be 10 by 3 again. For t greater than 1, yt will be 10 by 3 volt again. So what do you see here? If this was the input, this was the output. When you shifted the input by 1, your output also got shifted. There was a particular input, you received a particular output. When the input was shifted in the time, the output is also shifted in the time. This is known as time invariance. Time invariance. Time invariant system. Are you getting this point? If input is shifted, output is also shifted. So this is known as time invariant system. All good? Let's see this example. So those who haven't studied network analysis, they will not be able to understand this particular example. So they can skip this example. Those who don't know anything about network analysis. But if you already know the basics of network analysis, then this is a simple RC capacitor circuit. Sorry, RC charging circuit. So here the capacitor will charge. Initially capacitor will have 0 voltage and at steady state it will have 5 volt. So for t less than 0, capacitor will develop no charge. After that it will exponentially charge. After that it will exponentially charge to 5 volt. So this is how the capacitor would be charging to 5 volt, right? So for t less than 0, output was 0, but after that it is exponentially rising to 5 volt. Same goes here as well. Here t is goes to -1. So for t less than -1, everything was 0. But after that the capacitor will charge exponentially, it will charge to 5 volt. At t equals to -1, exponentially it will charge to 5 volt. So what do you see here? There was a particular input, there was a particular output. You shifted the input towards the negative hand side. You shifted the input backward. So your output also got shifted backward. Are you getting this point? You shifted the input backward, your output also got shifted backward. Say yes or no. So if I call this as xt, my output was yt. If I call this, if this is your xt, then what this would be? Xt plus 1. If this is yt, what this would be? Yt plus 1. So you can see that here t is replaced with t plus 1. Here also t is replaced with t plus 1. Same thing happened here as well. If I am calling this as xt, this is my yt. If I call this as xt, what this would be? T minus 1. Right? T minus 1. So what this would be? Yt minus 1. So here this is replaced with t minus 1. So this is also replaced with t minus 1. So this is the meaning of time invariant system. Okay. So we are not writing down the definition, but we are understanding with respect to the example. Because no one will ask you the definition. You need to explain with respect to the example that sir, this is the time invariant system. If I am shifting my input, my output is also being shifted in the same manner. Okay, let's see more example. Let's see this example. Yt is equals to x mod of t. Okay, x mod of t. So I will tell you the procedure that how to check. What I am doing, I am telling you the procedure that how will you check the time variance or invariance. So what is the input applied? Xt. If I apply input xt, what will be the output? X mod of t. Now in the second time, what I will do, in place of t, what I will put? T minus t naught. In place of t, what I need to put? T minus t naught. So in place of t, I need to put t minus t naught. In place of t, what I need to put? T minus t naught. And secondly, what I will do, in the bracket of x, listen to my words very carefully. In the bracket of x, I will subtract t naught. What is the first task? That in place of t, wherever you see the t, you put t minus t naught. Wherever I see the t, I will put t minus t naught. And the second task is, in the bracket of x, I will subtract t naught. Are both of them same? Both not same. And if both are not same, that means it is time variant system. Okay, time variant system. So this is how you will be checking in the examination. Let's see more examples. Yt equals to x square t. So if I apply xt, what I will get? X square t. What is the first task? Wherever you see t, you put t minus t naught. Wherever you see t, put t minus t naught. And second task is, in the bracket of x, what is this? This is actually x t whole square, right? So what is the second task? In the bracket of x, you put just a minus t naught. In the bracket of x, you need to subtract t naught. Here what did I do? In the bracket of x mod of t was there. So in the bracket of x, I just subtracted t naught. Both are different thing. Here in the bracket of x, what I am doing, I am just subtracting t naught. Are you getting this point? First task is, in place of t, you put t minus t naught. And the second task is, in the bracket of x, you subtract t naught. Are you getting the same thing? Yes, both are same. What does that mean? It is time invariant system. And this was time variant. Are you able to understand? Let's see more examples. When we see more examples, it will be clear to you. Okay. So applied input is xt. What will be the output? X sin t. What is the first task? Wherever you see t, in place of that you put t minus t naught. Wherever you see t, in place of that you put t minus t naught. And the second task is, in the bracket of x, simply put minus t naught. In the bracket of x, simply put minus t naught. Are both of them same? Both are not same. If both are not same, what does that mean? It is time variant. Look, there is a lot of confusion with a lot of students in this particular process, even in the linearity as well, even in the time variance and invariance as well. So if you just follow the procedure that I am telling, there would be no confusion at all. First task, in place of t, you put t minus t naught. Second task, in the bracket of x, just put minus t naught. That's it. Okay. E to the power xt. Whatever the input you apply, output will be e to the power xt. What is the first task? Wherever you see t, put t minus t naught. Wherever you see t, put t minus t naught. This is the first task. And the second task, in the bracket of x, you put just simply minus t naught. Whatever that is there, that will remain as it is. In the bracket of x, sin t was there, sin t remains as it is, just minus t naught. In the bracket of x, there was t, just minus t naught. In the bracket of x, there was mod t, just minus t naught. Same thing you need to do here. In the bracket of x, what is there? T, just t minus t naught. Are both of them same? Yes. That means it is time invariant. So this is how we will be solving. Mode of xt. What is the first task? Wherever you see t, put t minus t naught. Wherever I see t, put t minus t naught. Second task, in the bracket of x, put minus t naught. In the bracket of x, whatever t is there, whatever the thing is there, that will remain as it is. Just another t naught I need to write down. Are both of them same? Yes. Both are same. That means it is time invariant. like this. This is time invariant. Try this one. X ln t. Okay, X ln t. Two things you need to do. Wherever you see t, put t minus t naught. Wherever I see t, put t minus t naught. This is the first task. Second task, in the bracket of x, whatever that is there, that remains as it is. Just minus t naught you need to add. Are both of them same? Not same. They are not same. That means it is time variant. Okay. So this is the only process you need to follow. If you just follow this process, your answer will never be wrong. Okay. In place of t, you put t minus t naught. In the bracket of x, you put just minus t naught. Check both of them are same or not. If both are same, that means time invariant. If both are not same, time variant. We can check this example as well. Yt equals to 2xt by 3. So how will I check? Two process I need to do. Wherever I see t, I will put t minus t naught. And second process is, in place of t, in the bracket of x, whatever that is there, that remains as it is. Just minus t naught I need to put. What is this? Both are same. And if both are same, that means time invariant. And by the example also we can see it. Okay. So in that manner we can proceed. Let's see more example. X of minus t. X of minus t. Right. So x of minus t is the output. So what is the first task? Wherever you see t, put t minus t naught. Wherever I see t, in place of that I will put t minus t naught. So how I can reduce it? Minus t plus t naught. This is the first task. What is the second task? In the bracket of x, whatever that is there, that remains as it is. Just minus t naught. Are both of them same? They are not same. And if they are not same, what does that mean? Time variant. Here also it was time variant. Here it was time invariant. That is the other case. So in that manner we need to check. I hope it is being clear to you. Right? So time variant. Conjugate. X conjugate t. First task. Wherever you see t, put t minus t naught. Second task. Whatever that is there, that remains as it is. But in the bracket of x, you need to just add minus t naught. Both of them same. What does that mean? Time invariant. Xt plus ut minus 2. So what I need to do? Again the same thing. What is the first output? If I apply xt, output is xt plus ut minus 2. So first task, wherever I see t, I will put t minus t naught. So wherever I see t, in place of that I will put t minus t naught. Wherever I see t, in place of that I will put t minus t naught. And what is the second task? Only in the bracket of x, you just need to subtract t naught. Only in the bracket of x, you just need to subtract t naught. Only in the bracket of x, not in the bracket of u. Only in the bracket of x you need to do this process. In the bracket of x, you just subtract t naught. That's it. Not in u. So are both of them same? Not same. What does that mean? Time variant. Sine of xt. What do you think? What will be the answer? Sine of xt. Time variant or invariant? It would be invariant as well. It would be time invariant. Why is that so? Sine of xt. Wherever I see t, I need to put t minus t naught. Wherever I see t, I need to put t minus t naught. And what is the second task? In the bracket of x, what I am saying, in the bracket of x, whatever that is there, that remains as it is. Just I need to subtract t naught. Not in the bracket of sine. In the bracket of x, whatever that is there as it is, just I need to subtract t naught. Are both of them same? Yes, both are same. What does this mean? Time invariant. So I hope you are getting the idea here what is happening. Right? Sin t e to the power xt. Sin t e to the power xt. So try doing it on your own. Again, very simple thing. Simple output I will write. Although I don't need to write this thing, sin t to the power xt in the examination hall. In the examination hall, I will be directly going with the process. But here, for the notes purpose, I am writing it e to the power xt. So wherever I see t, first task, wherever I see t, I will put t minus t naught. Wherever I see t, in place of that I will put t minus t naught. Second task, in the bracket of x only. Here sin t, nothing. A to the power. In the bracket of x, in place of t I will put, sorry, in the bracket of x, whatever that is there, that remains as it is. Just I need to put minus t naught. In the bracket of x, whatever that is there, that remains as it is. Just another minus t naught I need to put. Are both of them same? Not same. Both are not same. And both are not same. What does that mean? It is time variant. Right? So this is time variant. This was time invariant, time variant. So in that manner you can see. So what do you think? What will be the answer of f of xt? F of xt. So what is the first task? In place of t, what you need to put? T minus t naught. And what is the second task? Whatever inside the x, in the bracket of x, whatever that is there, that remains as it is. Just another t naught you need to add. So are both of them time? Are both of them same? Yes. That means f of xt is time invariant. Very simple process, very easy. gt into f of xt. gt into f of xt. First task is, in place of t you put t minus t naught. What is the second task? In the bracket of x only you need to do the change. So gt remains as it is. F in the bracket of x. In the bracket of x, whatever that is there, that remains as it is. Minus t naught. Are both of them same? Not same. Both are not same. What does that mean? Time variant. G of xt plus ft. First task. All these things you can do on your own. What is the first task? In place of t I need to put t minus t naught. In place of t I need to put t minus t naught. Second task. In the bracket of x, whatever that is there, that remains as it is. Just another t naught I need to subtract. Both of them are not same. That means it is time variant. Okay. Time variant. This is also time variant. Time variant. What about this one? First task is, in place of t you put t minus t naught. And second task, in the bracket of x, whatever that is there, that remains as it is. Minus t naught. ft was there, ft remains as it is. Minus t naught. Are both of them same? Not same. What does that mean? Time variant. So this is the process. If you follow, then there is no one who can stop you in getting the correct answer. Otherwise, it becomes very confusing for a lot of students. They don't even know what they are doing. Sometimes they will subtract f of t minus t naught, then they will do f of t minus t naught here as well. Simple thing is, first, wherever you see t, put t minus t naught. Second thing, in the bracket of x, whatever that is there, that remains as it is. Just subtract t naught. If both are same, time variant. Sorry, if both are same, time invariant. If both are not same, that means time variant. Very simple process. Okay. What about the differentiator? What is the first task? Wherever I see t, I will put t minus t naught. Now, if you look closely, what is the value of dt minus t naught? Can I write it down in this manner? dt minus dt naught. T naught is a constant value, right? T naught is a constant. You can do a shift by 1 minus 1, 2 minus 2, 1 by 2 minus 1 by 2. So t naught is a constant. That means what this will be? This will be 0. So dt minus t naught can be replaced with dt only. So this is actually dt only. dy dt. So this is what we got. And what is the second task? The second task says that everything remains as it is. Just inside the bracket of x. Just inside the bracket of x, whatever that is there as it is, just minus t naught you need to do. Are both of them same? Yes. Both are same. That means it is time invariant. Time invariant. What about the integrator? This is a good example. You do it on your own. So what is the first task? In place of t, I need to put t minus t naught. Not in place of tau. In place of t, I need to put t minus t naught. Right? And what is the second task? Whatever that is there, that remains as it is. In the bracket of x, whatever that is there, that remains as it is. Just in the bracket of x, you need to add another t naught. Are both of these things, are both of them same? Actually, they are same only. Both are same only. Why is that so? Let's try it out. Can I put t minus t naught equals to alpha? So what will be your 2? 2 will be equals to alpha plus t naught. What will be your d2? d2 will be equals to d alpha, right? d2 will be equals to d alpha. Can I interchange the limit now? If tau is equals to, what is the limit? Limit is of tau. So when tau is equals to minus infinity, at that time alpha will also be equals to minus infinity. And when tau is equals to t, at that time alpha will be equals to, when tau is equals to t, alpha will be equals to t minus t naught. T minus t naught, right? So what I will get? I am just continuing this process. So what I am getting now? Alpha limit is going from minus infinity to t minus t naught. T minus t naught. X of, in place of 2 minus t naught, what I am putting? Alpha. In place of d2, what I am putting? d alpha. This is what I am getting. Now alpha can be replaced with 2 again. What I am doing? Alpha is replaced with 2 again. That means d alpha will be equal to d2. So minus infinity to t minus t naught, x of 2 d2. So what you are seeing? This thing, this particular thing, minus infinity to t minus t naught, x of d2. And here, this was the first step, this particular thing. Both are same only. Both same. What does that mean? It is time invariant. So standard integrator, that means running integrator, standard running integrator and standard differentiator, both are time invariant. Both are time invariant. And both were linear as well, right? Both were linear as well. If you remember by the last lecture, they were linear as well. Shall we check the linearity of last all, or you can do it on your own? Linearity I have already told. This will be non-linear. Will this will, what this will be? This will be linear. This will be non-linear. This will be linear. I will be directly writing on the results. I have given 2 hours for linearity and non-linearity. You should be able to do it. Here some function is added, so certainly it will be non-linear. X of ft, gt of x of gt into x of ft is always linear. This is always linear. F of xt, this will be always non-linear. Yeah, in some condition it can be linear for integrator and differentiator. So, but here random function f is there, so non-linear. This is linear. Here it was non-linear. And this is linear. For rest of the examples, all these examples will be some cases of these examples only. So you can write down on your own, right? This will be non-linear, or let me write it down. This will be non-linear only because e to the power xt is there, so non-linear. What about this one? Again, this is non-linear. What about this one? Some function is added, so again non-linear. What about this one? This is linear. This is x of ft, so this is linear. What about this one? This was non-linear. Non-linear, linear. What about this one? This was also non-linear. What about this one? This was linear. This was linear. What about this one? This was non-linear. What about this one? This was linear. And what about this one? This was non-linear. Right? So all these examples we have already seen about linearity, non-linearity. What about this one? This was linear, right? If you remember, no matter whatever the function is there, this was linear. But will it be time variant or invariant? So let's check out. What is the first task? In place of t, you need to put t minus t naught. In place of t, you need to put t minus t naught. X of 2 d2. And what is the second task? Rest all remains as it is. In the bracket of x, you will put t minus t naught. Right? In the bracket of x, you just need to add t naught. So will you get the same thing? There is no chance you will get the same thing. What I mean to say is that again I can do this process, that t minus t naught I am putting equals to alpha. So d tau will be equals to d alpha. Where will the limit go? Limit of alpha will go from minus infinity to, when tau is equals to t square, so limit will go from t square minus t naught. Say yes or no? When tau is minus infinity, alpha will also be minus infinity. When tau is t square, alpha will be t square minus t naught. Alpha will be t square minus t naught. So this will be the limit. So from minus infinity to t square minus t naught, x of alpha d alpha we are getting. Or what I can do, minus infinity to t square minus t naught, alpha can be replaced with 2 as well. So this particular thing and this particular thing, both are different. What does that mean? It is time variant. So it was linear, but it is time variant. So if there is a function of t here, then there would be issue, right? If there is a function of t, if it is not directly t, then there is, if it is directly t, then it is fine. Simple integrator, a standard integrator is a linear system. Okay, sorry, linear and time invariant system. But if there is a function of t, then there could be some issue. Okay. Segmented system, basically it is broken into some, for t greater than 0 it is xt, for t less than 0 it is minus of xt, right? So will it be linear or not? Is it linear or non-linear? It will be linear only, right? What is this? This is linear. And what is this? This is also linear. So it will be linear only. Or you can check as well. I will apply x1t, I will apply x2t, then I will apply x1t plus x2t. Again, both will be added. In that manner, it will go. So it will be linear only. There is no doubt about that. What about the time invariant and variant? So what is the first task? First task is, wherever you see t, put t minus t naught. Wherever you see t, put t minus t naught. Wherever I see t, put t minus t naught. So what is the final answer we are getting? X t minus t naught, t greater than t naught, and here x t minus t naught, t less than t naught. So this is what we are getting, right? And what is the next task? Nothing will change, just in the bracket of x, whatever that is there, that remains as it is. Just minus t naught I need to add. In the bracket of x, just minus t naught I need to add. This will not change now, right? Only in the bracket of x there will be changes. So are both of them same? Are these two same? Although these are same. Here there will be a negative sign as well. Sorry. Here there is a negative sign as well. So these are same actually. These values are same, but here there is a difference. So they are not same. It will be time variant only. So segmented system will be time variant always. Segmented system will be time variant. Why is that so? Because here there will be a term of time, and that will make t minus t naught. So it will be changing it. And in the second process, in the second task, I will not change it. In the first task, it will always change. Say yes or no. In the first task, in place of t, I will put t minus t naught. So it will always change. But in the second task, this will not change. So segmented system will be always time variant. But I am not writing this in theory. And you should also not write it, because what if in the examination hall they ask this question? So you will see, okay, segmented system, time variant, all good. Segmented system means time variant. This is what you will do in the examination hall, because sir told us that segmented system means time variant. But here it was defined with respect to t. Now this is defined with respect to xt. So take your time and let me know whether it is time variant or invariant. Also let me know whether it is linear or non-linear. Two things you need to let me know: time variant, time invariant, linear, non-linear. Take your time, whatever that you know, whatever that you have studied in last 2.5 hours for this particular chapter, that is basics of system. So apply all these things and let me know the answer. So let's start. You would have done it. What is the first process? In place of t, you need to put t minus t naught. In place of t, you need to put t minus t naught. In place of t, you need to put t minus t naught. In place of t, you need to put t minus t naught. And in place of t, you need to put t minus t naught. Rest all remains as it is. And what is the second task? Second task, what is the second task? In the bracket of x, you just need to do the change. In the bracket of x. So whatever that is there, that remains as it is, just minus t naught. Whatever that is there, that remains as it is, just minus t naught. Whatever that is there, that remains as it is, just minus t naught. Whatever that is there, that as it is, just minus t naught. So are both of them same? Both are same. So is it time invariant or time variant? This is time invariant. So segmented system is always time variant. That statement is wrong. Segmented system, or you can say piecewise defined system, that is always time variant. That statement is wrong. That's why we did not write it in the statement, because this classification you need to check. The classification is done. Here the segmentation is done with respect to t, but here the segmentation is done with respect to xt. So scenes are changing here. So better in the examination hall go by the process, because there will be only one question. So go by the process. Replace t with the t minus t naught. In the second one, just replace in the bracket of x, whatever that is there, that remains as it is. Rest you just need to add minus t naught. That's it. Just follow the process. If both are same, then time invariant. If both are different, then time variant. What about linearity? You will say that, sir, this is linear, and sir, this is also linear. So whole system is linear. Wrong. That is wrong. Why is that so? What do you think? Can you draw the graph of this particular function? Yt versus xt graph I need to make, right? Yt versus xt. Yt versus xt. So when xt is greater than 0, yt is equals to xt. When xt is greater than 0, where will be xt greater than 0? Here. When xt is greater than 0, yt equals to xt. So this kind of graph we will get. Right? And when xt is less than 0, xt is less than 0, yt equals to minus xt. The slope is negative. So if I make the graph like this, then it would be positive slope. But I need to make a negative slope. Negative minus 1 slope. So this is how the graph will go. So this is the graph between yt and xt. Did you understand this point? If xt is greater than 0, then yt equals to xt. If xt is less than 0, then yt equals to minus xt. So basically here yt equals to mod of xt is given, nothing else. Yt equals to mod of xt is given. If this was given directly, then you could have said that, sir, it is non-linear, and sir, it is time invariant as well. Because yt equals to mod of xt, you will put t minus t naught, and then in the bracket of x you will subtract t naught. So yeah, directly here it is seen, but when I made it segmented, then there is an issue for you. Then you couldn't see it. So this is the actual graph. Is this linear? Absolutely not. This is non-linear. So here you could have applied that particular concept, that, sir, if both are linear, then whole system will be linear only. Why is that so? Because segmentation is done with respect to t. So if this is linear, then it would be linear only. But when the segmentation is done with respect to xt, at that time you will draw the graph. When the segmentation is done with respect to xt, at that time you will draw the graph. Is that clear to you? All good? Okay. So this is how you will be solving in the examination. So always segmented wide question is coming. If segmented systems are coming, then what you need to do, you need to have some patience there. For time variancy, you check in this process, and for linearity, you draw the diagram, and you will be able to tell. Okay, so it is non-linear and time invariant, and this was linear and time variant. All good? All these examples you will do on your own. Okay, I am leaving it up to you. So do it. All these examples you should be done on your own only. This one 5th, and then this is the 6th one. After that, this also you will do. 1, 2, 3, 4 examples are there. Then fifth example is there, and then sixth, seventh, eighth, and some important points would come after. Yeah, so these 7 examples are left in this particular chapter. So do it on your own, and then we will proceed to our next particular topic. Okay, yeah. Yeah, welcome back. So actually in the previous part of the video, I just checked that mic was not connected. So the sound did not come that good. But now the mic is connected, so sound would come fine from now onwards. Okay. So I hope you would have tried this one. What is even part of xt? X of t plus x of minus t divided by 2. So was this linear? Yes. Time variant or invariant? Time variant. Why is that so? Because in place of t you will put t minus t naught. So this will become minus t plus t naught. So because of this minus sign there is an issue. Because of this minus sign it will become minus t plus t naught, but when you subtract t naught in the bracket of x, then it will be minus t naught. So it will become time variant. I hope you would be able to do this particular thing. So this is the time variant system. So it will be completely time variant only. What about odd part of xt? X of t minus x of minus t, x of t minus x of minus t divided by 2. Was this linear? Yes. What about time variancy? Time variant only. Why is that so? Because minus sign will not make any impact. X of minus t is there, that is doing all the problem. So everywhere, who is doing the problem? The problem is done just because of this minus t. Because in place of t you will put t minus t naught. So this will become minus t plus t naught, and that is causing the problem. Minus t plus t naught, that is causing the problem. So this was non-linear. Along with that, it is time variant as well. What about this one? The same thing. This was also non-linear. Along with that, sorry, here there will be negative sign. Time variant. What about real part? So this was the real part, right? So here there is no minus t. So this is also time invariant. Here this is also time invariant. So yeah, this was non-linear for sure because of the conjugate, but this will be time invariant. Why time invariant? Why it is time invariant? Because in place of t you will put t minus t naught, and then in the bracket of x you will just subtract minus t naught. So it would be all okay for you. Both will be same only. So it will be time invariant. Same goes for this one as well. What is imaginary part of xt? That is this particular thing, right? So because of the conjugate it is non-linear, but it will be time invariant only. Okay. So getting started with linear, time variant, linear, completely linear, linear, non-linear, non-linear. Because of the conjugate it is non-linear. Here time variance is there because of minus t, minus t, minus t, but it will be time invariant because of t only. Time invariant. All good. Very simple examples. What about this one? Linear, non-linear, time variant and time invariant you need to tell. So first example, will it be linear or non-linear? You will put x1t, you will put x2t, then you will put x1t plus x2t. So yeah, this is a linear operator, but something is added, some function is added, so that will make it non-linear. And you can check as well, additivity will fail, because in x1t plus x2t, ln t will be added only once, but we need it to be added twice. So this is non-linear. What about the time variancy? It will be time variant. Why is that so? Why it is time variant? Because in place of t, what you will put? T minus t naught, right? So ln t minus t naught will also be done. In place of t, you will put t minus t naught. So ln t minus t naught will also come. But in the second task, in the second case, what you will do? Only in the bracket of x, you will put t minus t naught. Only in the bracket of x, whatever that is there, just minus t naught you will put. So because of that, both will not be same. That's why it is time variant, right? What about this one? This we have already seen. It was linear and time variant as well. Why time variant? Because in place of t, you will put t minus t naught, and then whatever that is there in the bracket of x, that remains as it is, just minus t naught you need to add. So both will be different, so it is time variant. What about this one? This was linear? Yes, it was linear, right? Because this is gtx of ft. So yeah, this was linear. Time variant or invariant? This will be also time variant. Why time variant? Why it is time variant? Because in place of t you will put t minus t naught, but in the second task only in the bracket of x you will put minus t naught. So both will be different, so time variant. What about this one? Was this linear? Yeah, this is a standard summation, right? So this is a standard summer circuit, or you can say you are doing the running summation. So for the running summation it was linear only, or you can check as well, x1k you will put, x2k you will put, then x1k plus x2k both can be separated, and then you will put 3x1k. So that can also, 3 can also be taken outward. So this was linear. What about time invariancy? So that you can check. What you will do? The first task is, in place of n, this is the first task. In place of n, I will put n minus n naught. Right? And what is the second task? In the bracket of x, I will put n naught. Right? In place of n, wherever I see n, I put n minus n naught. In the second task, what did I do? In the bracket of x, whatever that is there, that remains as it is, just minus n naught I need to put. So are both of them same? Yes, both are same only. Why is that so? Let's check. What I can do? X minus n naught I can replace with p. Okay. So this limit is of k. This limit is of k. So if k is infinity, k is minus infinity, then p will also be minus infinity. And if k is n, then what will be p? P will be n minus n naught. P will be n minus n naught. So what I can do? P is going from minus infinity to n minus n naught x of p. And p again I can replace with k. So again p I am replacing with k. So k goes from minus infinity to n minus n naught x of k. So basically you do the shift here or you do the shift here, both are the same thing. If I need to kill this shift, then I need to bring this shift here. So if I kill this shift, basically minus n naught is gone. So that minus n naught is reflected here. Or if I need to kill this minus n naught, then this minus n naught can be reflected here as well. So both are the same things. So this thing, so this and this both are same. What does that mean? It is time invariant. And you can relate this example with the example of integrator as well, because in our continuous time, standard integrator was time invariant. So this is also time invariant. What about this thing? Dyt by dt sin t xt. So from here what I can write down? Yt is equals to minus infinity to t sin t xt, or sorry minus infinity to t sin to x to d to. This is fine, right? So let's check the linearity. Can you check the linearity? What you will do? You will put x1 t, sorry, you will put x1 to, then you will put x2 to, and then you will put x1 to plus x2 to. So I will directly put x1 to plus x2 to. If I put x1 to plus x2 to, what I will get? Sorry, at the input what I will put? If my input is x1t plus x2t, then what will be the output I will be getting? Minus infinity to t sin to x1 to plus x2 to d to, right? So minus infinity to t sin to x1 to dot d to is also there, plus minus infinity to t sin to x2 to d to is there, right? So this is the output with respect to x1 to, this is the output with respect to x2 to. That means additivity is followed. Additivity is followed, right? Additivity is fine. What about homogeneity? So you will put a 3x1t here. If I put 3x1t, what will be the output I will be getting? Minus infinity to t sin 2 into 3x2 d2. Here what I can do? I can take 3 common. So 3 can come outward. So this is the 3 times of x12, 3 times of this particular thing. That means homogeneity is also followed. So what is this? This is linear. So in the examination hall, if nothing clicks, go by the basic definition, nothing else. Just go by the basic definition. So this was our basic definition. We checked that linearity and homogeneity both are fine, linear. What about time variancy? So what is the first task? In place of t, you need to put t minus t naught. Or let's do it on the next page only. What I am checking now, I am checking time variance or time invariant. So In place of t, I need to put t minus t naught. In place of t, I need to put t minus t naught. Sin tau x tau d tau. Right? And in the second one, only in the bracket I need to do the change. Only in the bracket of x I will do the change. Are both of them same? Absolutely not. Both of them are not same. What I can do is that I need to make this as it is. So what I will do, this I can put as alpha. So d tau will be d alpha, and the limit you can check. If tau is minus infinity, alpha will also be minus infinity. If tau is equals to t, alpha will be equals to t minus t naught. So yeah, limit is becoming same. Till this point I am fine. But what will happen to sine? In the sine, tau was there, angle was tau, but here the angle will become alpha plus t naught. And here this will become alpha only, d alpha. Now alpha can be replaced with tau again. So alpha can be replaced with tau again. So sine of tau plus t naught into sine tau d tau. So this particular thing and this particular thing, are both of them same? Are both of them same? Sorry, this really sorry. This was x of alpha. Really sorry. In t minus t naught, this was alpha. This will be x of tau. So x of tau is same. D tau is same. Minus infinity to t minus t naught, minus infinity to t minus t naught. This is same. Sin tau, in place of sin tau, what we are having? Sin tau plus t naught. So both are not same. That means it is time variant. So what this came out to be? Time variant, and this was your linear. So this is how good examples can also come in the examination hall. You just need to check by the process. Just believe in the process. It will not take much time there. In the examination hall, you will directly get to know that, okay, first I will, in place of t, I will put t minus t naught. And in the second task, just in the bracket, I will subtract minus t naught. So both will certainly not be same time variant. Without even doing the calculation, you will be able to write down the answer. Here also you will see, okay, x1 tau plus x2 tau. Additivity is fine. 3x1 tau, homogeneity is also fine. Linear. So linear and time variant. Next one is maximum of 0 and xt. Maximum of 0 and xt. I hope you know the meaning. Like if I say maximum of 0 and 4, what is the answer? 4. Maximum of 0 and minus 2, what is the answer? 0. What is the maximum value between 0 and minus 2? That is 0. What is the maximum value between 0 and 4? That is 4. So this is the meaning of this particular function. Maximum of 0 and xt. So let's just say this is the graph of my xt. Assuming that this is the graph of xt. Just a random graph I am making. Just a random graph I am making. This is the graph of xt. So what do you think? What will be the graph of it? The graph of it would be somewhat like this. That maximum of 0 and xt. So in this particular range, xt is higher. So what will be the answer? Xt only. So whatever the graph of xt, we are getting the same thing. But after that, xt is negative. So between 0 and xt, who is higher? 0 is higher. So after that, everything would be 0. Now in this particular range, xt is negative. Xt is negative. So which is higher? 0 or xt? 0 is higher. So in this particular range, your answer would be 0. But from here, xt is positive. So which is higher? 0 or xt? Xt is higher. So this would be the graph. So this kind of graph you will be getting. This will be the graph of it. So just I am telling you the meaning of maximum of 0 and xt. I hope you understand the meaning of 0. Maximum of 0 and xt. Okay. So this is the meaning. But let's check. What we will check? Linearity we will check first. So what I am gonna do? First I am gonna throw x1t. What I will get? Maximum of 0 and x1t. Then I will throw x2t. What I will get? Maximum of 0 and x2t. Then what I will throw? x1t plus x2t. What I will get? Maximum of x1t plus x2t. Now can you break it down? Basically, is this equals to the addition of these two? Absolutely not. You cannot say that, sir, it would be equals to maximum of 0 and x1t plus maximum of 0 and x2t. This would be the worst possible way if you say it. That is absolutely wrong. This is wrong. Right? You cannot say it. Why you cannot say it? Let's just take an example. x1t is, let's just say it is 4, okay, and x2t, let's just say it is -6. So what will be the answer here? For the first case, x1t I am saying this is my x1t and this is my x2t. So here what will be the answer? 4, and here what will be the answer? 0. Next, what I am throwing? x1t plus x2t. That means I am throwing 4 minus 6. 4 plus minus 6. That means I am throwing -2. So maximum of 0 and -2. What will be the answer? My answer will be 0. But what this guy is saying? 4. Here the answer was 4 plus here the answer was 0. So your answer should be 4. This guy is saying that your answer should be 4, but your actual answer is 0. Both are not equal. By a random example, you can check. 0 and 4 I put. My answer was, for first case, my answer was 4. For the second case, my answer was 0. Then in the third case, I put 4 minus 6. That means -2 I put. So 0 and -2, which is maximum? 0 is maximum. So my answer is 0. But this guy is saying that answer should be 4 plus 0. That means 4 should be the answer. But that is wrong. So what does that mean? Here, linearity is not followed. Linearity is not followed. So it is, sorry, here additivity is not followed. Additivity is not followed. Additivity is not followed. That means it is non-linear. What about time variancy? What about time variancy? Very easily you can tell time variancy. What is the task that I told you? First task is, in place of t you put t minus t naught. And what is the second task? Wherever you see x in the bracket of that, whatever that is there, that remains as it is, just you need to subtract t naught. Are both of them same? Yes. What does that mean? Time invariant. So non-linear and time invariant. Did you understand this point? Right? In place of t you put t minus t naught. Secondly, whenever, what is the second thing? Wherever you see x in the bracket of that, whatever that is there, that remains as it is, just you need to subtract t naught as well. Are both of them same? Yes. That means time invariant and non-linear. So non-linear and time invariant. This was asked in GATE examination only. I don't remember the year, but this is a GATE PYQ only. So a very good question. So this is how we will be solving it. Like some people are making some graph, some people haven't even given the solution. So different ways are there, but actual concept we know how we will solve in the examination. Okay. So yeah, these kind of the PYQs are there which are actually good, but not solved correctly in any PYQ book. So this is what I say. All PYQ books are same. These kind of questions in some PYQ books you will not even find it because they don't have the solution. And whenever you find, like, solutions are wrong. So that's why I say all the PYQ books are same. Someone would say this book is good, that book is good. All are copy of each other, nothing else. All PYQ books are copy of each other. I am having the PYQ books of all coaching institute here. All the coaching institute, whatever that are available on market, all PYQ books I am having. And if some solution is wrong in one book, it is wrong everywhere. Okay. So I don't know who is the parent book, but whichever is the parent book, they are just simply copying from there, nothing else. So all PYQ books are same. Whatever that is wrong in PYQ books, that we will be solving in terms of assignment or in our lecture series only. So you don't need to worry about the wrong questions, or you don't need to worry about the good questions. Good questions will be in our class note only. Only the decent one, which you should solve on your own, that I will be leaving you for you. Rest good questions, if you need to solve, then our test series. In our test series, I personally will frame questions. So there you will find the level of questions very, very good. Okay. The way we are dealing all these things, even tougher problem from these concepts I will frame. So that is there in our test series. I am not promoting our test series here. If you want to purchase, you can purchase. I am just telling it. Okay. Yeah. Let's go to the next one. Yt equals to x xt into r xt. Is it linear? Absolutely not. Right? This is not linear at all. You can check. X1t you will throw, x2t you will throw. Basically, if you throw x1t plus x2t, if you throw x1t plus x2t, so whatever the input is there, that remains as it is. Along with that, in the multiplication, it will come in bracket. Right? So is it equals to x1t into r x1t plus x2t into r x2t? Are both of them same? Absolutely not. Additivity is failing. that means it is non-linear, right? Non-linear like this, non-linear. What about time variancy? So wherever you see t, put t minus t naught. So what will be your first task? Wherever I see t, wherever I see t, put t minus t naught. And what is the second task? In the bracket of x, whatever that is there, that remains as it is, minus t naught. In the bracket of x, whatever that is there, that remains as it is, minus t naught. Are both of them same? Yes, both are same. What does that mean? Time invariant. So it is non-linear and time invariant, like this case only. So these are some good examples. In that manner, basically you just need to follow the process. Okay, just follow the process, you will be able to do the problem in the examination hall. Because in the examination there will be one problem coming, and certainly the problem will be from these cases only. Okay, I will not leave a single case, even if I have left one or two cases that I will be covering in the assignment. So problem in the examination hall will be from our notes only, nothing apart from the notes will be asked. So you need to follow the notes in a good manner, that's it. Let's go to the next one. Minimum of under root xt and xt. I hope you will be able to solve. Linearity will not be followed here, right? What you will do, you will throw x1t, x2t, you will throw x1t plus x2t. So what that would be equals to? So what would be the output here? Minimum of under root x1t plus x2t plus x1t, x2t. So whatever that is there, whatever the input is there, that will come under root like this. Is it equals to minimum of under root x1t plus minimum of under root x2t. Are both of them equal? Absolutely not. Both are absolutely not equal. If both are not equal, what does that mean? Non-linear, right? This is non-linear. And what about the time variancy? So what is the first task? Wherever I see t, I will put t minus t naught. Wherever I see t, I will put t minus t naught. And what is the second task? In the bracket of x, whatever that is there, that remains as it is, just minus t naught. In the bracket of x, whatever that is there, that is as it is, just minus t naught. Are both of them same? Are both of them same? Yes. What does that mean? It is, both of them same, then it is time invariant. So just like the previous examples, again, linear, non-linear and time invariant. So that's it about time variant and invariant. So what we have seen, linear, non-linear, time variant, time invariant. What is the conclusion? In the linear one, what you need to do? Linear and non-linear. x1t you will throw, x2t you will throw, x1t plus x2t you will throw, and then you will throw 3x1t. So in that manner you will check if all are coming same or not. In time variant and invariant, what you need to do? Wherever you see t, put t minus t naught, and in the second task, in the bracket of x, whatever that is there, that remains as it is, minus t naught. Whatever that is there, that remains as it is, in the bracket of x, minus t naught. If both are coming same, then time invariant, otherwise time variant. So this is the process we are going to follow, and there is no chance that you will be getting the answer wrong. There would be n number of process, some will be telling do that thing, this thing, it will be just confusing for you. But this is the best possible or the least effort problem solving skills that we have developed for linearity and time variance. All good? Some important point, like this is a very basic point. So in a system, if there is an input, there would be some output, right? If I apply the impulse input, if my applied input is impulse, if I apply the impulse signal, then the output that we will get, that is known as impulse response of the system. Okay, what this is known as? Impulse response of the system. Okay, so output is known as response. This is the input signal, this is known as output response. Input signal, output response. So if my applied input is impulse input, then I will say impulse response of the system. If applied input is step, what I will say? Step response of the system. Step response of the system. And if applied input is ramp, what I will say? Ramp response of the system. If applied input is parabolic, then what I will say? Parabolic response of the system. If applied input is exponential, what I will say? Exponential response of the system. Okay, just the language, because when I will be teaching, I will be using step response of the system, ramp response of the system. So there you should not be getting confused. What is the meaning of ramp response? The meaning of ramp response is that applied input is ramp. So with respect to that particular input, what output you are generating? So that is known as ramp response of the system. Step input, step response of the system, and impulse input, impulse response of the system. So in this 60 minutes of this video, roughly around 60 minutes, what we have studied? We have studied about time variant and invariant systems. Okay, so linearity, non-linearity, time variance and time invariance. Everything is completed. Next we need to study about LTI system, linear time invariant system. So do you know what is linear? Yes. Do you know what is time invariant? Yes. That's it. So a system which is linear and time invariant as well, that is known as LTI system. And with respect to the LTI system, there is one specific property, and that property we have already seen. What is that property? That is convolution. So in the next lecture, we will just study whatever that we have already studied. So in the next lecture, you will not be learning anything new. You already know all the things about LTI system. So this is what I wanted to do. Usually chapter is started with LTI system only, and in between convolution and all these things come, and systems, this particular chapter becomes very complex. But here we have built up all the concept. We have studied convolution, we have studied linearity, we have studied time invariance as well. Now we will start linear time invariant system. It will be just a cakewalk for you. You will be doing everything on your own. I will not be teaching you anything. You just know everything about this particular chapter, or you can say this particular topic. So that we are going to see in the next lecture. So next lecture will be on LTI systems. Okay. Yeah. Thank you very much. Yeah. Hi everyone. Welcome back. So what we have studied? We have studied about linearity and we have studied about time invariance. Now what we need to study? We need to study about LTI system, linear time invariant system. So the system which is linear plus time invariant. So both should be there. Linearity should also be there, plus time invariance should also be there. So this is known as LTI system. Okay. So in a particular system, what we do? We apply an input and we get some output. So this is known as input signal. So this is a signal, right? This is a signal, and this is also a signal. You remember our example? Potential divider was there. R to R. We applied xt here. This was a signal, and then we got output yt. This was also a signal, and this was a system, right? This is a system. Now system could be different as well. It is a simple potential divider. I can use a RC circuit as well. I can use a RC circuit. In this circuit as well, there will be some input and some output. So this is a different kind of system. Both systems were linear as well and time invariant as well. This was also LTI, this is also LTI. So systems could be different, right? This is a different system, this is a different system. So now I am representing my system with h of t. Look, this is a signal, right? Xt is a signal, yt is also a signal, but this is a system. This is a system. How can you represent it with a signal? H of t is a signal, no? A function which is a function of time. I am representing my system with h of t. You will have a doubt that, sir, xt is a signal, fine, yt is a signal, but this is a system. How you are representing it with h of t? So h of t is not a signal, h of t is a system only. So let me explain you the meaning of h of t. Okay, what I will do, I will explain the meaning of h of t. So what I am saying, there could be different kind of systems. It will have some input signal, it will have some output signal. So xt is the input signal, yt is the input signal. Sorry, yt is the output signal. Here xt is the input signal, yt is the output signal. Different kind of system could be there. So I am representing the system, whatever that is there inside the block, whatever that is there inside this box, that is represented by ht. And now for a LTI system, for a particular LTI system, yt is given as xt convolution with ht. And do we know what is the meaning of convolution? Yes. But this will be applicable only for LTI system. Mark this thing. For an LTI system, I am representing my system with h of t. You don't know what is this h of t, we will talk about it. I am applying a xt signal. What will be my output? I can directly predict my output if I know this h of t, if I know this xt. So if I know this h of t, if I know this xt, then I can tell my output yt. That would be equals to xt convolution with ht. Fine. Now, if my input is xt equals to delta t, what I am saying, if my input is xt equals to delta t, so what will be my output? What I am saying, now if xt is equals to delta t, that means if my input is impulse input, so what I will call my output? Output will be called as impulse response of the LTI system. Here we have seen, right? If the input is impulse, what will be the output? Impulse response of LTI system. If input is step, what it is known as? Step response of the LTI system. So if my input is impulse, then what would be my output yt? Yt would be known as impulse response of LTI system. Say yes or no. If your applied input is delta t, how yt is given? Yt is given as xt convolution with ht. Xt convolution with ht. I don't know what is this ht. In place of xt, what I need to put? Delta t, because my applied input is delta t. My applied input is delta t. Delta t convolution with ht. Anything convolved with delta t will give you the same function. So delta t convolution with ht, what will be the answer? Ht only. And what is this yt? Yt is the impulse response of LTI system. When you applied the input to be delta t, when you applied the impulse input, what output you are getting? You are getting the output equals to h of t, and that is known as impulse response of LTI system. So did you understand what is the ht? Ht is not a signal, it is the response. It is the response of a system. But when the applied input is impulse. So ht is known as impulse response of LTI system. A very good point. People will simply mug up that ht is the impulse response of LTI system. They don't even know the meaning of it. The meaning is, if I apply my signal to be delta t, forget about this ht now. Forget about this ht. I was having a black box. I was having a box. Some system is there. I just kept this in a box. You don't know what is there inside. So what you will do? You will apply delta t. At the input, you will apply delta t. Then you will receive some output. Whatever the output that you are receiving, that would be known as ht. Are you getting this point? In a system, in a particular box, if I apply the impulse input, so whatever the output that I am receiving, that is known as ht. Now I am knowing ht. Now I know the ht. If I know ht, then no matter whatever the input I am having, I can predict my output, because yt would be equals to xt convolution with ht. Let's understand it more. From this slide, this is what you need to remember. That what is ht? Ht is known as impulse response of LTI system. What ht is known as? Ht is known as impulse response of LTI system, because if your applied input is delta t, then your yt would be equals to ht only, and yt will be known as impulse response of LTI system, that is equals to ht. So that's why ht is known as impulse response of LTI system. Let's understand it more. So there is a system given, okay? There is a system given to you in a box. In a box there is a system. You need to find the ht for the given system, or you need to find the impulse response of the system. If I need to find ht, what I need to do? I will apply delta t here. What I will do? I will apply delta t. What is yt? Yt is equals to 2r divided by 2r plus r, 3r into xt. So that would be equals to 2 by 3 xt. And what is the input applied? Input applied is 2 by 3 delta t. So one thing I know, that if I keep my input as delta t, then what is my output? My output is equals to the impulse response of LTI system, and that is coming out to be 2 by 3 delta t. So for this particular system, my impulse response is 2 by 3 delta t. That's it. Now if someone asks you that what will be your output if I apply the input to be 5 ut? If I apply the input to be 5 ut, then what will be your output? So what you will say? That sir, I know one thing, that yt equals to xt convolution with ht. Now what is the input you are applying? 5 ut. What is your ht? 2 by 3 delta t. So what can happen? Sir, common like this constant value can come outward. So 5 into 2 by 3, 10 by 3 ut convolution with the delta t. So anything convolved with delta t will give you the same function. So what is the answer? 10 by 3 ut. Are you getting the same thing? If I apply 5 ut here, what will be the output I will be getting? 5 into 2 by 3 ut. So yes, I am getting 10 by 3 ut only. And from this process as well, I am getting 10 by 3 ut. So did you understand what is ht here? Ht is the impulse response of LTI system. That means when I apply the signal to be delta t, what is the output you are receiving? That is known as ht. And if you know ht about a particular system, if you know the ht of a particular LTI system, then no matter whatever the input you apply, you can predict the output of the system. So this is the meaning of impulse response of LTI system. A very, very good important question for interviews. When you go to the master's interview, this is something they would ask. They will just say one thing, that ht is shown with reference to the signal. xt is a signal, yt is a signal. Both are signal. How you are representing a particular system with h of t? What is the meaning of h of t? Then you will say that, sir, h of t is the impulse response of LTI system. What does that mean? That, sir, output and input relationship can be given for a LTI system as yt equals to xt convolution with ht. If I put my input to be impulse, then my output will be called as impulse response of LTI system, and that would be equals to st. So st is my impulse response of LTI system. Then you will take this example and you will say that, sir, if I apply my input to be delta t, my output that I am receiving is 2 by 3 delta t. That means if I applied my input to be impulse, then the impulse response that I am getting, that is 2 by 3 delta t. That means my h of t is 2 by 3 delta t. Now if I know my h of t, then no matter whatever the xt value is, I can predict my yt. That's it. So this is the meaning of h of t. So h of t is not a signal. Again I am saying xt is a signal, yt is a signal. H of t is not a signal, it is the property of a system. And h of t is known as impulse response of LTI system. I hope this is crystal clear to you. Well and good, right? Let's see some more questions. You need to find the ht of the given system where input output relationship is given. Okay, input output relationship is given for a particular system. You need to find the ht of that. So A, how will you start? That, sir, this is a system. What is the input output relationship? That, sir, if I apply xt, what I will get? If I apply xt, what I will get? Sir, I will get sin t plus 2 xt. If I need to find the ht, what I need to find? Ht. That means I need to find impulse response of LTI system. What does that mean? That I need to apply my xt equals to delta t. So this is my yt. So when xt equals to delta t, at that time yt equals to ht, and that would be equals to sin t plus 2. In place of xt, what you need to put? Delta t. So what is this? How you can reduce it? This is in the multiplication. If you remember this particular process, let's write down alpha t here. Alpha t into delta t. What that would be? T minus 0, 0 can come here. So that would be equals to alpha 0 into delta t. I hope you remember this thing. This we have studied in basics of a signal, right? This is not convolution, this is the multiplication. So t minus t naught. So t naught would come here, t naught is 0 here. So alpha 0 delta t. So here 0 would come here. So sin 2 into delta t. This answer I will give. And this is completely wrong. Completely wrong. Why is that so? All this process, whatever that I have done, till this thing it is fine. That okay, you are applying xt, you will get sin t plus 2 into xt. This is the output you will be getting. Till this process, everything is fine. But after whatever that I have done, that if your xt is equals to delta t, then yt will be equals to ht. That is absolutely wrong. Why is that so? Because I told you one thing, all this will work for LTI system only, not for any random system. This will work only for LTI system. And is this LTI system? Is this system LTI? Is it linear? Yes, it is linear. But is it time invariant? This is time variant, right? Because in place of t, what you will do? t minus t naught. In place of t, you will put t minus t naught. But in the second task, the sign t plus 2 will remain as it is. Whatever that is inside of t, that will be replaced with minus t naught. So are both of them same? No. That means this is not an LTI system, right? So this system is non LTI. So if it is non LTI, then all this process will never work. So this is absolutely wrong. So what will be the answer? Answer will be cannot determine. What will be the answer? HT can't be determined. Okay. So this particular formula, everything started from here only. That output of a particular LTI system is the convolution of the input with the impulse response of LTI system. What is this HT? HT is known as impulse response of LTI system. So XT convolution with HT is given as YT. But this will be applicable only for the LTI system. Is this system LTI? No. Is this system LTI? Yes. This system is LTI. So whatever the process we did here, everything was fine. Because this was an LTI system. You can see that here linearity was also there and time invariance was also there. So it was an LTI system. So all the process was fine here. We applied delta t, we got 2 by 3 delta t. That was our HT. If we are having the HT, then how we can get YT for any random particular input that we have seen here. Right? But here this was non-LTI. So in this lecture till now what we have studied? First we have understood the meaning of HT. So what you need to remember? You just need to remember that XT is a signal, YT is a signal, but HT is not a signal. HT is known as impulse response of LTI system. And what is the meaning of an impulse response of LTI system? Then that means if I am applying my input to be delta t, then whatever the output that I am getting, that will be equals to the impulse response of LTI system, right? So that would be YT would be equals to HT for the particular input delta t. And if I know the impulse response of LTI system, then I can predict my YT, that would be equals to XT convolution with HT, where XT is the input signal and HT is the impulse response of LTI system and YT is the output response of the LTI system. There you go. This is the conclusion till now. Let's solve the question B. YT equals to XT plus 0.5 XT plus 0.5 XT minus 2. Is this an LTI system? Yes. Is this linear? Throw x1t, throw x2t, add both of them, then throw 3x1t. You will get to know, yes, it is linear. What about time invariance? In place of t, you put t minus t naught. In the second task, what you need to do? In place of t, you will put t minus t naught. In the second task, what you will do? Whatever that is there in the bracket of x, that remains as it is minus t naught. So by any mean, you can simply say that, yes, this is an LTI system for sure. Okay. Just follow the process, whatever that I have told, just follow that particular process. Throw x1t, throw x2t, then you will get to know. Then you throw x1t plus x2t, you will get to know that, yeah, additivity is followed, then homogeneity will also be followed, then time invariance is also followed. So yes, it is an LTI system. Now what I need to find? I need to find HT. What I need to find? HT. So how do I find HT? When xt is equals to delta t, at that time YT equals to HT. So in place of xt, what you need to put? Delta t plus 0.5 delta t minus 2. So this is your HT. Yes, this is my HT. And one thing you will see here, that if I need to predict my YT, what will be my YT? YT will be equals to XT convolution with HT. So the answer of this question is ending here. Okay, answer of this question has end here. This will be your HT. That's fine. But one thing also I can see, XT convolution with delta t plus 0.5 delta t minus 2. So XT convolution with delta t, what that would be? XT only. XT convolution with 0.5 delta t minus 2, what that would be? The same shift will be given to x of t minus 2 as well. This would be equals to YT. And was this the same relation? Yes, this was the same relation. This relation and this relation, both are matching. Yes, both are matching. That means, yeah, everything is correct. But for the case A, what HT we found? HT we found was sine 2 delta t. Sine 2 delta t. If I calculate my YT, what that would be? XT convolution with HT. XT convolution with, what is HT? HT is sine 2 delta t. Sine 2 delta t. Convolution sign is there. So sine 2 is a constant value. Sine 2 can come outward. Xt convolution with delta t. Xt convolution with delta t. What is the value of xt convolution with delta t? That is xt only. So what is the answer we are getting? Sine 2 into xt. And this is coming out to be equals to yt. So this is our yt that is coming out to be. Although all this process is wrong. We cannot do this process because it is non-LTI system. And here also we can verify that the given yt was this. The given yt was sine t plus 2 xt. But what yt we are getting? Sine 2 dot xt. Here what was the relationship? Sine t plus 2 dot xt. Here what we are getting? Sine 2 xt. So this relationship doesn't match. That means it is certainly a non-LTI system. So by any way we can check. First thing is that this process is not even followed. So here what you will say that simply by looking at input-output relationship, you cannot determine what is your HT because this is a non-LTI system. So if they want to frame a good question, they will frame the question like this, and certainly they will put this option as well. So people will click, okay, this is the impulse response. But the answer would be, we cannot determine the impulse response of the given system because it is an non-LTI system. Well and good? All fine? Okay, yeah. Let's move to the next one. So this is a concept only, or you can say this is a question. So what they are saying, two LTI system having impulse responses of H1T and H2T are cascaded. Cascaded means they are connected in series. Find the overall response of the new system. So this is the new system. This is the new system. So what will be the overall response? So first what will happen? Xt will be convolved with H1T. Xt will be convolved with, or let's call this as Y1T. Let's call this one this as Y1T. So what will be your Y1T? Y1T would be equals to Xt convolved with H1T. Xt convolved with H1T. Now what will be your Yt? Your Yt would be equals to Y1T convolved with H2T. What is my Y1T? Y1T is this thing. So Y1T is Xt convolved with H1T convolved with H2T. So what is the Yt coming out to be? Yt is coming out to be Xt convolved with H1T convolved with H2T. Can I write it down in this manner? Yes. What I can do? I can make a box. I am sending Xt. I am receiving output Yt. I am sending Xt. I am receiving output Yt. This is the new system that we are having. Right? What is the relation? Yt equals to, and for this new system I am saying that my impulse response is h of t. What I am saying? My impulse response of this particular system is h of t. What is the relation? Xt convolution with ht is equals to yt. What is the actual relation? Xt convolution with h1t convolution h2t. Right? This is your yt. So from here what did you get to know? What is the impulse response of the new system? That is ht equals to h1t convolution with h2t. Say yes or no. So this is the impulse response of the new system. So if two systems are connected in cascade, h1t impulse response, h2t impulse response, so both will be convolved. If these two boxes I need to reduce by one box only, that means I need to convolve them, not multiply. It feels like that we should multiply, but no. Xt convolution with h1t, then convolution with h2t, that is equals to yt. That means xt convolution with h1t convolution h2t. So your new impulse response is h1t convolution with h2t. So this is what you need to remember. If two are connected in a cascade, then what will happen? Both will be convolved. Okay. So they can ask you, they will give you that impulse response of this particular system is e to the power minus t ut. Impulse response of this particular system is e to the power minus t ut. So what will be the impulse response of the overall system? So what you need to do? E to the power minus t ut convolution with e to the power minus t ut. Sir, I told the trick. E to the power minus t, e to the power minus 2t, minus 1 minus of minus 2 into ut. So what will be the answer? E to the power minus t ut minus e to the power minus 2t ut. So these kind of questions they can ask. Okay. Are you able to understand the point? We have seen the convolution. So every question regarding LTI system we can solve, because we already know what is the meaning of convolution, how to perform the convolution. It is just that now we are just seeing that where to use the convolution, where convolution is used. So convolution is used in this process. All good? All fine? So can we frame a question? Yes. So let me write down the question and then we will solve it. Yeah, so this is the question. Try doing it on your own. Two LTI system having impulse responses of e to the power minus t ut and ut are connected in cascade. Find the impulse response of the overall system. So what is h1t? h1t is e to the power minus t ut. And what is h2t? h2t is ut. What I need to find? I need to find the impulse response of overall system. That would be convolution of these two. So e to the power minus t ut convolution with ut, right? So do you remember the answer of this particular thing, or you can remember that anything convolved with ut is simply the running integration. So minus infinity to t e to the power minus tau ut d tau. One thing you will get to know from here is that integration has to go from 0 to t e to the power minus tau d tau, considering the fact that t has to be greater than equal to 0. So when you integrate it, what you are going to do? 1 minus e to the power minus t ut. So this will be the answer. Okay, so this is the answer. Just 1 second, I got some work, I will come back. So this was the easy question, right? Okay, so we have done this question, right? So this was the easy question only. Let's go to this one. So this is a very good concept, or you can say this is a good question as well. So whatever the conclusion that we are getting from this particular question, that we need to remember, and it will be very easy to remember as well. So what they are saying, for a continuous time LTI system, you know the impulse response. Impulse response is given as ht. Okay, you need to find its step response and ramp response. What is the meaning of step response? What is the meaning of step response? Step response I need to find. So if I need to find step response, what should be my input? Input should be step input. So I need to apply ut input, then only I will get the step response, right? So your input has to be step input. So what will be your yt? Your yt is given as xt convolution with ht, right? And if, look, first I will write down this particular line, that yt is given as xt convolution with ht. If your xt is equals to ut, if I apply the step input, then yt will be equals to step response. Yt will be equals to the step response, and step response is given as st. Step response is given as st. So yt is equals to st convolution with ut convolution with ht, right? So what you are getting, let's carry this equation. The equation is st equals to ut convolution with ht, ut convolution with ht. What I can do, I can apply the differentiation property here. Okay, what I am doing, I will apply the differentiation property dst by dt, that would be equals to dut by dt convolution with ht. So what is the meaning of dut by dt? That is delta t convolution with ht. Anything convolved with delta t, what you are getting? ht only. So what did you get to know? dst by dt is equals to ht. So from here, what will be your st? St will simply be the running integration of h of tau d tau. What is h of tau? H of tau is the impulse response. So from here, what you got to know? That your step response is equals to the integration of impulse response. So in the examination, if impulse response is given and they ask you to perform the step response, will you be able to do it? Yes. Whatever the impulse response is given, I will just do the running integration. That's it. And how did I get to know this particular thing? From all this analysis. That yt equals to xt convolution st. ht is already given, right? If I put xt equals to ut, then my ht will be known as step response. So st will be equals to st. St will be equals to ut convolution ht. What I can do? I can apply the differentiation property. When I apply the differentiation property, I get to know this relationship. From there, I get to know that st is equals to this particular thing. Look, if you have studied convolution, then only you will be able to understand all these points. Otherwise, nothing you will understand. That's why I taught convolution beforehand. Now, understanding LTI system will be a cakewalk for you. Every single question, no matter how much tough question they frame, you will be able to solve that particular question. Because the concept of convolution is clear in your mind. All these things, differentiation property, everything is clear, right? Everything is crystal clear. So, no issue there. I can solve the same for, next what I can do, I will solve the same for ramp input as well. What they are asking? Ramp response. Ramp response they are asking. Step response is given, you need to find the ramp response. Or what is given? Okay. Impulse response is given, you need to find the ramp response. Okay, fine. So yt is given as, this will be the first step that I know that yt is given as xt convolution with ht. So ht is given. If I put xt equals to rt, if I put the input to be ramp, then what yt will be called? Yt will be called as ramp response. Ramp response. And ramp response is shown by ct. Okay, ramp response is shown by ct. Right? So let's add a page. So ct will be equals to, the ramp response will be equals to, if your input is rt, convolution with ht. This is not the impulse function, this is the impulse response, right? This is not the impulse input, this is impulse response. So you cannot say that anything convolved with ht will be rt only. No, nothing like that. Don't do these kind of mistakes. What I can do, I can apply the differentiation property. If I apply the differentiation property, what I am getting? What this will be replaced with? Ut. Right? If I apply the differentiation property, then only one signal will be differentiated. So RT differentiation will give you UT. Well and good. UT convolution with HT. UT convolution with HT. Where it is? UT convolution with HT. From equation 1, UT convolution with HT is equals to ST. Basically, this is your step response. So from equation 1, what you are getting is equals to ST. So what will be your ramp response? Ramp response will simply be the running integration of step response. So what did you get to know from here? And what is S2? S2 is the running integration of, from here another thing you can write down. What is S2? S2 can be replaced with, S2 can be, ST or S2 can be replaced with running integration of H of 2. So again there is a running integration of H of 2 d2. Right? So from here you got to know that ramp response is the integration of step response. Also you got to know that ramp response is equals to the double integration of impulse response. So twice differentiation you need to do. Is this concept clear? So what we have studied? Impulse response, from impulse to step you need to go integrate, step to ramp you need to go integrate. Right? What we have studied? Delta t to ut if you need to go integrate, and ut to rt you need to go integrate. Same goes with responses as well. If you are having the step response ht and you need to have the step response st, and then you need to have the ramp response ct. So this is the procedure you need to follow. ht, if you take the running integration you will get the step response, if you take the running integration you will get the ramp response. Well and good. And what if the other process we need to do? That means step response is given. What you need to find? You need to find impulse response. So what is given? Step response is given. That means ST is given. What will be ST? ST is or let's make the system. This is the system. What is this? This is the impulse response. What is this? This is the impulse response, and this is what we need to find. We need to find the impulse response. What is given? What is given? Step response is given. That means ST is given. So what input you would have applied? You would have applied the step input. So what will be your ST? ST is given as UT convolution with HT. If my applied input is UT, then I would get ST, right? What I can do, I can apply the differentiation property. So this guy will be differentiated. So delta T convolution with HT. So what you are getting from here? Anything convolved with HT will be HT only. So HT is HT is equals to dST by dt. So from here what you are understanding? That your impulse response is the differentiation of step response. And which is pretty obvious as well, right? Because from here to here, when you are going, you need to do the integration. So if you need to come back, you need to do the differentiation. From this particular step, you can get to know that impulse response will be the differentiation of the step response. If integration goes that side, that will be converted into differentiation. So this is the proof as well. Well and good. Okay. Let's get back to the next question. Ramp response is given, you need to find the step response. So what is given? Ramp response is given. That means if your applied input was RT, then your output was CT. I am assuming that HT is the impulse response. HT is the impulse response. Although I don't need to find impulse response, what I need to find? I need to find the step response. So let's check. What will be CT? CT will be equals to RT convolution with HT. If I do the differentiation, what I will get? Differentiation of RT, what that would be? UT. UT convolution with HT. What is this? This is the step response, right? So dCT by dt. What is this equals to? This is equals to the step response. So what did you get to know? For finding the step response, what I need to do? I need to differentiate the ramp response. So step response is equals to the differentiation of ramp response. There you go. Right? All good? All fine? So what is the conclusion? The conclusion is with the time domain, what we have studied. In the time domain, we have studied that from delta t to ut, I need to go integrate. From ut to rt, I need to go integrate. From rt to ut, I need to go d by dt. From ut to delta t, I need to go d by dt. That's it. Same goes with responses as well. If impulse response is given, I need to find step response, integrate. Step response is given, I need to find ramp response, integrate. Ramp response is given, I need to find step response, differentiate. And step response is given, I need to find impulse response, differentiate. So when you revise, you will just revise this slide, that's it. You will quickly see the derivation, okay, this is how it is derived, all the equations, everything is clear to me. What is the meaning of impulse response, that is clear to me. When I study LTI system, one thing I will get to know that if two systems are cascaded, then both will be convolved. After that, I need to see this particular concept that impulse, integrate step, integrate ramp. Ramp, differentiate, step, differentiate, impulse. Same goes with responses as well. That's it. In the examination, this kind of question can come. They will not write down in the theory. What they will do, that sir, there is a system, I am applying the input to be 3 delta t, I am receiving the output to be e to the power minus t ut. So now what will be your output when the applied input is 5t plus 2 ut? So try doing it on your own. You can do it for sure. What they are saying? Always our first task would be to solve the question of LTI system. I will assume that my impulse response is h of t. So what I am assuming? First task would be impulse response h of t. Impulse response is h of t. Right? Now, when applied input is 3 delta t, that will be convolved with h of t. what output it will give you? The output it is giving you e to the power minus t ut, e to the power minus t ut. What is the meaning of this? Del t convolution with ht, that would be ht only, e to the power minus t ut. So from here, first task has been done, that our impulse response is this particular thing. This is our impulse response. The first job is done. Now if I know the impulse response, then no matter whatever the input is applied, I can find the output. So this output I am assuming as yt. So what I need to find? I need to find yt, and that yt will be equals to the applied input convolution with ht. What is the applied input? Applied input is 5t ut plus 2 ut. Can I write it down in this manner? 5t ut plus 2 ut convolution with ht. And what is ht? ht is e to the power minus t ut divided by 3. What is 5t ut? Tut is rt only. So can I write down in this manner? 5 rt convolution with e to the power minus t ut divided by 3. Divided by 3 is there, so here I am writing 5 by 3 plus 2 by 3 ut convolution with e to the power minus t ut. This is the equation that I am getting. This will be my yt. I need to perform this particular operation and I need to perform this particular operation. What is the meaning of this particular operation? Anything convolved with ut will be the running integration. Anything convolved with ut will be the running integration. So this particular process I am calling as y1t, and this particular process I am calling as y2t. So what will be my yt? My yt will be equals to 5 by 3 y1t plus 2 by 3 y2t. If you solve the problem in the examination hall with this particular mindset, very slowly you need to solve, then there will be no chance of calculation error. Otherwise, a lot of factors are there, 3, 5, 2, there would be high chances of calculation error. But you need to solve by this much patience. Now my target is to calculate y1t and y2t. Can I calculate y1t? Y1t will be the bigger task. What will be y1t? That is rt convolution with e to the power minus t ut. So a lot of people will be starting with the basic definition. That sir, let's start with the basic definition. But why we should do so? Because I know that convolution is done with respect to RT. So what I can do, I can use my differentiation property. So here the differentiation property will be used. Whenever you are convolving with UT or delta T, UT we always remember, right? Anything convolved with UT is the running integration. But anything convolved with RT, there is no property. Anything convolved with RT, there is no property. So what I will do, I will apply the differentiation property. I will apply the differentiation property. So what I am getting? E to the power minus t ut. Then I will realize that this I need to already calculate. What I mean to say is that, what is my y to t? Here I realize that this is my y to t. What is my y to t? Y to t is ut convolution with e to the power minus t ut. And then I get to know that anything convolved with ut is the running integration. So minus infinity to t e to the power minus tau u2 d2. Running integration I have taught a lot of times. So what will happen? E to the power minus tau u2. So you get to know that it is non-zero from tau greater than 0. So the limit will change from 0 to t. And if t is less than 0, that means there will be no integration. So t has to be greater than 0. E to the power minus tau d2, with the condition that t is greater than or equals to 0. So from here what I get to know is that it would be e to the power minus tau, negative sign would be there, 0 to t. So what answer I will be getting? 1 minus e to the power minus t ut. So your y to t is coming out to be, from here I get to know that my y to t is coming out to be 1 minus e to the power minus t ut. Okay, this is the y to t that is coming out to be. And the same thing I can put here as well, 1 minus e to the power minus t ut, right? This is my dy1t by dt, dy1t by dt. From here I need to calculate y1t. What that would be? The running integration again, 1 minus e to the power minus tau u2 d2. Okay, what I need to do, I need to do the running integration. So 0 to t 1 minus e to the power minus 2 d2, considering the fact that the t has to be greater than or equal to 0. So when I integrate, what I will be getting, 1 plus e to the power minus 2 from 0 to t, that would be equal to 1 plus e to the power minus t okay, yeah, integration is done wrong, that's what I was thinking. So what will be the integration? Integration of 1 will be 2, right? 2 minus e to the power minus 2, and minus 2 another minus will come, 0 to t. So that would be t plus e to the power minus t minus 2 will be put 0, that would be 0 only, e to the power 0 is 1 into ut. So this is the answer you are getting for y1t. So you are having the values of y1t and y2t very easily. So one was ramp response, another one was step response. If you could see that, okay, I am having the impulse response, I need to calculate the step response, I just need to integrate. And if I need to calculate the ramp response, I am double integrating it. First integration is done here, then another integration is done here. But in the examination hall, don't go with the pressure that I need to integrate that thing. Just go by the process. If they want to frame a good question, they will frame with respect to the process. And if you keep the pressure in mind that I need to do this process, that process, then there is very high chance that you will mess it up. So nothing, no formula is there. What if in the examination hall they ask in the MCQ that if you are given step response, how will you find ramp response? By integrating it. For that it is good. For this particular thing it is good. But if they are asking a question, then forget about all these formula and anything. Just have the trust on yourself that I have studied the concept and I will be able to solve. This is the problem with a lot of aspirant. They always try to remember the trick, this thing, that thing. If you solve by trick, first thing, it will take more time. Second thing, there will be very high chance of messing it up. And third thing, your confidence level will be very low. But if you go by the concept, have trust on yourself, then these kind of things will be very easy for you. And believe me, just give this question to a lot of students, those who have studied this particular subject, and they will find it difficult. But did we find any difficulty here? We are just following the process. Whatever the process is there, just going by that particular thing. We got to know the ST value, then I need to find the YT, then I got to know that this is Y1T, this is Y2T, Y1T and Y2T I am having. So what will be my YT now? So my YT is simply 5 by 3 Y1T plus 5 by 3 Y1T plus 2 by 3 Y2T, 2 by 3 Y2T. So 5 by 3 Y1T, Y1T is, okay, Y1T is this particular thing, t plus e to the power minus t, this will be tut plus 5 by 3 e to the power minus tut, e to the power minus tut minus 5 by 3 ut, right? Basically 5 by 3 will come common, t plus e to the power t minus 1 ut. So this is the multiplication that I have done, plus 2 by 3 ut minus 2 by 3 e to the power minus tut, e to the power minus tut. Well and good. So this is equals to 5 by 3, this I can call as RT, plus 5 by 3 e to the power minus tut, 2 by 3 e to the power minus tut. So that would be e to the power minus tut. And what about this one? Minus ut. So let's keep it as tut only, because that will give us better results. So what is the answer we are getting? 5 by 3t plus e to the power minus t minus 1 ut. So that's the YT answer. Okay. This is the final answer. Although here it took time, but in the examination hall, while doing all this process, it will not take much of time. Okay, let's check back the calculation. So tut e to the power minus t minus 1 ut e to the power ut minus e to the power minus t. So 5 by 3 tut remains as it is, 5 by 3 minus 2 by 3, that would be 1 only, and minus 5 by 3 plus 2 by 3, that would be minus 1 only. So ut comes common, then 5 by 3t plus e to the power minus t minus 1. Fine. Okay, so this is the answer. So yeah, the same thing we need to study for discrete time as well. So I will take a pause, I will change the slide as well. After that, we will study the same thing with discrete time as well. But in the discrete time, if you remember the difference of Rn, what that was? Do you remember it? It was Un? No, it was u of n minus 1. Basically, d by dt of Rt is equals to ut, but difference of Rn is not equals to un, it is equals to u of n minus 1. Or I told you that remember the running integration of un, that is not equals to Rn, it is equals to r of n plus 1. So running integration goes here, it will make a difference. So difference of Rn plus 1 is equals to un. So difference of Rn would be equals to un minus 1, right? Well and good. So this thing we are going to see in the next in this lecture only, but I need to change the slide and then we will see it. The discrete time LTI system we are going to see. Okay. Yeah, welcome back. So we need to study about LTI system only, but in discrete time now, right? So ditto same concept, whatever that we have studied for continuous time, the same concept is there for discrete time. But when we were studying about discrete time, I forgot to show this property of difference. There we studied the property of differentiation in continuous time, right? Like xt convolution ht would give you yt. So if I differentiate only x, what will happen? The differentiation will be done with respect to only y. So one differentiation here, one differentiation here. If there are two differentiation here, so here also there will be two differentiation. So I hope you remember this particular property, right? So you remember this particular property. Now what about this thing? So let's derive it. So can I write down x of n minus 1? So I am doing a shift of 1 in this particular function, and this function is as it is. So what will be the shift in y? This property I have taught you, right? If there is a shift in place of n, you are putting n minus 1. So here also in place of n, you will put n minus 1. Whatever the shift that is being taught here, that will be taught here as well. If you remember this particular property, that x of n minus n naught 1 convolution with h of n minus n naught 2, what that would be equals to y. In place of n, you will put n minus n naught 1 and this shift as well. So here the value of n naught 2 is 0. Value of n naught 2 is 0, n naught 1 value is 1 here. Is this true? Right? This I am calling as equation 1. This I am calling as equation 2. Can I subtract equation 2 from equation 1? What I am doing? 1 minus 2. So if I do 1 minus 2, what I will get? X of n convolution with h of n minus x of n minus 1 convolution with h of n is equals to y of n minus y of n minus 1, right? Can I take h of n common from here? H of n convolution with x of n minus x of n minus 1. Is there anything wrong? Absolutely not, right? This is true only because h of n convolution with x of n minus h of n convolution with x of n minus 1. So I can take h of n common. Here y of n minus y of n minus 1. What is this equivalent to? Del of xn, right? Difference of xn. So h of n convolution with different of xn. Convolution with the difference of xn. What is this? This is equals to difference of yn. So the same property, that whatever that we have seen in continuous time, the same property is followed in discrete time as well. If I do differentiation once, here also one differentiation is done. So what did you understand from here? The delta of xn convolution with h of n will give you delta of yn. Say yes or no. Is this fine for you? And what if I would have done this particular thing? The delta of xn along with that delta of hn as well. So there are two differences. So in the y as well there will be two differences. So these properties are actually very important. If they want to frame a good question, they will frame questions from these properties. Also this property is also very important. Complete convolution is based on this particular property. Okay, so these are actually very important points. Well and good. Let's see the question. A discrete time LTI system is given, impulse response is given, you need to find the step response. So basically what is the scene? Your x of n is applied, you will receive some y of n, and the impulse response of this particular LTI system is h of n. You will apply x of n and this will be your y of n. So how the y of n will be given? Y of n will be x of n convolution with h of n. So this is the property of LTI system. Okay, what they are saying, h of n is given, this is given. What you need to find? Step response. For step response, how will I show step response? I will show the step response by s of n. For step response, what should be the input? X of n should be equals to u of n, right? Input should be u of n. So s of n would be equals to, if your applied input is u of n, that will be convolved with h of n. What I need to do? I need to put that differentiation property here. Why is that so? Because I know that differentiation of un, or you can say difference of un is equals to delta n. I hope you remember this particular thing. Where should I write? Here I am writing difference of un, what that was? Delta n. I hope you remember it. And difference of Rn, what that was? U of n minus 1. Do you remember these two properties? Not properties actually, these two results. This we have seen in our, I guess before LTI system we studied it, right? Difference of un is equals to delta n, difference of Rn is equals to u of n minus 1, right? So this is what we are getting. So what I can do, I will take one difference here. If I am taking one difference here, the same difference can go here as well. Say yes or no, right? Convolution with h of n. What is the value of this particular thing? Or you can do simply un minus 1. What this will be equals to? This will be equals to delta of n only. So this will be your delta of n. Delta of n convolution with h of n. Right? Delta of n convolution with h of n, what that would be equals to? H of n only. So from here what we are getting? H of n is equals to delta of Sn. So similarly, when we used to do this particular thing, that d by dt of alpha t is equals to beta t. So what we used to do, what will be your alpha t? That would be the running integration of beta t, right? So from here alpha t was running integration of beta t. So here also the same thing will happen. If delta goes here, that will be converted into running summation. So from here, this is the first property, this is the first result that you need to remember. No need to remember, this is the process that you need to remember. And what will be your S of n then? S of n will simply be the running integration, where k goes from minus infinity to n. This will be your S of n. So if h of n is given, you can find S of n simply by doing the running summation. Okay, just you need to relate it with the continuous time. Differentiation, if differentiation goes to the other side, it will become integration. So here difference goes to the other side, it will become running summation. Okay, so if your impulse response is given, then you can find step response by doing the running summation of your impulse response, right? Very easy thing. Discrete time LTI system, step response is given, you need to find ramp response. So what is given? S of n is given. S of n is given, that is given as u of n convolution with h of n. So this I am assuming as impulse response. Impulse response. So this is given. This is given. S of n you are given. You are having S of n. You are having S of n with you. What you need to find? You need to find C of n. This is what you need to find. You need to find the ramp response. So R of n convolution with h of n. This is what I need to find. What I can do? Differentiation. Right? What is the value of this particular thing? Even if you forget in the examination, all you can derive it there only. Rn minus 1. This can be written as un minus 1, and this can be written as n minus 1 un minus 1. So un minus 1 can come common. What will remain? U of n minus 1. So what is the value of this particular thing? That is un minus 1. un minus 1 h of n, that is equals to delta of Cn. Do we have the value of this particular thing? No, we don't have the value of this particular thing. What we have? We have un convolution with h of n. What we have? Un convolution with h of n. But one property I know. If I make the shift of 1 here, if I make the shift of 1 here, here as well there will be a shift of 1, and h of n I keep as it is. Say yes or no. Have we studied this property? Yes. Here only we have seen this property, no? Shift of n naught 1, shift of n naught 2, total shift is n naught 1, n naught 2. Here only the shift of 1 we are doing. So here also there will be a shift of 1. So what is this equivalent to? Delta of Cn is equals to S of n minus 1. From here, this is the first equation that you can keep in mind. And from here, if I need C of n, from here if I need C of n, what I need to do? I need to do the running summation. Very easy thing, like nothing you need to mug up. You will remember 0 things out of it. All this process you can do in the examination hall. Very easily you can do it in the examination hall. We will solve the problem as well, that how to solve the problem. But as of now, we are just looking at the process. If we are comfortable with the process, then we can do anything in the examination hall, right? So impulse response is h of n, step response is s of n, and RAM response is c of n. So what was our step response? S of n. Step response was equals to running summation of h of n, right? It was equals to the running summation of h of n, right? And what was our Cn equals to? Our Cn was equals to running summation of s of n minus 1 actually, right? S of k minus 1 I should write, not n minus 1, k minus 1, because the limit of k we are putting. Can we write it down in this manner as well? K goes from minus infinity to n minus 1 s of k. No, it looks like delta of k. This is s of k. So both are the same things, right? Both are same thing only. K minus 1 you can put equals to alpha. Then what will be the limit of k? Minus infinity to alpha minus 1. Then alpha can be replaced with, again it can be replaced with k. So that process we have already seen. I told you, whether you make this shift here or this shift you can make here, both are the same thing. This we have already seen. We have seen the derivation as well. So these are the conclusion we are making, but no need to remember any conclusion. In the examination, we will better focus on the process rather than remembering the conclusion. Now we will do the other process. Ramp response is given. You need to find the step response. So in the examination, first thing I will do, okay, ramp response is given. So what is given, that I will write down. What is given? Ramp response is given. Ramp response is given as C of n. That is R of n convolution with H of n. This is given. What I need to find? I need to find S of n. Step response I need to find. That means un convolution with H of n. This is what I need to find. So I cannot do anything with this, but here I can apply the differentiation property. So let's keep it aside. This is what I need to find. So my target is to get u of n anyway. My target is to get u of n anyway. So what I will do? Let's do the differentiation. Delta of C of n. If I do the differentiation here, or you can say if I take the difference here, H of n, what this will result in? Delta of R of n. I can derive it there, then I will get to know that it is u of n minus 1 convolution with H of n. This is equals to delta of Cn. But I am not having this particular value. Sorry, I don't want this particular value. What do I want? I want un convolution with H of n. What I want? Un convolution with H of n. So what I can do? In place of n, I can put n plus 1. In place of n, what I am doing? N plus 1. And this H of n is as it is. That means I am giving it a shift of 1. What I have done? I have give it, look, already n minus 1 was there. So I gave it a shift of 1. So the same shift I need to give here as well. The same shift I need to give here as well. So what I am getting? Un convolution with H of n, which is equals to S of n, and that would be equals to delta of Cn plus 1. Say yes or no. And what else I can do? S of n the step response will be equals to delta of c plus cn plus 1. What that would be? What is delta of xn? Delta of xn is the same signal minus the previous sample. So the same sequence c of n plus 1 minus the previous sample. This is your s of n. There you go. So in the examination hall, I can do this process. So if I am given the ramp response, can I find the step response? Yes. This was given. C of n will be given. So from there you can find C of n plus 1, and from there you can find S of n as well. So this is how you will be finding it. Is that clear to you or not? A very, very good process, right? Step response is given, you need to find impulse response. So what is given? Given is, what is given? Step response is given. That is, if your input is u of n, convolution with h of n. This I need to find. This is my impulse response. So this is something that I need to find. H of n only I need to find. Right? So what I will do? Again, differentiation I can make. Convolution with h of n. One thing I know, what this will be equals to? Delta of n. Convolution with h of n. Right? What this would be equals to? Anything convolved with delta of n is equals to h of n only. So what is your impulse response? That is delta of Sn. So h of n is coming out to be Sn minus Sn minus 1. There you go. So this is your impulse response. So nowhere I am asking you to remember a single formula. I am just asking you to remember the process. No, nothing you need to remember. Okay, just have the faith on the process. Well and good. Let's solve the question if this kind of question is coming in the examination also. So two questions are there. That step response is given. You need to find the system response when the input is n. So step response is given. What is given? What is given? S of n is given, and that is equals to un convolution h of n. H of n you are considering as impulse response. Impulse response. Okay. In the first question, what I need to find? I need to find ramp response because this is R of n only. So here I go to know that what I need to find. I need to find. I'm saying that my output is y of n. I need to find the output. I need to find the output, or I need to find the step response. So I can write down C of n. Sorry, not step response. Sorry, I need to find ramp response. So if my applied input is R of n, convolution with h of n. So this is something I need to find. What I need to find? I need to find C of n. How can I get that? What I can notice here is that if I do delta of Cn, so what I will get here? Delta of Rn, convolution with h of n. What is delta of Rn? That is u of n minus 1. If you don't remember, you will derive it there. H of n, right? Delta of Cn. This is what you are getting. Secondly, you know that you are not given the value of un. You are not given the value of un minus 1 h of n. What value you are given? Un convolution with h of n. But what you need to make? You need to make un minus 1 convolution with h of n. That means if I give a shift of 1 here, so here also shift of 1 will be given, right? So what this would be? This would be shift of 1. This is your delta of Cn. Say yes or no? So what will be your Cn now? So your Cn would be the running integration of the k minus 1. All this process we have already done. So I need to take the running integration of this particular thing, but minus 1. So what is my s of k? S of k is this particular thing. This is equals to your s of n. This is your s of n, right? So what is given? S of n is given as s of n is 2 delta of n plus 1, 2 delta of n plus 1 plus delta of n plus delta of n minus 1 plus delta of n plus delta of n minus 1. So what will be my S of k minus 1? So in place of n, what you need to put? K minus 1. So what you will get? In place of n, I need to put k minus 1. So 2 delta k plus delta k minus 1 plus delta k minus 2. Next, what I need to do? I need to take the running integration. Or what you can do? What is the meaning of running integration? What do you understand by running integration? Running integration simply means convolving with u of n. Say yes or no. Can I write down this particular thing as this? How would I solve this particular thing? I would take the running integration of s of n minus 1. Yeah, this is the same thing. So in place of k, I am putting n only. You can take the running integration as well, you can take the convolution as well. But here what I can sense is that taking convolution will be easy. Why is that so? Why it would be easier? Because all are delta function, no? All are the impulse sequence. If all are the impulse sequence, then taking the convolution will be a very, very easier path. Convolution with u of n. That would be equals to c of n. So what I need to do? 2 delta of n plus delta of n minus 1 plus delta of n minus 2. Convolution with u of n. So what I will get? Anything convolved with delta n. Anything convolved with delta n will be the same. Anything convolved with the delta n will be the same. Just shift will be shown. So this will be the ramp response. There you go. In the examination hall, if my concept is very clear, if I have good enough problem solving skills, then what I will think? Step response is given, I need to go to the ramp response. That means I need to take the running summation. Running summation of this particular thing, what that would be? 2u of n plus 1. Why is that so? Because I remember that running summation of delta k was u of n. I remember this thing very easily, right? So that would be 2u of n plus 1 plus 2u of n plus u of n minus 1. But will that be answer? No, because you remember that the running summation of step function is equals to r of n plus 1. But actually you need r of n. So in place of n you need to put n minus 1. So in place of n I will put n minus 1. In place of n I will put n minus 1. And in place of n I will put n minus 1. So this would be the answer. So 2u of n plus 2u of n, this 2 will not come. 2u of n plus u of n minus 1 plus u of n minus 2. 2u of n plus u of n minus 1 plus u of n minus 2. Did you understand how did I solve it? Look, the thing is, the running summation of step sequence, what I am saying, running summation of step response will give you not properly ramp response, but it will give you the ramp response plus 1. Have we seen this thing here? The running summation of this we can see, right? Or what I can write from here, c of n plus 1 would be equals to minus infinity to n s of k. This I can write. Basically here n minus 1, in place of n you put n plus 1. So what will happen? This will become n only. Here c of n plus 1 will come, and this is s of k will remain there as it is. So what did you understand? What did you understand from here? That running summation of step response is giving you ramp response, but n plus 1 it is giving you. So whatever the answer that you are getting, you need to subtract minus 1 from all the brackets. So here I need to take running summation only. I need to take running summation of all these. What that would be? 2u of n plus 1 plus un plus u of n minus 1. But this is not my final answer. In the final answer, in place of n, I need to put n minus 1. So what will be the final answer? 2u of n plus u of n minus 1 plus u of n minus 2. This is the answer I am getting. All this process I will do in the examination hall if I don't remember anything. Like here, if you remember 0 things, still you are able to solve it. As of now, you feel like that, sir, yes, I can remember it, but in the examination hall, there will be a lot of things. In your mind, there will be a lot of things, there will be a lot of pressure that how to solve a particular problem. So there, all these things will not click. That's why I always go with the process. This process can click there that I need to find ramp response. Okay, so this is what I will write. Then I will take the difference. If I take the difference, delta of Rn, even if I don't remember the final result, then I can derive it there. Then I get to know that yes, it is coming out to be delta of delta of Cn is coming out to be S of n minus 1. But what do I need? I need the Cn. I need the Cn. That means I need to take the running integration. So can I take the running integration? Yes, the running integration simply means you need to convolve it with un. So can I convolve it with un? Yes, I can convolve it with un. So this is the answer I will be getting. Well and good. It will not take much time in the examination hall. Now in the second question, it is neither step response, it is nor ramp response, it is neither impulse response, it is nothing. It is a random signal. X of n is a different kind of signal, right? So in the question B, what you need to find? You need to find your y of n, that is x of n convolution with h of n. So here you need impulse response. Say yes or no. Basically a system is there. Here a random x of n is applied. It will have some impulse response. A random x of n is applied, and you need to find y of n. So that y of n is x of n convolution with h of n. So you need impulse response. And for the impulse response, what is the information given? You are given with the step response. So what is given? Given is step response. S of n is already given. That is equals to u of n convolution with x of n. So what you can do? Take the difference. What you will be getting? Difference of un will be, not x of n, h of n. H of n. So what you are getting? Convolution with h of n. What that would be equals to h of n only. So what you are getting? Your h of n is s of n minus s of n minus 1. Because what is difference of Sn? Difference of Sn is equals to S of n minus S of n minus 1. So what is S of n? So what will be your H of n? H of n will be equals to S of n. What is S of n? 2 delta of n plus 1 plus delta n. 2 delta of n plus 1 plus delta n plus delta of n minus 1 plus delta of n minus 1 minus, in place of n you need to put n minus 1. So what that would be? 2 delta of n plus delta of n minus 1 plus delta of n minus 2, right? So these kind of questions require high patience in the examination hall. I always say one thing, gate examination is never an examination of speed, it is the examination of accuracy. If there is a good student, he will never say that sir time was less. Never ever the time would be less. You will solve these problems in a very hurry. Then plus minus sign would be there, somewhere you are forgetting to, all these errors will happen and your rank will be affected drastically. So always these kind of questions requires good amount of patience. I would say every question requires good amount of patience. So have the patience here. Solve it with the patience. Slowly you need to solve it. So what we are getting? Nothing will happen to 2 delta of n plus 1. Delta of n minus 2 delta of n, that will be minus delta of n. Delta of n minus 1 minus delta of n minus 1, both will be cancelled out, and this will be delta of n minus 2. So what is this? This is your impulse response. What you need to find? You need to find y of n. Y of n. What is that equals to? X of n convolution with h of n. What is x of n? X of n is 1 by 2 to the power n un. 1 by 2 to the power n un. 1 by 2 to the power n un. Convolution with 2 delta of n plus 1. 2 delta of n plus 1 minus delta n minus delta of n minus 2. Right? So 2 is the common factor that can come outward. 1 by 2. In place of n, what I need to put? N plus 1. Basically anything convolved with impulse sequence will be the same sequence, but in place of n you need to put n plus 1 because there is a shift of 1. So there is a shift of 1. Anything convolved with delta of n will be the same. Anything convolved with the delta of n will be the same. So this would be the answer, y of n. So this would be the response of that particular signal. Okay. So what we are doing here, is that clear to you? If I need to find the response for a random signal, it is neither step response, it is nor ramp response, it is neither impulse response. I need to find the response for a random signal or for a random sequence. So what I need to do, I need to get my impulse response first. So step response was given. From there easily I could have found the step response. From there I could have found the impulse response from the step response, that was s of n minus s of n minus 1. From there I found out this is my impulse response. So if I have the impulse response, that means I have the value of h of n, I have the value of x of n, then certainly I can find y of n. So just I need to do the convolution. So when I did the convolution, it was very easy for me. 2 into 1 by 2 to the power n u of n plus 1 minus 1 by 2 to the power n u of n minus 1 by 2 to the power n minus 2 u of n minus 2. So this is the answer. This is the gate problem only. In gate examination, they asked y of 0. So what you will do, you will put n equals to 0 here. So if I put n equals to 0 here, what I will be getting? 2 into 1 by 2, that would be 1 minus. Here I will put n equals to 0 minus 1. If I put n equals to 0 here, u of minus 2. U of minus 2 is already 0. So this term will not come into action. Right? I will put n equals to 0 here. So this term will not even come into action because u of minus 2 is already equals to 0. So 1 minus 1, answer would have been 0. So this is a gate PYQ only. In 2021 it was, I guess, in 2021 or 2022 as far as I remember. So this was a good question. Although these kind of questions can be solved with jet transform as well. So there also you will get another approach. So in the examination hall, I am saying this thing again and again. When you solve a particular question of signal system in the examination hall, at least you will be having 2 to 3 approaches. Okay, by the end of this subject. So this is all about LTI systems. Okay, so that's the end of LTI systems. So this is the classification of system. I did not show you beforehand. We directly started from linear, non-linear. Then we studied time invariant and time variant, and then we studied LTI. Now we need to study all these. These are very easy, very straightforward. So we will study all these, and then again we will come back to LTI system. LTI system is not completed here. We will study all these kind of types. Then again we will come back to LTI system. Some basic property we are going to see about the LTI systems. All good for you? I hope this classification is clear. I hope the flow is clear. So next we will start about static, dynamic, causal and non-causal. These 4 kind of system we are going to see in the next lecture. So this will be the flow of our subject. Okay, well and good. So let's meet in the next lecture. Thank you very much. Hi everyone, welcome back. So now we need to study about static, dynamic, causal and non-causal signal. Basically we have studied about linear, non-linear, time invariant, time variant, LTI. Now we will study about static, dynamic and causal, non-causal system. Okay, so let's get started with static system and dynamic system. So what is the meaning of static system? The present output will depend on present input only. What is the meaning of that? Let's see this particular example. Yt is equals to xt plus 3. That means if I apply the input xt, what will be my yt output? Xt plus 3. What does that mean? If I put t equals to 1, what I will get? Y1 equals to x1 plus 3. So output at t equals to 1 depends on the input at t equals to 1. If I make the time window, this is for output and this is for input. So output at t equals to 1 depends on the input at t equals to 1. So this is t equals to 1 only and this is also t equals to 1 only. So present output is depending on the present input only. But what about this one? If I put y2, here, what I will get? In place of t, what I am putting? 2. So what I am getting? 4. That means in this particular example, the output at t equals to 2 seconds is depending on the input at t equals to 4 seconds. That means to get the output at t equals to 2 seconds, you need the value of x4. And what is x4? Let's just say this is the graph of xt. This is the graph of xt. So you need the value at t equals to 4 seconds to get the output at t equals to 2 seconds. So for getting the output at t equals to 2 seconds, you need the value at t equals to 4 seconds. You need the input value at t equals to 4 seconds. That means you need the future value. This is 2, this is 4. So you need the future value. What does that mean? That means this is your dynamic system. Okay, so this is known as dynamic system. And if it is only depending on the present input, then it is known as static system. Okay, so here if you put y equals to, let's just say y equals to -1, then what I am getting? X equals to -1 plus 3. That means the output at t equals to -1 second is depending on the input at t equals to -1 second. Ignore these three. I only need to look at xt and yt. So output at t equals to -1 second is depending on the input at t equals to -1 second. That means present output is depending on present input only. Here your present output is depending on the future input. What I mean to say is that present output depends on future input. On future input. That means to give the output at t equals to 2 seconds, you need the input value at t equals to 4 seconds. Then only you will be able to tell what will be your x of 4. So y of 2 is equals to x of 4. That means you need the input value at t equals to 4 seconds to tell the output value at t equals to 2 seconds. So present output depends on future input. What if I put in place of t what I am putting 1 by 2? In place of t what I am putting 1 by 2. So what I will get? X of, in place of t you need to put 1 by 2. So what you are getting? 1 by 4. So here your output at 0.5 second is depending on the input at 0.25 second. 0.25 second. So output at 0.5 second, output at 0.5 second is depending on the input. 0.5 would be somewhere here. Output at 0.5 second is depending on the input at 0.25 second. That means present output is depending on the past input. Present output is depending on the past input. Present output depends on past input. So basically the condition is if it is depending on the present input only. Here what is the scene? Present output depends on present output depends on present input. So here the scene is if your present output depends on present input, then it is static, otherwise it is dynamic. So here someone will say that, sir, what if you put t equals to 1? So here also your present output is depending on present input only, but it is depending on future as well, it is depending on past as well. So if there is only one condition which will not satisfy present output depending on present input, then it will be dynamic only. That means always this should be satisfied, then only it will be static, otherwise it will be dynamic. So that's why I have written here not static. So if your present input is not depending on the, if your present output is not depending on the present input only, then it will be dynamic. Okay, so only one condition you need to make it dynamic, but to make it static, you need to always satisfy that your present output should always depend on the present input. Okay, well and good. So let's remove it off. So this is the definition. We will certainly see more example, it will be more clear to you. So have the patience, just watch the lecture till the end. By the end of this video, everything will be clear. Same kind of system is causal and non-causal. Okay, so causal system means present output can depend on the present and past input. Okay, it can depend on present or past input. Present output depends on present or past input. That means here past is also accepted. Future is not accepted, past is also accepted. So how do I remember that a gate aspirant should be static? A gate aspirant should be static. That means you should be focusing on present only. You should not be talking about past. You should not be talking about future. That, sir, I got this much rank last year. What will happen to me? Can't comment. Should not be thinking about that. Your present is you are studying this particular topic. So a gate aspirant should be static. He should be thinking about the present. What will happen in gate 126 or in gate 127? I don't care. What has happened in gate 125? I don't care. As of now, I am studying this subject. So gate aspirant are static. For causal, what do I remember? I remember CPP. That means for causal system, present output, for causal system, present input and past input both are accepted. Present output depending on present input and past input as well. So for causal, present and past both are accepted, but static, a gate aspirant is static, that means he should be focusing on present only. So this is how I remember, because in longer run you would be thinking, sir, what was static, what was causal? Causal was present past or static was present past. So gate aspirant is static, that means he is only focusing on present, and CPP, causal, past and present. So in causal system, your output can depend on past and present input. Let's see this example. Let's talk y of 1. What will be y of 1? Y of 1 will be equal to x of minus 1. What does that mean? That your output at t equals to 1 second is depending on the input at t equals to minus 1 second. So past input. Present output depends on past input. So if it is depending on past input, you are fine with that. It can be causal. If I put 0, what you are getting? X of 0. So present input. So what do you see here? It is either depending on the past input or it is depending on the present input. So it is causal. No. You did not check the negative values, no? Put t equals to minus 1. What you will get here? X of 1. So your output at t equals to minus 1 second is depending on input at t equals to 1 second. So t equals to minus 1 second and t equals to 1 second. So your output at t equals to minus 1 second is depending on the input at t equals to 1 second. What does that mean? That means here it is depending on future input. So all three conditions are satisfied here. Past, present and future. If only past and present was there, then I would be happy. I could have called it causal. If only present was there, then also it is causal. Only past is there, then also it is causal. Past and present both are there, then also it is causal. But if there is future input, if your present output is depending on a future input, that means it will be non-causal. So this particular system is non-causal. Okay. We have studied causal signal, non-causal signal. That was a different concept. That has nothing to do with this particular concept. Okay. That signal was different. This is system. We are studying causal system now, causal and non-causal system. There is nothing called anti-causal system. Okay. Only causal system and non-causal system. We have studied causal signal, anti-causal signal. What was causal signal? That it was HT, or you can say it was non-zero for t greater than 0. And what was anti-causal? It was non-zero for t less than 0. Otherwise, it would have been 0 only, right? And what was non-causal? Which is neither causal, nor anti-causal. That was non-causal signal. So this we have already seen. But now we are studying system. Now what about this one? Here your present output will always depend on the past input only. It can never depend on the future. So your target would be to make your output depend on the future input. Because if it is depending on the future input, then your job is done, it will be non-causal. Otherwise, it will be causal only. So if I calculate y of 1, what I am getting? X of minus 1. So present, your output at t equals to 1 second is depending on the input at t equals to minus 1 second. Your output at t equals to 1 second is depending on the input at t equals to minus 1 second. That means past. You put 0, minus 2. Your output at t equals to 0 second is depending on input at t equals to minus 1 second. Again past. Put any value, because here it is t, here it is t minus 2. So t will always be greater than t minus 2, no? Right? So your present output will always depend on the past input only. Say yes or no? From here what you can see is that t is always greater than t minus 2. This is the condition always satisfied. Here t is greater than minus t. Can you say that this is always true? No, this is not always true. This is also acceptable. But is this true? No. But this is always true, no? T is always greater than T minus 2. T is always greater than T minus 2. What does that mean? That your present output at T equals, your present output at T second, your present output at T second will depend on the input at T minus 2 second. Your output at T second will depend on the input at T minus 2 second. So that means always it will be depending on the past input. What does that mean? Either past or present. If there is no future, that means it will be causal. Okay. If it is not depending on the future input, that means it will be causal only. So what I will tell here is that T is always greater than T minus 2. That means it will be causal. Okay. Well and good. More examples. Let's see more examples. So checkpoints. Checkpoints for causal, non-causal, static, dynamic. Now we will see the examples. It will be more clear to you. So usually I will check at 1, -1, 0, 2, -2. Sometimes I can check at 3/2, like rational value I can check, or sometimes I can check at pi as well. So these kind of values I will check, or -3/2 also. So these values I will check mostly. Okay. And when I am talking about causal and non-causal, then my target would be to make it depend on future. If it is depending on future, then my job is done. It will be non-causal. And when I am checking static and dynamic, my target would be to make it not depend on present. What will be my target? To make it not depend on present. So let's check for this one. First we are checking static and dynamic. What is in my mind? In my mind, first I need to check static or dynamic. Static or dynamic. So in my mind, target is that it should depend either on either on past or future. This is my target. It should not be depending on present. This is the target, right? So what I can do is that I can put T equals to -1. If I put T equals to -1, what I will get here? What I will get here? Mod of -1. Mod of -1. What that would be equals to? X of 1. So what you are getting from here? Y of -1 is equals to x of 1. So your output at t equals to -1 second is depending on the input at t equals to 1 second. T equals to -1 second, 1 second. Your current output is depending on the future input. So if it is depending on the future input, what does that mean? It is dynamic. Dynamic. And if it is depending on future, what does that mean? It is non-causal as well. So this would be our target. We are not going to check for all the points, but target should be clear in our mind, that causal, non-causal, causal CPP, present and past. If it is depending on future, it would be non-causal. That's the target. Static, dynamic. If it is not depending on the present, then it would be dynamic. Well and good. Let's check this example. So let's go with the static and dynamic. Okay. Static and dynamic. What is there in my mind? Static, dynamic is there in my mind. I am not going to write it. I am just writing static or dynamic. So what would be your y of 1? Y of 1 would be x of 1 plus u of 7. Will you say that, sir, your output at t equals to 1 second is depending on the input at t equals to 7 second? No, this is not the input. What is the input? You need to look at the block diagram. What is the input? Input is xt, and what is the output? Output is yt. So only you need to look at xt and yt only. Whatever the other signal is there, don't care about that. Only I need to look at input and output. So my present output is depending on the present input only, because my t will always be equals to t. T will always be equals to t. So your present output will depend on present input only. Present output always depends on present output depends on present input only. That means it is static. And just tell me one thing, if it is static, then 100% it will be causal. Say yes or no. If it is static, that means it is certainly not depending on future. If it is not depending on future, that means it cannot be non-causal. So it has to be causal. So if it is static, then 100% it will be causal, because static means it is only depending on present. So if it is depending on present and past, causal is fine with that. So that means it will be causal as well. X of at, you can take any random value of a. Let's take let a is equals to 1 by 2. Okay, a is equals to 1 by 2. Just a cannot be 1. This should be given in the question. A cannot be 1 because if a is 1, then yt equals to xt it will be. So that we already know, that is static and causal. So what I am checking, a equals to 1 by 2. So yt equals to x of t by 2. So if I put y of 1, what you are getting? X of 1 by 2. So it is depending on past, right? But if I check y of minus 1, then what it would be? X of minus 1 by 2. So it is depending on future. If I check y of minus 1, that means output at t equals to minus 1 second. Output at t equals to minus 1 second is depending on the input at t equals to minus half second. So minus half is greater than minus 1, right? Minus half is greater than minus 1. That means your output at t equals to minus 1 second is depending on the input at t equals to minus 1 by 2 second. That means it is depending on future. So if it is depending on future, so if future is there, then it would be non-causal. And certainly it will be dynamic because past, future, everything is there. So certainly it will be dynamic. You can check for any other value as well. You can check for any other value of a. It will always be non-causal and dynamic unless a is equals to 1. Check for any other value. Check for 2. If a is equals to 2, what will happen? Yt equals to x to t. I can directly see here is that y of 1 is equals to x of 2. At t equals to 1 second, depending on t equals to 2 seconds. Future. If future is there, what does that mean? It will be non-causal. And if it is non-causal, certainly it will be dynamic. Because if it is non-causal, that means it is depending on future. Certainly it is not depending on present only. If apart from present, if it is depending on future or past, it will be dynamic only. So if future is there, non-causal and dynamic. Right? Let's take the negative values. Let's take minus 2 here, minus 2 here. So what I will do? I will put t equals to minus 1. If I put t equals to minus 1, so again at t equals to minus 1, what value I will get here? X of 2. So again my output at t equals to minus 1 second, output at t equals to minus 1 second is depending on the input at t equals to 2 second. So again future, right? So again future, again non-causal and dynamic. So yt equals to x at, no matter yt equals to x at, no matter whatever the value of a is there, it will always be non-causal and dynamic. So you don't need to mug it up, you will analyze in the examination hall. These are very, very easy, very straightforward. Yt equals to ft into xt. There is any random function ft is there. So what do you think, what will be the answer? It will be static and causal. Why is that so? Check at y at t equals to 1. Do you care about this particular function? It could be a function of t square as well. It could be anything. Here I am writing f of gt. What I am writing? F of gt. It could be anything. I don't even care about this thing. F of gt dot xt. I don't care about this particular thing. I don't even care about this particular thing. What I care about is xt. So whatever that is there, that remains as it is. F of g of 1, or let's write down t square. So f of g of 1, I don't care about that. I only care about xt and yt. So present output depends on present input only. Present. From here you can directly see that t will always be equals to t. That means it is only always depending on static. It is always depending on the present input only. So it is static, and if it is static, then certainly it will be causal, right? Static and causal. Let's go to this one. F of xt. I only need to look at input. I will only look at the bracket of input. That's it. I only need to look at input. No matter whatever that is there outside, I don't care about that. Y of 1 will be equals to g of 1. Here t square could also be there. F of x of 1. So what did you get to know? Present output, present input. T is equals to t. That means again static and causal. So here if I put 2, here it will be G of 4, but I don't care. I only care about X. So your present output is depending on present input. So static and causal, right? X of sin t, X of sin t. So again put the values. What I can put? Let's put y of pi. In place of t, what I am putting pi. Why is that so? Because I know the sin pi will be 0. Sin pi will be 0. So y of pi would be equals to sin pi is 0. Pi is 3.14. Pi is 3.14. Right? So present output is depending on the past input. So this is about the past, but I need to make it future. How will I make it future? Y of minus pi. What that would be? X of sine of minus pi. Whether it is sine pi or sine of pi or minus pi, it will always be 0. What is the value of sine of minus pi? That is 0 only. So y of minus pi would be equals to sine pi is 0 only, and minus pi can be written as minus 3.14. So here your present output is depending on the future value. Minus 3.14 is lesser than 0. This is future, right? So past is there, future is there. What does that mean? Non-causal. Future, if future is there, that means non-causal, and certainly it will be dynamic. X of cos t, same thing you can do, right? If I put t equals to 0, yeah, t equals to 0, what I am getting? X of cos of 0. What is cos 0? Cos 0 is 1. So y of 0 is equals to x of 1. So this is depending on future. If it is depending on future, your job is done. If it is depending on future, that means certainly it will be non-causal. Along with that, it will be dynamic. Because in static, it will always depend on present only. And if future is coming, that means it will be non-causal for sure. X of n plus x of n minus 1. What do you think? What will be the answer? Let's check. Y of 1 will be equals to x of 1 plus x of 0. So output at t equals to 1 second is depending on the input at t equals to 1 second and 0 second. So this is present, and this is your past. It is not depending on future. If it is depending on past, from here only you can say that certainly sir it is dynamic. That's for sure. But my target is to make it depend on future. Will it ever be possible? Because you know that n will be equals to n. But this n will always be greater than n minus 1. So there is no way I can make it depend on future. Can you make it depend on future? No. No matter whatever the value you put. If you put a minus 1, or let's put minus 2. So x of minus 2 plus x of minus 3. So present output is depending on the past and present input. So always it is past. That means it is causal and dynamic. Causal and dynamic. Okay. What about this one? N is always greater than 2n minus 1. Is that true? N is always greater than 2n minus 1. That means this output will always be greater than input. No. This is only true for minus n is greater n less than 1. So that means if you put n equals to 2. So let's put n equals to 2 here. What I need to put? N equals to 2. So what I am getting? X of 2 plus x of 3. So your present output is depending on the future. What is this? Future input. Output at t equals to 2 seconds is depending on the input at t equals to 3 seconds. So if it is depending on future, then it is non-causal and dynamic. So how will you think in the examination hall? You will just see the bracket of x. You will get to know that n can, if n is always greater than 2n minus 1, this is not possible. Here n is always greater than n minus 1, yes. Because from here what you are getting, if you subtract n on both of the sides, 0 is always greater than minus 1, yes. So this inequality is always satisfied. But n is always greater than minus 1. Here what I am going to write is that n is always greater than 2 and minus 1, not always true. Not always true, right? If this was true, that means your output would have depended only on the past input, but this is not the scene here. It is depending on the future input as well. So that's why it is non-causal and dynamic. So very easy chapter it is, right? Very straightforward chapter. Nothing like there is very rare chance that you will get it wrong. What you will do here? Will you do like this? That sir, y of 1 will depend on d by d1 x of 1. This is not what we do, right? This is not how we differentiate. If I need to differentiate at a particular time window t, what do we do? Let's just say I make a signal of xt. Okay, this is a signal of xt. I need to differentiate at 1. I need to differentiate at t equals to 1. So how I will define it? What I need to find? Y of 1. So what that would be? That I will take the value at 1 plus, right? I can take the value at 1 plus minus the value at 1 divided by 1 plus minus 1. Or what I can do? I can take the value at 1 and then I take the value at 1 minus divided by 1 minus minus 1. Is that clear to you? How do you define that differentiation? You take 1 ahead, like basically we used to write it down in this manner. T plus delta t minus t divided by delta t, tending delta t to 0. Same thing I am doing here. Your value of x, this is the graph of x of t. So value of x at 1 plus, what I am finding? Y of 1. So value of x at 1 plus minus value of x at 1 divided by 1 plus minus 1 divided by this gap, divided by this gap. Or what I can do? The value at 1 minus the value at 1 minus divided by 1 minus 1 minus 1 minus 1 minus, but basically this gap. If both are equal, then only your differentiation is defined. If both are equal, then only your differentiation would be defined. Say yes or no, right? So someone will say that sir, this is the definition of a differentiation. Someone will say that sir, this is the definition of differentiation. From here, one thing I am getting to know is that it is depending on future, it is depending on past. What is this? This is your past, this is your future. So one thing is for sure that sir, it will be dynamic. That's for sure. That it is not only depending on present input. It is depending on past as well, and here it is depending on future as well. But someone will say that sir, this is the definition of differentiation, and someone will say that sir, this is the definition of differentiation. So if I look at this definition, I will say it is non-causal, and if I look at this definition, I will say it is causal. So in the examination, if they ask this particular question, then they will tell you that what kind of definition you need to use for differentiation. What this is known as, if you remember in your 11th 12th class, you would have studied it. We call it right hand derivative. Right hand derivative. What is this side? This is the right hand side. So this is known as right hand derivative. And what this is known as? Right hand derivative. And what this is known as? This is known as left hand derivative. So if your differentiation is defined with respect to the right hand derivative, that means it is non-causal. And if it is, this is your present, right? This is your present. And if it is defined with respect to left hand derivative, that means present and past, it will be depending on present and past, then it would be known as causal. So you cannot say that your differentiator is a causal system or non-causal system. It will be depending on the definition. But one thing for sure, that my differentiator is dynamic, because even if you go by this definition, then it is depending on past, so it is dynamic. And even if you go by this definition, then it is depending on future, so it is dynamic. So certainly it is dynamic for sure. That's for sure, right? Let's go to the integrator. So think about it. Think about it. What is your yt? Yt is the integration from minus infinity to t x of tau d2. So can I make the graph of x of tau? This is the graph of x of tau. Okay, this is the graph of x of tau. Let's just say I need to find the value of y of 1. So what I will do? minus infinity to 1 x of tau d tau. So limit of tau will go from minus infinity to 1, minus infinity to 1. So at tau equals to 1, what is the value? This is x of 1. What I need to find? Y of 1. So that means I need to calculate the area from minus infinity to 1. That means I need to calculate this much area. This much area I need to calculate. Now to calculate this particular area, I would be needing all these values, right? This value, let's just say this value would be x of 0. This value would be x of minus 2. This value will be x of minus 7. So to calculate this particular area, I would need the value of x from minus infinity to 1. So I need all the past values and the present value as well. But I don't need the future value. Do I need the value of x of 1.1? Let us say this is 1.1. Do I need the value of x of 1.1 to calculate this particular integration? No. So to find the value, to find the output value at t equals to 1 second, I need the input values from minus infinity to 1 second only. I don't need the future value. That means I only need the past values or the present value, not the future value for sure. So what I need? Past and present. Past plus present. But I don't need future. If I don't need future, that means it is causal. And if I need past, certainly it will be dynamic. A very good concept. Did you understand this point? I hope you would have understood the logic here. So you will draw the diagram and you will think, okay, if I take a particular value, then from where to where I need to integrate, and from where to where I need to integrate, so what all values I require? What about this one? Minus infinity to 2t. So think about it. If I need y of 1, what will be the integration? Minus infinity to 2 x of tau d tau. So I need to calculate the area from minus infinity to 2 second to calculate the output at 1 second. So this is my x of tau. So to calculate the output at t equals to 2 second, to calculate the output, this is the limit of tau. So limit of tau should be going from minus infinity to 2 second. So to calculate the output at t equals to 1 second, I need all these values because I need to calculate this area. If I need to calculate this area, so I will be requiring the value of x of 2 as well. I will be requiring the value of x of 1.5 as well. Let's just say this is x of 1.5. This is your x of 1.5, right? I would be requiring the value of x of 1.1 as well. So I require the past, present and future value. Basically, to calculate the output at t equals to 1 second, I require x of 1 as well, right? I require x of 0 as well. So from minus infinity to 2 second, whatever the input value is there, I require all these values. From minus infinity to 2 second, whatever the input values are there, I require all these values. And what does that mean? It is depending on future value as well. That means it is depending on time t equals to 2 second as well. Like if it is depending on t equals to 2 second, that is not the matter of concern. The matter of concern is here I would require the x of 2 as well. So if I require x of 2, that means I need the input value at t equals to 2 second. And if I need the input value at t equals to 2 second, then there is the problem. So it is depending on future as well, right? So basically it is depending on past plus present plus future. So if it is depending on future, then job is done, non-causal and dynamic. Right? What about the difference in discrete time? So difference in discrete time is defined as x of n minus x of n minus 1. So this is the way it is defined. So your y of n is equals to x of n minus 1. From here you can directly see that your present output will depend on present input and past input, because you know that n will always be greater than n minus 1. So it is depending on present plus past only. No future is there. If no future is there, what does that mean? It would be causal. and since it is depending on past, it will be dynamic. Okay, causal and dynamic. From minus infinity to n, the summation, what is this? This is your running summation, right? Similar to running integration. So how I can write it down? Can I write it down in this manner? Or what I can see, let's calculate y of 1. Y of 1. So what will be y of 1? Y of 1 would be k goes from minus infinity to 1, x of k. How I can write it? X of 1 plus x of 0 plus x of minus 1, in that manner x of minus infinity, right? So your present output is depending on present input and past. So this is present and rest all are past. There is no future, only past is there. Can you make it depend? Can you somehow make it depend on future? No, you cannot make it depend on future. Why is that so? Because what is your y of 1? Your y of n is actually x of n plus x of n minus 1 plus x of n minus 2. In that manner it will keep on reducing, plus x of n minus 3 to x of minus infinity. So this is the present, but you always know that your n will be always greater than n minus 1, it will always be greater than n minus 2, it will always be greater than n minus 3, and so on. That means it will always depend on present and past. So present and past is there, so certainly it will be causal only. Causal and dynamic. Causal and dynamic. It is a very simple lecture. Very simple lecture. Nothing is there. What about this one? Mod is there. I will take the negative value, y of minus 1. And there you go. K goes from minus infinity to mod of n. What that would be? 1. X of k. What I am getting? X of 1 plus x of 0 plus x of minus 1 plus x of minus 2. In that manner till x of minus infinity. So your output at t equals to minus 1 second is depending on input at t equals to 1 second. What is this? Future. And as soon as you get future, your job is done. It will be non-causal, right? And if it is non-causal, certainly it will be dynamic only, right? So in this manner we need to solve the problem. What about these things? Even, odd, conjugate symmetry, conjugate antisymmetry, and then we need to check real and imaginary. After that we will solve this question, and then segmented one we will see. So yeah, in that manner we will proceed. So let me take a pause. You try solving this question. Even, odd, conjugate symmetry, conjugate antisymmetry, real part, imaginary part. These are very simple. You can do it on your own. So let me take a pause, and then I will come back. Okay, so let's get started. X of n plus x of, we saw all these examples with respect to continuous time. Now we are saying it with respect to discrete time. So just for a change I did this. Okay, you could have done it with the continuous time as well. Like previously for LTI system, for linear time invariant, for those we were seeing it with respect to continuous time. So that's why I thought I should make a change. Now we are seeing it with respect to discrete time, but things are same, the concept is same, right? X of minus n divided by 2. So can it depend on future? Yes. What you will put? Y of minus 1. So y of minus 1, what that would be? X of 1, sorry, x of minus 1, x of minus 1 plus x of 1 divided by 2. So at t equals to minus 1 second, it is depending on t equals to 1 second, right? So it is depending on future. You can directly see that n is greater than minus n. This is not always true. This is only true for n greater than 0. If your n is less than 0, then yes, it will come into action, right? So yes, this is non-causal, and if it is non-causal, certainly it will be dynamic. Same goes for odd part as well. X of n minus x of minus n divided by 2. This is also non-causal and dynamic. Conjugate symmetry, x of n plus x conjugate of, conjugate will make no impact. The problem is with this negative sign. The problem is with this negative sign. For n less than 0, that means if your n is -1, then it is creating some issue, because your y of -1 will be depending on x of 1. Although it will depend on the conjugate, but at least x of 1 value you will require. Let's just say x of 1 is 2j, then you will do the conjugate. So x of 1 and x of 1 value you will require, right? So for y equals to -1, x of 1 value you will require, that means you will require the future value. And if you are requiring the future value, then it would be non-causal and dynamic. Same goes here as well. Minus sign will not make any impact, just the problem is non-causal and dynamic. What about this one? Real part. What is the real part? X of n plus x conjugate of n divided by 2. So here it is depending on n only, here this is also depending on n only. That means your present output is depending on present input, here also present input. So always it will depend on present input, because you know that n will always be equals to n will be always equals to n. So what does this mean? That yes, it is depending only on present. Only on present. That means it is static as well as it is causal. Static and causal. What about this one? X of n minus x conjugate of n divided by 2j. So here also it is depending only on present. That means it is static as well and it is causal as well. Well and good. Okay. Let's go to the next one. Minus infinity to t x 2 to minus 3 d2. So you will tell everything about it. Like this example I should have taken in linearity as well. Everywhere I should have taken it, but I forgot to take it. So you will tell every single thing about it. Linearity also you need to tell, time variance also you need to tell, causal, non-causal system also you need to tell. Along with that you need to tell this static and dynamic system as well. So whenever you see this kind of condition, what is the scene? The scene is your input was xt, right? Input was xt. Then there was some integrator. You don't know, this is not a standard integrator that you can directly see, because if it was standard integrator, there x of tau would have been there, but x of tau is not there. That means certainly it is not a standard integrator for sure, right? So your input was x of t and your output was y of t. So standard integrator it is not there. So whenever you see these kind of questions, your target would be to make here x of tau. Make here x of tau. You can change the limit. What did I tell you? If you remember, if this changes, then limit changes. So what would be my target? My first target would be to make the relation in terms of y of t is equals to integration x of tau d2. The limit could be anything. Then it would be easy for me to solve. So this is how we will solve the problem based on integrator. What is the target? That what I will do, 2 tau minus 3 is equals to alpha. That means if tau is equals to minus infinity, then alpha will be equals to minus infinity, and if tau is equals to t, then alpha will be equals to 2t minus 3, right? If tau is equals to t, then alpha will be equals to 2t minus 3. So minus infinity to 2t minus 3 x of alpha 2t minus 3, that means 2 d tau is equals to d alpha. So d alpha by 2. So what we are getting? 1 by 2 can come outward, but this 1 by 2, this factor doesn't matter anywhere. 2t minus 3 x of alpha d alpha. So this alpha can be replaced with tau now. So y of t is equals to 1 by 2 minus infinity to 2t minus 3 x of tau d2. So in this manner I will reduce it. Okay, this is my target. In this manner I will reduce it. So what this system was doing? This system was, first it was multiplying with 1 by 2 and then it was integrating, taking the limit from minus infinity to 2t minus 3. Okay, minus infinity to 2t minus 3. 2t minus 3. This is what it was doing. So this is the relationship now. Now can you tell me whether it will be linear or non-linear? Certainly it will be linear. Directly I can see. Right? Because x1 tau I will throw, x1t I will throw, x2t I will throw, then x1t plus x2t, then simply the multiplication 3x1t I will throw. So x1t plus x2t, then it can be broken, and 3x1t, 3 can also be taken out, right? So this is certainly linear, right? Linear you can check on your own, you can check. What about time variance? Will it be time variant or invariant? So what did I tell you? In place of t, you put t minus t naught. So what is the first task? In place of t, 1 by 2 is there as it is. In place of t, you will put t minus t naught. So 2t minus 2t naught minus 3 x of tau d tau. And what is the second task? The second task says that whatever that is there, everything remains as it is. Just inside here you put t naught. So if you need to replace this t naught here, then how it will go? This can be replaced like 1 by 2 minus this t naught can directly go here. Or you can, what you will do, t minus t naught is equals to alpha, then d tau is equals to d alpha, then limit will be changing in this manner only. What I mean to say is that what you can do, tau minus t naught is equals to alpha. So d tau is equals to d alpha. If how the limit will change now? 1 by 2 integration. If tau is equals to minus infinity, then alpha is also minus infinity. If tau is equals to 2t minus 3, then alpha is equals to 2t minus 3 minus t naught, x of alpha d alpha. Now this alpha can be replaced with tau as well. So this is the second thing you are getting. This and this both are not same, because here the difference is minus t naught, here the difference was minus 2t naught. So both are not same, that means it is, what does that mean? So this was linear for sure, but this is time variant. Secondly, time variant we have seen. Next, what I need to check, actually I needed to check what I needed to check. I needed to check about the causal, non-causal, static and dynamic. So for that I will add a page. Just 1 second. So again I will copy my signal. Output signal is 1 by 2 minus infinity to 2t minus 3 x of tau d tau. 2t minus 3 x of tau d tau. Right? So if I need to calculate y of 1, what that would be? 1 by 2 minus infinity. 2 minus 1 will be minus 1. That means I will be taking the integration from minus infinity to minus 1. So past, it is depending on past, right? Basically, output at t equals to 1 second is depending on input from minus infinity to minus 1. I hope this is something that you remember. This was the graph of x of tau. So you need the value still minus 1 only. That means you need the value x of minus 1. So till this particular point you need all these values to get the output at t equals to 1 second. So till this point it is fine, but t can be less than 2t minus 3 as well, right? That means minus t is less than minus 3, so t is greater than 3. So if you put the value of t greater than 3, then there will be some issue. Put the value of t equals to 4. So what will be your y of 4? Minus infinity to, put 4 here. 4 to ja 8, 8 minus 3 will be 5. X of tau d tau. So here you are taking the integration from minus infinity to 5. What you are doing? You are taking the integration from minus infinity to 5. Now you would require the value of x of 5 as well. You would require the value of x of 5 as well. So all these values you require. So certainly it is depending on past, but output at t equals to 4 second is depending on input at t equals to 5 second. So it is depending on future as well. Future plus past plus present. So in the integrator, this is how you need to see. You need to look at this particular thing, that this can be greater than, sorry, 2t minus 3, this limit 2t minus 3 can be greater than t. Yes, it can be greater than t for t greater than 3. So if your t is greater than 3, then it will be depending on future as well. So yes, it is depending on future, and if it is depending on future, then it is non-causal and dynamic. Okay. What about this segmented system? So yt equals to x of minus t for t greater than 0. and it is equals to x of t for t less than 0. So for t less than 0, again we need to break it down. For t less than 0, yt equals to xt. That means this present will depend on present only. So there is no issue. Present only, it is depending on present. For t greater than equals to 0, yt equals to x of minus t. So t is always greater than minus t. T is always greater than minus t for 2t greater than 0, or you can say for t greater than 0. So if your t is greater than 0, then certainly this guy will always be greater. Basically, this will be always greater than this particular thing. If your t is greater than 0, you cannot put t equals to minus 1 here. You cannot put t equals to minus 1. What I mean to say is that, can I put t equals to minus 1 here? No. I can only put the t greater than 0 values. Only I can put positive values. So what if I put t equals to 1? So y of 1 will be equals to x of minus 1. That means it is depending on your output at t equals to 1 second is depending on the input at t equals to minus 1 second. That means it is depending on past. So it is depending on present and past. It will never depend on future, right? Because t will always be greater than minus t for t greater than 0. And here it is only depending on present only, here it is depending on past, right? So what does that mean? This is your causal. And since it is depending on past, that means it is dynamic as well. So causal and dynamic. What about this one? Think about it. Think about it. For n greater than 0, what does that mean? Can I put y of pi here? Can I put y of pi? No. N has to be integer, right? N has to be integer. So I cannot put y of pi here. What I will put? Y of 1. So for n greater than 0, what we are checking? For n greater than 0, y of 1. That would be equals to, okay, first I will write down the definition. For n greater than equals to 0, y of n is equals to x of sin n. Okay. So what will be y of 1? Y of 1 will be equals to x of sin 1. What is the value of sin 1? 1 is in the radian. That would be, I guess, 0.8 something. Okay, 0.8 something. So y of 1 would be output at n equals to 1 is depending on the input at n equals to 0.8 past. So n is always greater than sin n. Yes, this is true actually. Okay, this is actually true. N is always greater than sin n for n greater than 0. For n greater than equals to 0. This is true. You can remember it. N is, or you can remember in this manner, that t is always greater than sin t for t greater than 0. Okay, and t is always less than sin t for t less than 0. And for t equals to 0, both are equal only. So anywhere, yeah, this thing you nahi. For t equals to 0, both are equal only, no? Basically, for t equals to 0, you will put t equals to 0 here, so it would be 0 only. If you put t equals to 0 here, sin 0 is also 0. So for t greater than 0, t will always be greater than sin t. We prove all these kind of things in mathematics. Like we will assume a function f of t that will be t minus sin t. Then what we will do? We will do the differentiation, that is 1 minus cos t. And I get to know that this differentiation will always be positive. That means your slope is always positive. Say yes or no? So if your slope is always positive, so at t equals to 0, what is the value you are having? 0. Slope is always positive. Slope is always positive. Slope is always positive. So if your slope is always positive, that means graph will always be increasing. And if the graph is always increasing, at t equals to 0, you are having the value 0. So after that, the value will be positive only. And before this, the value will be negative only. So for t less than 0, the value are negative. That means this value is less than 0. For t less than 0. For t less than 0, this particular thing is less than 0. That means t is less than sin t. And for t greater than 0, this value is greater than 0. That means t is greater than sin t. Did you understand this mathematics? Look, I cannot teach you the whole concept of engineering mathematics here. This we have studied in 11th, 12th class as well. We will assume a particular function, then we will differentiate it. In that manner we do it. So those who know mathematics, they would have understood it. But if you don't know mathematics, then also it is fine. You can just remember it. Okay, or you can take examples. Take example. What will be the value at t equals to 2? 2 will be always greater than sine 2. Do it in your calculator. 2 is fine. Here you are putting 2 in radian. So what will be the value of sine 2? You can check in your calculator. Whatever the value you will get, certainly it will be lesser than sine 2 only. Why is that so? Because 2, the value of sine can maximum go up to -1 to 1. So sine 2, whatever it is, it can never be greater than 2. So for t greater than 0, t will always be greater than sine t. Right? That means it will always depend on the past value. N will always be greater than sine n. What you can check? Y of 2 you can check. So y of 2, sine 2. So this is also past, because you know that 2 will be always greater than sine 2. What you know? 2 will be certainly greater than sine 2. So again it is depending on past only. So for n greater than 0, we are done, that it is depending on only past for n greater than 0. What about n less than 0? What about n less than 0? So for n less than 0, y of n is equals to x of n square, right? So here n is equals to n. So it is depending on only on present value. No matter whatever the function of xn is there, I don't care about that. Y of 1 will be equals to x of 1 square. Say yes or no? So your output at n equals to 1 is depending on input at n equals to 1. So it will only depend on present. So what did you understand from here? This is depending on past, this is depending on present. So your output is depending on either on past or on present. What does that mean? That means it is causal. Along with that it is dynamic, right? Causal and dynamic. There you go. Very easy. Which of the following statements are correct? This is the last question. After that our causal, non-causal, dynamic and static, everything is completed, and very easily we have completed it. Static system are memoryless. So what is the meaning of memoryless and with memory? So memoryless means memoryless. That means it will always depend on present input. And what about with memory? With memory means it will depend on past or present or future. Or what do I mean by that? Present input only, that means output. Memoryless means present output depends on present input only. So basically static system are known as memoryless element, or you can say memoryless system. Sorry, I should not say element, I should have called system only. So static system, the other name of static system is memoryless system. Why is that so? Because they don't have any memory. They neither have past memory nor they will create a future memory. They only focus on present. So no past, no future. If there is some past, if there is some future, that means there could be memory. So static system are memoryless, yes. Dynamic system are with memory, yes. If it is a dynamic system, then certainly it would be depending on past or on future. I don't know whether on past or future, but certainly it has to be dependent on past or future. So if it is depending on past or future, that means it is having some memory. So dynamic system are with memory. Static system are memoryless, dynamic system are with memory. That means either they have past memory or they will create some future memory. Right? All memoryless system are causal system. Is that true? Yes. All memoryless system. Memoryless system means it will always depend on present. So it is not depending on future. If it is not depending on future, if future is not there, that means certainly it is causal. So all memoryless systems are causal system. All causal system are memoryless. All causal system are memoryless. What is the meaning of causal? Causal means present plus past or past. Present or past, basically it can have past as well. Causal system can have past as well, and past means memory. So causal system can have memory. So this statement is not true. So A, B, C are correct, D is not true. All causal system are not memoryless. Some can be memoryless, some cannot be memoryless as well. All good. So the other name of a static system is memoryless system. That's it. The other name of static system is memoryless system. Well and good. So this particular topic is also completed. We have studied about causal, non-causal, static and dynamic. Next, what we need to study? We need to study about stable, unstable system. Stable and unstable system. So that will be our next task. So what is stable system and what is unstable system, that we are going to see now. Okay. Thank you. Hi everyone. So before moving on to the next topic, this will be a short video. Here we will be covering again linearity, non-linearity, time variance, time invariant, causal, non-causal, static and dynamic. All these things we are going to see again, but in terms of differential equations. If a particular differential equation is given, will that be linear, non-linear, time invariant, time variant, causal, non-causal, static or dynamic? So how to analyze that particular differential equation, this is what we are going to see. So first, a simple question is there, yt equals to dxt by dt. Is it linear or non-linear? It was linear only because we have already seen. First I will throw x1t, what output I will get? dx1t. dx1t divided by dt. Just one second. Next what I will throw? I am calling this output as y1t. Next what I will throw? x2t. So what output I will be getting? dx2t divided by dt. Then I will throw x1t plus x2t. x1t plus x2t. So what I will get? This is the output I will be getting. Right? I am calling this as y alpha t. Is this equivalent to y1t plus y2t? Because dy dt x1t is y1t. dy dt x2t is y2t. So it is equivalent to y1t plus y2t. y1t plus y2t. So y alpha t is equivalent to y1t plus y2t. That means additivity is followed here. And what about homogeneity? So for that what I will throw? I will throw 3x1t. So here I am calling that output equals to y beta t. So if I throw 3x1t, all these things we have already seen, but we need to make some interesting conclusion out of it. That's why I am doing the process all over again. So this is coming out to be 3y1t. So y beta t is also coming out to be 3y1t. That means here homogeneity is also followed. That means it is linear. What about this particular thing? Yt goes to xt dot dxt by dt. What I am doing? xt dot dxt by dt. Will that be linear? Do the same thing. Throw x1t, throw x2t, throw x1t plus x2t, then throw 3x1t. So first I will throw x1t. What I will get? This I will get. Then I will throw x2t. What I will get? This I will get. Then I will throw x1t plus x2t. So what I will get? x1t plus x2t. So whatever the input is there, that comes as it is, and then in the multiplication it will be differentiated. x1t plus x2t. Right? So how I can write it down? Certainly it is not equals to the addition of these two. If I call this one as y1t, if I call this one as y2t, and I am calling this as y alpha t. So y alpha t is here directly what thing I can see, that my y alpha t is certainly not equals to y1t plus y2t. That's for sure. This is for sure. Right? Just one second. This is for sure. What does this mean? That this is non-linear, because additivity is not followed here. So this is non-linear. So yt goes to dxt by dt, you are fine. But again there is a multiplication of xt. With dxt by dt there is a multiplication of xt that is doing all the problem. Right? Let's see more example. We just need to make some conclusion. Here the question is dyt by dt is equals to xt. So from here what I can see, yt is equals to minus infinity to t x of tau d2, right? Differentiation goes into integration. So I know that, yeah, integrator was a linear operator. It was a linear system only. But I can solve it without even converting into integration. What I can do is that first I will throw x1t. So with respect to x1t, my output will be y1t. Then I will throw x2t. With respect to x2t, my output will be y2t. Then I will throw x1t plus x2t. Then I will throw x1t plus x2t. So what will be my output? This will be my output. What this is equivalent to? What is x1t? dy1t by dt. And what is x2t? dy2t by dt. Okay. If you compare these two, this and this, if you compare these two, what you are getting? That your y alpha t is equivalent to y1t plus y2t. And this is what you wanted, right? This is what you wanted, that if I throw x1t, my output is y1t. If I throw x2t, my output is y2t. If I throw x1t plus x2t, my output is y1t plus y2t. So when I throw x1t, my output is y1t, but the equation will be dy1t by dt is equals to x1t. When I throw x2t, my equation will be dy2t by dt x2t. And when I am throwing x1t plus x2t, this is the equation I am getting. And when I compared these two, what I am getting? This particular thing I am getting, that my y alpha t is equals to y1t plus y2t. So this is followed. And what about homogeneity? For homogeneity, what I need to throw? I need to throw 3x1t. So what will be the equation? Y beta t by dt would be equals to 3x1t, and that is equivalent to 3 y1t by dt. And from here what you get to know, that y beta t is equals to 3 y1t. So here homogeneity is also followed. So additivity, homogeneity, both are followed. What does that mean? This is linear system. Well and good. So this was linear, this was non-linear, and this was linear. So with respect to y, if there is differentiation, no issue. With respect to x, there is differentiation, no issue. But if xt is multiplied or divided as well, like this could have been written as yt by xt, dxt by dt. So if xt is multiplied or divided with dxt by dt or with yt, basically if x and y are in multiplication of each other, or x and x is multiplication of each other, or y and y are in multiplication of each other, then there is an issue. We will see more example, it will be more clear to you. Here x and y are in multiplication of each other. So what I will throw? First I will throw x1t. So what output I will get? y1t. What equation I will get? Can I write down the equation in this manner? Right? Then I will throw x2t. What output I will get? y2t. Then I will get this equation. Now I will throw x1t plus x2t. So what output I will get? Y alpha t. What I am throwing? x1t plus x2t. And what is my output? Y alpha t. So one thing I am certainly sure here, or you can break it down as well. In any manner you can break it down. Y alpha t plus x2t into y alpha t. One thing I am pretty sure, that my y alpha t is not coming out to be equals to y1t plus y2t. So additivity is not followed. What does that mean? It is non-linear. So here x is in the multiplication of y. Previously in this case everything was fine. In this case x was in multiplication of x. So whenever these multiplications are there, then there is an issue. But multiplication should be done with respect to x or y. Are you getting this point? X, y are in multiplication. Let's see more example. Here multiplication is done with respect to x, but multiplication is done by t. Here it is not xt dot xt, neither it is yt dot xt, it is t dot xt. So this is neither input nor output, this is simply a function of t. Are you getting this point? In place of t you could have put ft as well. In place of t I could have put ft. Better I should put here ft. What I am doing? ft xt. And one thing also I am mentioning, that ft is not equals to xt, and it is not equals to yt as well. So it is a random function of t. So just let me know whether it will be linear or not. So let's check out. I will throw x1t, I will get y1t. I will throw x2t, I will get y2t. I will throw x1t plus x2t, I will get y alpha t. So ft x1t plus ft dot x2t. So ft dot x1t is equals to dy1t, and ft dot x2t is equals to dy2t. So dy alpha t is equals to dy1t plus y2t. What does that mean? Y alpha t is equals to y1t plus y2t. Is there any issue? No. Will there be, so here additivity is followed. Will there be any issue with homogeneity? Absolutely not. What you need to do, you need to throw 3x1t. So my y beta t would be, if I am throwing 3x1t, so ft remains as it is, dot 3x1t. So 3 goes outward, ft dot x1t. What this would be equivalent to? Ft dot x1t, that would be 3 dy1t divided by dt. So y beta t is 3y1t. Right? So here homogeneity is also followed. What does that mean? It is linear. So either your xt is multiplied with any function or yt is multiplied with any function, that doesn't matter. Linearity will still be followed. The only issue is if xt is multiplied with xt, or xt is multiplied with yt, or yt is multiplied with xt, or yt is multiplied with yt. So if x and y are in multiplication, or x and x is in multiplication, or y and y is in multiplication, then there is an issue with linearity. Otherwise no issue is there. Are you getting this point or not? Let's see one more example here. dxt by dt whole square. Basically it is dxt by dt dot dxt by dt is equals to yt. This is the scene here. dxt by dt dot dxt by dt is equals to yt. So what I will do, I will throw x1t, x2t, x1t plus x2t, and in that manner I will check. Certainly I know that it will not be linear. You can also tell without even checking, because there is square, no? So square will not result in linear. But let's check for your happiness that I will throw x1t, what I am getting, y1t. Then I will throw x2t, what I will be getting, y2t. And then I will throw x1t plus x2t, what I am getting, y alpha t. So how I will open it up? This will be opened as, oh sorry, x1t plus x2t whole square is there, no, sorry. This was the scene, right? x1t plus, in place of input you will put x1t plus x2t and then you will do the whole square. So a square plus basically this square, a square plus b square, or if you are not able to understand, this is simple mathematics, nothing else. Can I write it down in this manner? d by dt x1t plus d by dt x2t, right? And whole square I need to do. How it will be opened? A square plus b square. So till this point everything was looking fine, but the issue came, a square plus b square plus 2ab. So dx1t dx2t. This is equals to your y alpha t. So certainly your y alpha t, here this was your y1t, here this was your y2t, but here this is the extra term, right? So your y alpha t is coming out to be y1t plus y2t plus 2 under root y1t plus y2t. Whatever it is coming out to be, I don't care actually, but one thing I am pretty sure, that your y alpha t is not equivalent to y1t plus y2t. And what does that mean? That means it is non-linear, right? Although all this process was not even required, directly you could have checked there is a square. If there is a square, then certainly there will be some issue. So here a differentiation of x is multiplied with differentiation of x. Basically x is being multiplied with x. X is being multiplied with the random function, no issue. X is being multiplied with y, yeah, non-linear. This is simple equation, no issue there. X is being multiplied with x, non-linear. This is simple equation, no issue. I hope the conclusion is clear now. So you don't need to mug up these conclusion. If you see these equations, first one very simple, linear. Now will you call this linear and non-linear? Sir, there is square. There is square, but this square represents that you are doing the differentiation twice. It doesn't mean it will be non-linear. It will be linear only. Basically, what this is, d by dt, then d by dt of xt. So it will be linear only. This square doesn't mean that you are doing the square with respect to x. No. 2 times you are differentiating, or you can try as well. I will throw x1t, then I will throw x2t, then I will throw x1t plus x2t, and then I will throw 3x1t. Then you will get to know that y alpha t is equals to y1t plus y2t, y beta t is equals to 3y1t. So certainly it is linear. This square doesn't mean you are doing the square of a function. No. This square means you are doing the differentiation twice. So this is also linear. Will there be any issue in this particular equation? No. T is being multiplied, no issue. Xt, straightforward. Twice differentiation, no issue, linear. T is being multiplied, no issue. Straightforward, no issue. Issue comes here, that you are doing the differentiation twice, but you are taking the square as well. So if you are taking the square, then there is an issue, but that means x is being multiplied with x, non-linear. So looking at the differential equation, you will be able to tell this will be a linear system or non-linear system. These kind of questions you see in mathematics as well. But in mathematics, we confine ourselves with linearity only. But this is not mathematics. We need to study linearity, time invariance, then static, dynamic, causal, non-causal. So all these things we need to study. What about this one? 3 time differentiation, no issue. But here the issue comes, that xt is being multiplied with xt. Till this point also there was no issue, but then I got to know about this thing. Xt is being multiplied with xt, non-linear. No issue, no issue, no issue, no issue. Xt as it is, no issue. T multiply with yt, no issue at all. 3 multiply with constant value multiply with anything, no issue. And this is double differentiation, no issue, non-linear. No issue here, no issue here, but the issue comes here. Yt is being multiplied with yt. Oh sorry, no issue there, no. So it is linear, really sorry. There is no issue in the whole. So this is linear, this is non-linear, right? Here there was no issue. Multiply with 3, multiply with the function of t, xt directly, d square yty dt. But here d square yty dt square. That's why it is non-linear. What about this one? No issue, still no issue. But xt being multiplied with yt, non-linear. Is that concept clear to you? xt yt, xt xt, yt yt. Then there is issue. It could be in terms of differentiation as well. It could be the direct function as well. If you are multiplying your xt with ft, or if you are multiplying your yt with ft, no issue. Yt is being multiplied with ft. Ft means a function of t. Here I could have done t square as well. There was no issue. But issue comes here. Here I could have done square as well. Right? Still there was no issue. It would be linear only. Here I could have given a square. Square doesn't mean that it will be linear, non-linear now. No. This is a ft. Ft could be anything. We have seen this example, right? Here we have seen this example. If ft is being multiplied with xt, or ft is being multiplied with yt as well, I don't have any issue. The issue is if x and y are in multiplication. All clear? So that's it about linearity and non-linearity. Now the same concept we need to see for time variance and invariance. Time variance and invariance. So let's get started. So what is the method that I told you? What was the method? That first you replace t with t minus t naught. First you replace t with t minus t naught. And then in the bracket of x, whatever that is there, that remains as it is, minus t naught. Both are same, linear. Sorry, time invariant. Time invariant. If both are different, then time variant. The same thing you need to do with y as well. What I need to do? First, replace t with t minus t naught. First, replace t with t minus t naught. So the same thing I am doing here as well. Then in the bracket of y, whatever that is there, that remains as it is, minus t naught. Similarly, in the bracket of y, whatever that is there, that remains as it is, minus t naught. Are both of these equations same? Yes. If both of these equations are same, then it is time invariant. Previously, I told you a trick that only you see with respect to x. But if I need to include y as well, although I need to see here only, my job will be done. But if I need to include y as well, so what I will do, whatever that I was doing with x, the same thing I will be doing with y as well. Let's see more example. T into xt. So what I will do? Previously, how I used to solve? Whenever you see t, put t minus t naught. Whenever you see t, put t minus t naught. Then, whatever that is there, that remains as it is. In the bracket of x, put t minus t naught. In the bracket of x, just put minus t naught. All these equations, both of these equations are same? No. Both are not same. That means time variant. Now what I'm going to do? I'm going to do the same thing with y as well. So, in place of t, put t minus t naught. In place of t, put t minus t naught. In place of t, put t minus t naught. Then what next you need to do? Whatever that is there, that remains as it is. In the bracket of x, in place of t, in the bracket of x, whatever that is there, that remains as it is. Just subtract minus t naught. In the bracket of x, whatever that is there, that remains as it is. Just subtract minus t naught. Similarly, you need to do here as well. In the bracket of y, whatever that is there, that remains as it is. Just subtract t naught. Are both of these equations same? Here y t minus t naught is this. Here y t minus t naught is this. Both are not same. What does that mean? It is time variant. What about this? This will be time invariant. So what I will do? In place of t, put t minus t naught. In place of t, put t minus t naught. In place of t, put t minus t naught. That I know dt naught will be 0 only. So d by dt x t minus t naught. What about with respect to y? Again, what next thing I need to do? So whatever that is there, that remains as it is. In the bracket of x, just put minus t naught. Here as well, whatever that is there, that remains as it is. In the bracket of y, put minus t naught. Are both of these equations same? Yes, both are same. What does that mean? Time invariant. So although there is no need to look at this particular thing, only we need to look at this particular thing only. And in the last lectures, we were doing the same thing. When I was taking time invariance, I was only looking at the equal sign, whatever that is written after equal. Only there I was looking. I was not even looking before that. But I can look before that as well, that what is happening with respect to y. So if both are same, then it is time invariant. If both are not same, then it is if both are same, then it is time invariant. And if both are not same, then it is time variant. Right? What about this one? In place of t, put t minus t naught. Next task, whatever that is there, that remains as it is. In the bracket of x, just put minus t naught. Similarly, here as well, in place of t, put t minus t naught. In place of t, put t minus t naught. So from here, what you get to know, dt naught will be 0 only. So d by dt, y of t minus t naught is equals to x of t minus t naught. And what will be the second task? Whatever that is there, that remains as it is. In the bracket of y, just put minus t naught. Whatever that is there, that remains as it is. In the bracket of x, just put minus t naught. So this equation and this equation, both are same, time invariant. Now what about this? Xt is being multiplied with y dy ty by dt plus yt is equals to 0. So what is the first task? Wherever you see t, put t minus t naught. Wherever you see t, put t minus t naught. So wherever I see t, I am putting t minus t naught. Right? What will be this dt minus t naught? That would be dt only. Because here in the bracket, what I am writing, dt minus t naught is equals to dt. What is the next task? whatever that is there, that remains as it is, just in the bracket of x, put minus t naught. Whatever that is there, that remains as it is, just in the bracket of y, put minus t naught. Whatever that is there, that remains as it is, in the bracket of y, put minus t naught. Are these two equations same? Yes. Both of these equations are same only. What does that mean? Time invariant. So let's see the conclusions, what is happening. This was time variant, time invariant. This is a simple equation between y and x. Yt equals to dxt by dt. No issue, time invariant. This is a simple differentiator. So differentiator is time invariant, we know it. Here if your xt is being multiplied with the function of t, xt is being multiplied with t, then there comes the issue. xt is being multiplied with t, then there comes the issue. Because in the second task what we do, whatever that is there, that remains as it is, just in the bracket of x we change. What if this question was yt equals to sin t dot xt, then also it will be time variant only, right? Because in the first task what I would have done, that in place of t you put t minus t naught, in place of t you put t minus t naught. In the second task, whatever that is there, that remains as it is, in the bracket of y put minus t naught, whatever that is there, that remains as it is, in the bracket of x put minus t naught. So are these two equations same? No, that means it is time variant. So if there is a function of t, then there comes an issue. So here ft dot xt is a problem, or ft dot yt is a problem, or yeah, these two are the problems only. If xt dot yt is there, is that any problem? See this example, xt dot yt, is there any problem? No, because I know that in the second task, in the bracket of both minus t naught will be put, so they are not creating any problem. The only problem is ft dot xt or ft dot yt, because in the second task this ft will remain as it is, and that will create the problem, and in the first task this t will be replaced with t minus t naught. In the second task ft remains there as it is, so that creates the problem. Just because of this, the equation doesn't come equal, and then it becomes time variant. Is this conclusion clear? Are you able to think about it? Are you able to think about it? I hope this is not tough. You are able to think about it. A very, very good point. If I want to frame a good problem, I will ask the question given that differential equation, and there people will keep on analyzing. What about this particular equation? Here xt is being multiplied with d square yt by dt, dt square actually, right? It would be dt square, right? So dyt by dt square xt plus yt plus is equals to xt. So here no function of t is being multiplied either with xt or yt. Xt multiply with yt, no issue. Yt multiply with yt and then multiply with xt. Here what is happening? Yt, then multiply with yt again, and then multiply with xt. But there is no other function of t. Yt alone, xt alone, no issue at all. It will be time invariant only. We can check as well. What is our task? First task. In place of t, put t minus t naught. In place of t, put t minus t naught. dt square. Can you let me know what is the meaning of this? D t minus t naught square. Sorry. Previously you were doing the differentiation with the t with respect to t. Now you are doing the differentiation with respect to t minus t naught. Twice you need to differentiate. So basically you need to differentiate t minus t naught twice. So if I do the differentiation of t minus t naught once, what I am getting? Dt. And then again I need to differentiate this dt only. What I will get? D square t only. You will not do like this, that sir, here I will open it up, t square minus t naught square plus a square plus b square minus 2ab. This I can do that then sir, dt square, then dt naught square will be 0, and what about this 2t naught dt? This is absolutely wrong process. What is the meaning of this particular thing? The meaning of this particular thing is t minus t naught should be differentiated twice. What is the meaning of this particular thing? That d of t minus t naught, right? This is the meaning of this particular thing. So first you need to differentiate t minus t naught once. what you will be getting? dt only, because dt naught will be 0. And what this can be written as? T is differentiated twice, d square t. So this is equivalent to d square t only. So what this is equivalent to? Or d square t, since it is in denominator, I will write dt square. Basically, dt is being again differentiated. So dt square. So this is equivalent to dt square only. Did you understand the point here? What I was doing, in place of t, I need to put t minus t naught. What is the meaning of that? dt minus t naught square. That means you need to differentiate t minus t naught twice. Initially, you were differentiating with respect to t, but now you are differentiating with respect to t minus t naught. So first you will differentiate t minus t naught, you are getting dt only. And then again differentiation, that means that it is dt square only. So you are differentiating actually with respect to t only. With respect to t only, you are differentiating twice. Is that clear to you? All good? Right? Here, in place of t, put t minus t naught. In place of t, put t minus t naught. This was the thing of bracket. In place of t, put t minus t naught. Plus, in place of t, put t minus t naught. Then in place of t, put t minus t naught. In the second task, what I need to do? Whatever that is there, that remains as it is. In the bracket of x, just put minus t naught. In the bracket of y, just put minus t naught. In the bracket of y, just put minus t naught. In bracket of x, just put minus t naught. In the bracket of y, just put minus t naught. In the bracket of x, just put minus t naught. So what does that mean? The same equation I will be getting. That means it is time invariant. So the conclusion is clear. If there is no function of t is being multiplied, then it will be time invariant only. And if there is a function of t, then it will be time variant. So this is creating a problem here. In the second example, this is creating the problem. What I am going to do is that in place of t, I am going to put t minus t naught. T minus t naught, it will be dt only. In place of t, I am going to put t minus t naught. What is the second task? The second task says whatever that is there, that remains as it is. In the bracket of y, put minus t naught. Whatever that is there, that remains as it is. In the bracket of x, put minus t naught. Are both of these equations same? No, they are different. And if they are different, what does that mean? It is time variant. So this function of t is creating all the problem. This function of t is creating all the problem. Here there was no issue, xt dy by dt, no issue here, no issue here. This particular thing, this function of t, what is this? This is a function of t. This is creating a problem. Okay. So now if you are given these things, no issue there. This was your linear and time invariant. This was also your linear and time invariant. What about this? Was this linear? No. This was non-linear. Along with that, it will be time variant as well. Why is that so? Because of this t. And this was linear only, really sorry. This was linear or non-linear? This was linear. In linearity, what was the issue? xt should not be multiplied with yt. xt alone, xt alone, xt alone, yt alone. So this was linear only. What about this one? This was non-linear because of this. And will it be time variant or time invariant? Because of this time invariancy, no issue. xt is being multiplied with xt, it will be time invariant only. But here, this t will create an issue. And because of this t, it will be time variant. Are you getting this point? Because of this t, it is time variant and it was non-linear only. Let's check here. Because of this t, it will be time variant. And was it linear or non-linear? It was non-linear because xt was being multiplied with xt. Non-linear. Because of this t, it will be time variant. Was it linear or non-linear? No issue here, no issue here, no issue here, no issue here. It was linear. Right? In the linearity, if t is being multiplied, no issue. But if xt is being multiplied with yt, there is issue. xt multiplied with xt, issue. yt multiplied with yt, there is an issue. Right? Here yt multiplied with yt, that means it is non-linear. Is it time variant or invariant? Time variant. Because of this, let's remove it off. Let's remove this Let's keep it like this only. So now let me know whether it is time variant or time invariant. It is time invariant now, right? Time invariant. Why it is time invariant? Because yt being multiplied with yt, I don't have any problem. But t multiply f function of t multiply with xt or yt, then I have the problem, and which is not occurring here. What about this one? This t is creating the problem, so it is time variant. And these two are in multiplication, that means it is non-linear as well. So I hope you are able to analyze how to see the linearity and time invariance in a particular differential equation. So the bottom line is xt multiply with xt, xt multiply with yt, and yt multiply with yt. If that is there, then it will be non-linear. And if any function of t is multiplied either with xt or any function of t is multiplied either with yt, then there is an issue that will create time variance. So here what I am saying, xt multiply with xt, xt multiply with yt, and yt multiply with yt. All these three things combined will give you non-linearity. And function of t multiplies with xt and function of t multiplies with yt. All these things will give you time variance. This is the conclusion of the discussion of last 30 minutes. Very simple conclusion. You should remember it, because a good question will be framed on differential equation only. Well and good, right? So LTI system, this was LTI, then there is no LTI. Okay, only one LTI system we got. So a simplest example of LTI system, d square yt by dt square plus 3 dyt by dt plus 2yt is equals to xt. So here yt multiply with xt, xt multiply with xt, and yt multiply with yt. None is occurring, that means it is linear. Function of t multiply with xt, function of t multiply with yt, that is also not occurring, that means it is linear time invariant. Linear is also there and time invariant is also there. So this is a LTI system. Say yes or no. So this is our LTI system. Okay. Well and good. Now we need to study causal, non-causal, static, dynamic. So that we will study after a break. So let me take a break and then we will study about causal, non-causal, static, dynamic. So what do you think? All the differential equation will be static or dynamic? What do you think? All the differential equations will be static or dynamic? All the differential equation will be dynamic only. Because if you are doing the differentiation or if you are doing the integration, you have to look at the past value at least. I don't care about future. I am not talking about causal, non-causal. But if you talk about static and dynamic, what is the meaning of static? Gate aspirant should be static. That means he should be focusing on present. So static means it will always focus on the present. So present output should depend only on the present input. But if you are doing the differentiation, differentiation means you need to look at the past output as well. Or if you are doing the integration, so you need to look at the past input as well. Sorry, not past output, past input. So you would eventually require the past values as well. Past value of input or past value of output. So differentiation, if it involves differentiation or integration, it can never be static, it has to be dynamic. So all the differential equation will always be dynamic. All the differential equation will be always dynamic. So we don't need to care about static, dynamic, it will always be dynamic only. The problem comes with the causal and non-causal, and this is a very interesting concept that we are going to see. Okay, yeah. So let me take a pause and then welcome back. So we need to see the differentiator now. Okay, so now we need to tell whether it is causal, non-causal, static or dynamic. So will it be static or dynamic? So this we have discussed. If there is a differential equation, then certainly at least you would need a past value or you would need a future value. So if there is differentiation or if there is integration, it has to be dynamic. So every differential equation will be dynamic. It cannot be static, right? Only gate aspirant will be static, right? Now causal and non-causal. So this example we have already seen when we were studying our causal and non-causal systems. So at that time, what did I tell you? That it could be causal as well, it could be non-causal as well. So there, what was the explanation? I said that yt can be written as the differentiation. How do we write down? Limit delta t tending to 0, x of t plus delta t minus xt divided by t plus delta t minus t, that means delta t only. Or if I write down the left hand limit, this is known as right hand limit, right? And if I write down the left hand limit, that will be written as t minus delta t upon t minus delta t, so it will be delta t only. Also considering the fact that limit delta t tending to 0. So this is known as left hand limit. So if left hand limit and right hand limit both are equal, then only your differentiation is defined. Then only you can define the differentiation. So there I told you that if you consider this case, it will be non-causal because here it is depending on the future value. And if you consider this case, it is depending on the past and present value. So it will be causal. That is true as well. Somewhere in some textbook you will find that differentiation is a causal system, and somewhere in some textbook you will find that the differentiator is a non-causal system. Okay, some will say it is causal, some will say it is non-causal. But let me tell you one thing. So this is the way we used to define our differentiation, right? This is the way we used to define our differentiation. But can I define it in this manner, that this is my xt, that I need to define my differentiation here? So what I do, I pick a point delta t ahead. That means I pick one point here and I pick one point delta t backward. That means I pick one point here. So this will be my x t minus delta t and this will be your x t plus delta t. So can I define the differentiation in this manner? That limit delta t tending to 0, x of t plus delta t minus x of t minus delta t divided by t plus delta t minus t minus delta t. So it would be plus. So divided by 2 delta t. So if I am defining in this particular manner, so here what I will say, it is depending on future value and this is depending on past value. So from here what I will say, it is non-causal. So if someone in some interview, if someone is asking you that a differentiator is a causal or non-causal, so you will say there it is non-causal. If in the examination they are asking you it is causal or non-causal, so you will say it is non-causal. Okay, and there is another reason behind that. What is the reason? The reason is like if you convert it into the Laplace domain, so it would be ys equals to s x of s. So from here if you find out the transfer function, what will be the transfer function? Output divided by input. If you haven't studied it, you will not be able to understand, but if you have studied it, then only I am telling you. So what is the transfer function? Transfer function is s. Is it proper transfer function or improper transfer function? It is improper transfer function. So every improper transfer function is a non-causal system, and this we are going to learn in Laplace transform. In Laplace transform, I will prove that why every improper transfer function is a non-causal system. There I will prove it. Okay, because they are not practically realizable. Every practically realizable system is a causal system, and which is not practically realizable, these are non-causal system. As of now, we are not able to understand all these things. So just understand, if I calculate the transfer function and if it is coming an improper transfer function, this is improper, right? What is the meaning of proper transfer function? That a denominator will have the higher power and numerator will have the lower power. So this is proper transfer function. And if your numerator is having the higher power and denominator is having the lower power, this is your improper transfer function. So this is the improper transfer function. If you are getting improper transfer function, that means it will be non-causal system only. Okay, so this is a non-causal system. In the last lecture I told you it would be causal as well, it could be non-causal as well. That was with respect to that particular lecture only. But now we are seeing the complete differential equation. So the one conclusion from here, what did I make? So if you don't know all these things, Laplace transform, then just forget it. I don't know anything Laplace transform, what is Laplace transform, I don't know anything about it, about this particular concept. But what I can see, the degree of differentiation in x is more than the degree of differentiation in y. The degree of differentiation in x is more than the degree of differentiation in y. What does that mean? It means it will be non-causal. What is the degree of differentiation of x? That means it is being differentiated one time and y is being differentiated 0 time. So if your degree of differentiation of x is more than the degree of differentiation of y, that means you will result in improper transfer function, and if you are resulting in improper transfer function, that means the system will be non-causal. So as of now you need to remember it. In Laplace transform everything will be explained. As of now I cannot explain it with respect to this particular example. but I will give you two examples so that you will be able to remember in a good manner. One is the differentiator, other one will be the integrator. This is the integrator, right? dy by dt is equals to xt. So can I write down my yt as minus infinity to t x of tau d2? What does that mean? That I need to differentiate my x of tau, right? So what did I tell you? X of tau versus tau, limit goes from minus infinity to t. If I calculate, let's just say if I calculate y of 1, what does that mean? Minus infinity to 1 x of tau d2. So I would need the value from minus infinity to 1. So I need the value of x tau. That means this will be your x of 1. So to calculate this particular area, what all values I will require? X of 1, x of 0, x of half, x of minus 1, all these value I will require. X of half, x of 0, x of minus 1, x of minus 2. But I don't require any future value. So there I told you integrator is a standard integrator is a causal system, right? Because here you only require the past and present value. You don't require any future value. So that's why it was known as causal system. Say yes or no. We agreed on this. So here what did you get to know? The degree of differentiation of y is more than the degree of differentiation of x. The degree of differentiation of y is more than the degree of differentiation of x. It is causal system. And when you find out the transfer function, what you will get? Ys divided by xs, what that would be? Transfer function would be equals to 1 by s. It is a proper transfer function. That means it is practically realizable system. And if it is a practically realizable system, then it will be a causal system only. In Laplace transform, I will give you a complete explanation of this particular point. But as of now, you don't even know what is Laplace transform. You don't even know what is practically realizable system. You don't even know why this will be practically realizable and why this one will not be practically realizable. So all these explanation I will give you in the Laplace transform. So for that you need to wait. As of now, the conclusion is if the degree of differentiation of y is more than the degree of differentiation of x, then it would be a causal system. And will you be able to remember it? Surely you will be able to remember it. One example you will remember differentiation. Yt equals to d by dt of xt. So there what you will see, okay, this is a non-causal system. Differentiation is a non-causal system because I would require the past value as well, I would require the future value as well. So this is a non-causal system. So here I can see that degree of differentiation of x is more. So there you don't need to calculate the transfer function. What you will see, there is the degree of differentiation of x is more and degree of differentiation of y is lesser. And that means it will be a non-causal system. So for non-causal system, the conclusion is if the degree of differentiation is of x is more, then it would be non-causal, and if the degree of differentiation of y is more, then it would be causal system. So this is the explanation, and with respect to these two examples, you will be able to remember as well. Because integrator, you would see, okay, integrator means yt equals to minus infinity to t x of tau d tau. Integration mean I only require the past values, I don't require the future value. That means it would be causal. So integrator is causal, differentiator is non-causal. Then you will write down the expression integrator is causal. So you will write down something like this: dyt by dt is equals to xt. So this is your causal. This is your causal means degree of differentiation of y is more than the degree of differentiation of x. So it is a causal system. In that manner you will be able to remember. I am just telling you the way to remember, and then you will write down differentiator. So degree of differentiation of x is more than the degree of differentiation of y. Then you will say it is non-causal. So this is how you will remember. If you forget in the examination hall, then this is how you are going to remember, because remembering the statement is a very tough task, but remembering the example is easier. So example you can remember, and from there you can make the statement, right? And what if the degree of differentiation is same? Basically yt equals to xt. If this is the scene, yt equals to xt plus c. So it will be causal only, no? Right? Here also degree of differentiation is 0. Here also degree of differentiation is 0. So it will be causal only, because it will never depend on the future value. Degree of differentiation of xt is same as degree of differentiation of yt. So it will be causal system only, right? So if the degree of differentiation of yt is more than or equals to xt, if the degree of differentiation of yt is more or equals to xt, then it would be a causal system. So no need to mug up the statement. The bottom line is you don't need to mug up the statement. You need to think in the examination hall. So particular equation will be given, and from there we will think. So what is the first conclusion? The every differential equation is dynamic in nature. The second conclusion, order of differentiation of xt is more than the order of differentiation of yt. That means dxt by dt is equals to yt. So what is this? This is differentiator, and differentiator is non-causal. So this is how I will be thinking in the examination hall. Okay, and here degree of differentiation of xt is lesser than the degree of differentiation of yt. That means it will be dyt by dt is equals to xt. So here degree of differentiation of yt is more, xt is lesser. That means it is integrator. And if it is integrator, what does that mean? It will be causal only. And all these are considering the fact that xt is your input and yt is your output. All these conclusion we are making considering the fact that xt is the input or yt is the output, right? So here I should have written the order of differentiation of output, order of differentiation of input is lesser than the order of differentiation of the output. Then you can say it will be causal. Here also in the previous example as well, I was referring xt as input and yt as output. In all the examples I have referred yt as output and xt as input. I hope you know this particular thing, right? We have been always referring xt input, yt output. So that's why I have written xt yt here. So xt means input and yt means output. So quickly tell me the answer of all these things. Degree, what is the degree of differentiation here? 2. You will not say that sir here it is 0. You need to see the highest one. So degree of differentiation of y is 2. Degree of differentiation of x is 1. What does that mean? It will be causal. Degree of differentiation of y is 1. Degree of differentiation of x is 2. What does that mean? It will be non-causal. Degree of differentiation of y is 2 or 4? 2 and then square, it would be 4. No, differentiation is done only twice and then you are taking the square. So whatever the differentiation value you are getting, you are taking the square of that. It doesn't mean that you are doing the differentiation 4 times. First you do the differentiation 2 times. Whatever the value you get, you do the square. That means here the degree of differentiation is 2 only and here the degree of differentiation is 3. So what is this? Non-causal. What about this one? This is your non-causal. Degree of differentiation is 2. Degree of differentiation is 1. Causal. Shall I write down causal here? Wrong. X of t plus 1. We are talking about xt and yt. xt, yt, xt, yt, xt, yt, xt, yt. Nowhere I took x of t plus 1. Nowhere I took x of t plus 1. X of t plus 1 itself is telling that you need to look at the future value. X of t plus 1. If I put t equals to 1 here, that means I will do the differentiation of yt twice and then I will put t equals to 1. Here also I will put t equals to 1. But x of t plus 1, you need to look at the future value. T plus 1, that means x of 2 I need to look. So output at t equals to 1 is, your output at t equals to 1 is depending on the input value at t equals to 2. So already it is depending on future. So here you cannot tell by the degree of differentiation. So the thing is, degree of differentiation, all these things work if everywhere you see yt, yt, xt, yt, yt, xt, yt, yt, xt. But here you are seeing yt, yt, x of t plus 1, right? So it would be non-causal only, right? So that was a important thing, 2, 1, but because of this particular thing, it is non-causal. I can prove it again, okay? I can prove it with one example. What kind of example I can take? dyt by dt is equals to x of t plus 1. So here what you will think? That sir, degree of differentiation is 1, degree of differentiation is 0. So degree of differentiation of yt is more. That means it is like an integrator. Integrator means it should be causal. But no. Let's see it. Let's see. What will be your yt? What will be your output? Output will be minus infinity to tau x of tau plus 1, sorry, minus infinity to t x of tau plus 1 d tau. I told you this limit can go here, right? So I can interchange it with t plus 1 x of tau d tau. This thing we have already proved, right? Now if I need to find the value of y of 1, that means I need to integrate from minus infinity to 2. So to find the output at t equals to 1, I would require the value till t equals to 2. This is your, you will integrate from minus infinity to So x of tau versus tau. So what is this value? X of tau. So to find the value at t equals to 1, to find the output value at t equals to 1, you need to integrate from minus infinity to 2. That means you would require the value of x of 2 as well. That means you require the future value as well. What you require? You require the future value as well. You require the value of x at 2. You need to calculate this particular area. So you require the value of x at t equals to 2. So that means it is non-causal. And this is what I said. So just by looking at the degree of differentiation, you will never tell your answer. You will see these kind of input as well, that already it is depending on the future value. That means surely it will be causal. Surely it will be non-causal. So that's it. This is the complete discussion. A very short conclusion of this particular video is, first thing is this: xt dot yt non-linear, ft dot yt time variant, because here the issue will be with the t and here they will become square. That will create some issue. And from here every differential equation will be dynamic, and if degree of differentiation of xt is more than the degree of differentiation of yt, that means it has differentiating nature. If it is having differentiating nature, that means it will be non-causal. If the degree of differentiation of xt is lesser than the degree of differentiation of yt, that means it will have the integrating nature. Integrating nature means causal. But always be aware of these kind of examples where you are already referring to the future value of input. Here I am already referring to the future value of input. We proved it here as well, that already we are referring to the future value of input. That means I would require the value of input at t equals to 2 as well, although I am calculating the output at t equals to 1 only. That means it will be non-causal. So if a particular differential equation is given, will you be able to tell whether it is linear or non-linear, time invariant or time variant, static or dynamic, or causal or non-causal? This was a very important topic which is missed in a lot of notes. It is not taught in a good manner, which I have taught here. And when we go to our Laplace transform, there it will be more clear. I will again come back to all these things: LTI system, linearity, non-linearity. And in the next lecture we are going to study about stability, invertibility. So all these things will be discussed again there in Laplace transform. In Fourier transform as well I will be discussing LTI system. So this is the beauty of signal system. Everything that you are studying right from the beginning will be used till the next, in every new chapter. Whatever the new chapter you are studying, the previous things will be used. So every chapter is connected here. So that's the beauty of signal system. That's why I am saying that by the end of this subject you will be very comfortable in all the questions of signal system. And if you want to listen to me, I will tell one thing. You attempt the PYQs of signal system once after clearing the whole subject. Once the whole subject is done, then only go to the PYQs. Till that point you learn the concept, you solve the problems which I am giving in the classroom, whatever the assignments that I am giving, all these problems you solve. But once you are done with the complete subject, then only go to the PYQs. This I am telling only for signal system, not for all the subject. Okay, that kind of subject is signal system. In signal system everything is interrelated. Okay, every single thing like energy, power, all these things will also come into action again. So all these things are also interrelated. That's why I say this particular thing about signal and system. Okay, so let's meet again in the next lecture. Yeah, thank you very much. Hi everyone, welcome back. So in this video we are going to study about stable system, unstable system, invertible system and non-invertible system. So these are the 4 parts left. This is what we are going to see in this particular video. So let's revise something. Have we studied about bounded signal? In basics of signal we studied about bounded signal, right? What do you mean by bounded signal? That it should never be infinity. At any point of time, at any point of time t, function should never be equal to infinity. That's it. This is the meaning of bounded signal. Is this bounded? Yes. What is this? Signum function. This function is never going to infinity. At any point of time, this function is not going to infinity. Is this bounded? Yes. At any point of time, this function is not going to infinity. Is this bounded? Yes. So bounded, this is signum, this is unit step, and this is a square wave. This is known as square wave. This is a square wave. So I will be showing it using SQT, okay? Square wave, SQT. So this is a particular square wave. So this is also bounded because at any point of time, it is not going towards infinity. Same thing can be converted into discrete time as well, right? This is also signum function only. but this is signum sequence. This is your signum sequence. What is this? This is your step sequence, and this can be written as square sequence. Okay. So the thing is, at any point of time, these signals are not going to infinity. That means certainly they are the bounded signal. So whenever I say bounded signal, whenever I use the word bounded signal, these things should come into your mind: signum, step, and square wave. Do you remember this thing? Will you remember this particular thing? Whenever I say bounded signal, so what thing will come into your mind? Signum, step, and square. Okay, and the same thing can be converted into discrete time as well. And what do you mean by unbounded signal? That at any point of time it will go to infinity. There would be a particular time t. There will be a particular time t where it is going to infinity. So this signal is going to infinity at t equals to infinity. So this is unbounded signal, right? At this particular time, at any point of time t, this is going to infinity. At t equals to 0, this particular signal is going to infinity. That means this is also unbounded signal. This is at any t equals to t1, this is going to infinity, and at n equals to infinity, this is also going to infinity. So this is also unbounded signal, right? What do you understand by impulse sequence? Is it bounded or unbounded? Impulse sequence. Impulse sequence is simply a single sequence, that's it. So this is bounded, right? Impulse sequence is bounded. And what about impulse function, or what about impulse signal? Is it bounded or unbounded? It is unbounded, right? It is unbounded. Why unbounded? Because its amplitude is infinity, no? The amplitude of impulse signal is infinity, but the amplitude of impulse sequence is 1. So this is bounded, this is unbounded. So whenever I say bounded signal, these things should come into your mind. And what is the meaning of unbounded signal? That at any point of time it will go to infinity. That signal will go to infinity at some point of time. It could be t equals to 0, it could be t equals to infinity, it could be t equals to t1, or it could be n equals to infinity, right? Or it could be n equals to n1, or it could be n equals to 0. So if it is going to infinity, that means it is unbounded. And if it is not going to infinity anytime, then that means it is bounded signal. So this was just a revision. Let's get back to our concept, that is stable system. What we need to study? Stable system. So this is a particular system. If I am applying a particular input xt, I am receiving a particular output yt. Okay. Now, if I apply a bounded input, what I am applying? I am applying a particular bounded input, and my output is bounded. I applied a bounded input and my output is also bounded. Sorry, my output is also bounded. That means the system is stable, and this is known as Bibo stable. Okay, Bibo stable. What is the meaning of Bibo? Bounded input, bounded output. For bounded input, you are getting bounded output. So this is known as Bibo stable. Okay, so other name would be Bibo stable. So if you are applying a bounded input, you will receive a bounded output. That means your system is stable. Or how you can check? That for a finite value of input, your output should also have a finite value. Finite value of output. So for a finite value of input, you will receive a finite value of output. This is the meaning of a stable system. So let's check it. Yt equals to e to the power xt. Can we make the graph between yt and xt? Yes. So first let's make the graph between yt and xt. Yt equals to e to the power xt. This is your yt. This is your xt. So what is the graph? This will be the graph. Right? Because e to the power, at e to the power 0, your value is 1. At e to the power infinity, the value is infinity. So will you call it unstable system or stable system? This is stable system only. Why is that so? Because what I am saying, for a finite value of input, your output should be finite. So if my xt is 1, what is the value of my output? E to the power 1. If my xt is 2, what is the value of output? E to the power 2. If my xt is 4, what is the value of output? E to the power 4. If my xt is minus 1, what is the value of output? E to the power minus 1. So if I am applying a finite input, I am getting a finite output. Now you will say that, sir, it is going towards infinity, right? Someone will say that, sir, your yt will be infinity. But when it will be infinity? At xt equals to infinity. That means when your xt is going infinite, at that time your yt is going infinite. Is that clear to you or not? So that is fine. I am not, I don't have any problem if yt is going to infinity when xt is infinity. I don't have any problem at that time. Okay. So for a finite value of input, I am getting a finite output. Then I am okay with that. So this definition we have satisfied. That for a finite value of input, you are getting a finite value of output. So that means it is a stable system. That's for sure. Okay. You are getting yt equals to infinity, or you can say yt will tend to infinity at xt equals to infinity. So I am okay with that. I don't have any problem with that. But if xt equals to 1 and yt is going to infinity, then there is an issue. What I mean to say is that, what if your yt was ln xt? Your yt was ln xt. So can you draw the graph between yt and xt now? Yes. This is yt and this is xt. So what will be the graph? This will be the graph. This is the graph between yt and xt. So when xt is 0, when your xt is 0, xt equals to 0 means xt is finite. So when your xt is finite, your yt is going to minus infinity. So when your xt is finite, your output is going to minus infinity. So for a finite value of input, you are getting a infinite output. So that's an issue, that this system will be unstable. I don't have any problem when xt is equals to infinity, my yt is going to infinity. Here, when your xt is infinity, your yt will go to infinity. There is no issue with that because both are infinity. But if I am applying xt to be finite, if I am applying xt to be 0, then my yt is going to minus infinity. The problem comes here. So this will be an unstable system. So if you can draw the graph between yt and xt, will you be able to tell me that it is a stable or unstable system? Certainly you will be able to tell me, right? I hope the concept is clear. Now let's satisfy this definition as well, that for a bounded input you will receive bounded output. Okay, which definition we are going to satisfy now? Just one second, what did I, this much I can remove. So which definition we are going to satisfy now, that for a bounded input you will receive bounded output. So what was our example? Yt equals to e to the power xt. So what bounded input I can take? What did I tell you? Whenever I say bounded input, for a bounded input signal basically, and you will receive a bounded output signal. So what do they mean to say is that there is a system to which you will apply xt and you will receive e to the power xt as the output. Applied input is xt and you will receive e to the power xt as the output, right? So now first you will apply xt to be a bounded input. Xt should be bounded. So can I apply xt equals to rt? No, because rt is unbounded. So I cannot apply xt equals to rt. I need to apply a bounded input. So what I am applying? Ut. Xt equals to ut I am applying. So what will be my yt? My yt will be e to the power ut. What does that mean? That it will be e for t greater than 0, because ut will be 1. For t greater than 0, ut will be 1. So it will be e to the power 1 for t greater than 0, and for t less than 0, it will be equals to e to the power 0, and e to the power 0 is 1 only. So what is your yt? Your yt is coming out to be e to the power e for t greater than equals to 0, not greater than equals to 0. I should not put a, actually at a, let's not define it at t equals to 0, because ut is also not defined at t equals to 0. So let's put a t greater than 0, and for t less than 0, it would be equals to 1. So what kind of graph of yt you are getting? What will be the graph of yt? Yt with respect to t I am drawing. Important point to note here is that previously what graph did I draw? Yt versus xt I am draw. Yt versus xt I draw. Here yt versus t I am drawing. So for t greater than 0, it is having a value of e. For t greater than 0, it is having a value of e. And for t less than 0, it is having a value of 1. For t less than 0, it is having a value of 1. So this is the graph of yt. So was this a bounded signal? Yes. Bounded signal. Is this the bounded output? Yes. I will call it bounded input signal. So I applied a bounded input signal. Did I receive a bounded output signal? Absolutely yes. Right? So applying a bounded input signal, you are receiving a bounded output signal. So yes, this is known as Bibo stable. Bibo stable. But by looking at only one input, you cannot comment. Okay? By looking at only one input, that sir, I applied UT and I got to know that sir, yes, bounded output I am receiving. So yes, it is Bibo stable. By looking at only one input, you will never say. You need to analyze for all these inputs. You need to analyze for signum t as well. You need to apply. You need to analyze for square t as well. So this is what I told you. Whenever I say bounded input, what should come into your mind? UT, signum t and square t. Look, if you are able to make the graph, then you will be able to analyze with respect to graph as well. That if your xt is going to infinity, then only your yt is going to infinity. So I am fine with that. That means it is Bibo stable. That's it. If you are able to make the graph. But if you are not able to make the graph, then this is the process you will follow. That first you will apply xt equals to ut. Secondly, you will apply xt equals to signum t. So what you will get? If I apply xt equals to signum t, so what will be my yt? Yt would be e to the power signum t. What that would be equals to? It would be equals to e for t greater than 0, e to the power 1, and it would be equals to e to the power minus 1 for t less than 0. So can I make the graph? Yes. This was a bounded input signal. Bounded input signal. And here what we are receiving. This is also bounded because it is never going to infinity. Basically this signal is never going to infinity. It can have only two value, e and 1 by e. You can draw the graph as well, but without even drawing the graph you can tell no that for t less than 0 it is 1 by e. For t less than 0 it is 1 by e, and for t greater than 0 it is e. Or without even drawing the graph you can tell that whether the value is e or 1 by e. That means it is never going to infinity. So yes, for a bounded input signal I am receiving a bounded output signal. So e and 1 by e. Okay. Here also you will not stop. If you are checking by this process, look, there are two methods. This was the method 1, that you draw the graph, and this is the method 2, that you apply different kind of inputs, you apply different kind of bounded input, and you check the output. I applied bounded input signal, I received bounded output signal. Again I applied bounded input signal, again I received bounded output signal. Okay, but I told you never ever stop here. Okay, third signal also you need to apply. What is the third signal? Third signal will be square function. Third, what you will apply? Square function. So this is your bounded input signal, right? So what will be your output? Yt, that would be e to the power square t. So you know that you know one thing, that square t can have only two values. Either it would be 1 or it would be minus 1, right? It can have only two values, 1 or minus 1, 1 minus 1, 1 minus 1. That means if this can have only two values, that means yt can also have only two values. Either it would be e or it would be e to the power minus 1. That means yt is never tending to infinity. And if it is never tending to infinity, that means it is also bounded output signal. So did you understand the conclusion? Like if you are able to make the graph, happy. But if you are not able to make the graph, then this is the process that you will follow. That first you will apply ut. All this process you don't need to do. You don't need to do. What you will do, I will apply ut, then I will check, okay, ut can have only two values, 0 or 1. That means my yt will have only two kind of values, e to the power 0 or e to the power 1. So yes, it is not going to infinity. So for bounded input, I am receiving bounded output. Signum t, e to the power signum t. Signum can have only two values, 1 and minus 1. That means my output can have only e to the power 1 or e to the power minus 1. So yes, this is also not going to infinity. So for a bounded input, again I am receiving bounded output. Now, here I will apply square signal. It can have only two values, 1 and minus 1. So for a bounded input, again I am receiving bounded output signal. So all these processes are checked. That means certainly it is Bibo stable. So two methods I am having. One is to make the graph, other one is to check like this. Let's talk about Bibo unstable. Oh sorry, not Bibo unstable. It would be only unstable. We will not say BIBO unstable. We will say BIBO stable, or directly we will use the term unstable system. So this is the unstable system. So what is the meaning of that? For a finite value of input. In the previous diagram, what we wrote first? In the previous diagram, we wrote bounded first. So for a bounded input signal, for a bounded input signal, what you are receiving? Unbounded output signal. Okay. For a bounded input signal, if you are receiving unbounded output signal, then it would be unstable. Or what you can say, for finite value of input, finite value of input, you receive infinite value of output. Let's take the example of lnxt. Okay, let's take the example of lnxt. Which example we are taking? lnxt. Okay, now what I will do, method 1, make the graph. If you are able to make the graph, your job is done. So how will you make the graph? Yt versus xt graph you need to draw. So what did you get to know here? That when xt is equals to 0, when xt is equals to 0, yt is infinity. So for a finite value of input, finite value of input, for a finite value of input, you are receiving infinite value of output. For a finite value of input, I am receiving infinite value of output. That means it is a unstable system. So this is the method 1. What is the method 2? I told you that start applying the signals. So xt equals to ut I can apply. If I apply xt equals to ut, what thing I know, that ut can have only two values, 0 or 1. What is my yt? Yt is equals to ln xt. Yt is equals to ln xt. So xt can have 0 or 1 value. That means yt can have what yt value, what yt can have? Yt can also have only two values. That would be ln 0 or ln 1. Are you able to understand this point? Xt can have only two values, that is 0 or 1. That means yt can also have only two values, ln 0 or ln 1. So what yt can have? What is the value of ln 0? Minus infinity. And what is the value of ln 1? That is 0. So you are fine with that, but you are not fine with this. So what did you understand here? That if you are applying a bounded input, this was a bounded input, right? Bounded input. If you are applying a bounded input, what you are receiving? Bounded input signal. What is yt? Yt is unbounded output signal. Unbounded output signal. So for a bounded input signal, I am receiving unbounded output signal. What does that mean? That means it is unstable system. Okay, so I hope you would have understood both of the methods. The first method is to make the graph. So here only you can see that for a finite value of xt, for a finite value of xt, you are receiving a infinite yt. So there is an issue, unstable. Method 2, what I did, I applied a bounded input. I am applying a ut on a particular system. On this particular system, I applied ut. I applied ut. I applied ut. Then I got to know that my output with respect to t, what will be the graph of yt with respect to t? The graph here, the graph of yt with respect to t. What kind of graph we will get? For t less than 0, ut is 0. For t less than 0, ut is 0. That means here it will be infinity. For t less than 0, yt will be infinity. Basically, what will be the graph of yt? Yt is equals to ln xt, or in place of ln xt, what I can put? Ln ut. So yt is equals to ln ut. So for t greater than 0, for t greater than 0, for t greater than 0, ut is 1, that means ln1 0. So for t greater than 0, yt is 0, and for t less than 0, ut is 0, so yt is infinity. So I cannot make the graph actually because I cannot show infinity, but here from here you got to know that yt is having two values. For t less than 0 it is having infinity value, for t greater than 0 it is having 0 value. So I am fine with 0, but I am not fine with this infinity. So from here you got to know that for when I applied ut to my particular system, I received two kind of outputs, 0 and infinity. I am not fine with infinity. I applied a bounded signal here. This was a bounded input signal, but I received unbounded output signal. So it is an unstable system. Is that okay for you? All fine. So you would have understood the complete process here, that what we are going to do in this particular topic, right? So let's see this question. From the given graphs between xt and yt, you need to find if the system is stable or unstable. Graphs are given. You need to tell whether the system is stable or unstable. The graph is given between yt and xt. So what is the first thing you will see? That if your yt is going to infinity or not. So you will say that, sir, yes, yt in this particular graph, yes, sir, yt is going to infinity. But when yt is going to infinity? When xt itself is infinity. First thing you need to see is that, sir, yt is going to infinity or not? Yes, yt is going to infinity. But when it is going? When xt is also infinity. So for a infinite value of input, you are receiving infinite output. So I don't have any problem with that. That means it is a stable system. So this is stable. Here yt is going to infinity? No, never yt is going to infinity. So for a finite value, you are always receiving a finite output. Stable. Is yt ever going to infinity here? Yt is never going to infinity. No matter whatever the value of xt you apply, it will never go to infinity. It will either give +1 or -1. What does that mean? This is also stable. This is x cube t. Yt equals to x cube t. So this is the graph of x cube t. That means here as well, you will receive infinite output only when your xt is infinity. If your xt is infinity, you will receive yt equals to infinity. If your xt is minus infinity, then you will receive yt equals to minus infinity. So you will receive infinite output only when your input is infinity. That means this is also stable system. Fine. Let's go to this one. So here what do you see? At xt equals to pi by t, output is going to infinity. At xt equals to pi by 2. At xt equals to pi by 2, yt is going to infinity. So for a finite value of input, what we are receiving? Infinite value of output. What does that mean? This is unstable, right? So if there is a graph between yt and xt, it is very easy for us, very easy job, right? But if we are not able to draw the graph, then it will be then we need to apply some signal ut, signum t and square t, that we need to apply. What about this one? This we have already seen. This is unstable only because at xt equals to 0 you are going to infinity. So at xt equals to 0, yt is equals to minus infinity. What does that mean? Here what did I write? Infinity or minus infinity? Yt equals to minus infinity, sorry, minus infinity. At xt equals to 0, yt is equals to minus infinity, no? So this we have already seen. So this is also unstable. Well and good. Okay. So this is the procedure of checking that if yt equals to fxt is given, that means yt equals to ln xt, yt equals to ln xt, yt equals to xt, yt equals to sin xt, yt equals to xt cube, yt equals to signum xt. That means before xt some function is applied. So if that kind of thing is given, what you need to do? You can draw the graph. And if graph is not possible, that means some kind of signal is there, yt equals to ft into xt. So these examples we will see. If graph is not possible, then you will apply bounded input and you will check if the output is bounded or not. Process is clear, right? Let's see the examples. Yt equals to ln xt, this we have already seen. So in place of this, what we will see? Yt equals to t into xt. And let's remove this example. Yt equals to xt. What will be the graph? We can draw the graph. Yt equals to xt. What kind of graph we will get? This kind of graph we will get between yt and xt, right? For this particular example, this will be yt, this will be xt. So what do you see here? That for a finite value, you are having finite output. But if your input goes to infinity, your output goes to, if your input goes to infinity, your output goes to infinity. And if your input goes to minus infinity, your output goes to minus infinity. So for infinite value of input, you are receiving infinite output, and you don't have any problem with that. For finite value of input, you are never receiving finite output. That means, sorry, for finite value of input, you are always receiving finite output. So that is a stable system. This is same as the first example here. This example, same as this example, that yt is going to infinity, yes, but it is going to infinity when xt is infinity. So the same example we are seeing here. So no issue with that. That means it is a stable system. So before stable, you can say bounded input, bounded output. So let's remove it off. So let's see this particular example. Now yt equals to txt. Can you draw the graph? Some people will say that, sir, it is a linear system. Yt equals to txt. It is a linear system. So sir, for linear system, you have told that you can make the graph in this manner. Yt equals to, if I make the graph between yt and xt, you can draw something like this. Yt, xt, a straight line with the slope of t. This I told you when you are drawing between yt and xt only. But here you need to consider that t as well. Okay, what I am saying, you need to consider the t as well. So if it is something like this, ft into xt, this is a very important point to note. If your system is yt equals to ft into xt, you will never draw the graph. For linearity, if you draw the graph like this, it is fine. Even during the linearity, we will never solve the problem with respect to graph, right? In linearity, I have told you the process, x1t, x2t, x1t plus x2t, 3x1t. Okay, so never we draw the graph. So if your function is like yt equals to ft dot xt, yt equals to ft dot xt, then you will have to put some inputs. What you need to do? You will have to put some inputs. Okay, so let's put the inputs now. So what is the first example I will take? Is this finite? Oh, sorry, not finite, I should say bounded. This is a bounded input signal. And what is your yt? Yt would be t into ut. And what that would be? T into ut is rt. So what is your yt? Yt is rt. So this is my yt. And what was the applied input? Applied input was ut. Applied input was ut. Or you should say this is your xt actually. So this is a bounded input signal. Is this a bounded signal? Is this a bounded signal? No, this is an unbounded signal. No, because at any point of time, if your signal is going to infinity, that is unbounded. So this is an unbounded signal. This is your unbounded signal. Now you will say that, sir, at t equals to infinity, yt is going to infinity. So I don't have any problem with that. No, I did not say that thing. What I said, when your xt is equals to infinity, when your xt is equals to infinity, at that time your yt is going to infinity, then I don't have any problem. But if any point of time, if your yt is going to infinity, at any point of time, if your yt is going to infinity, that means I am receiving an unbounded output signal for a bounded input. For a bounded input, I am receiving an unbounded output signal. So I have an issue with that. That means it is unstable system. Did you understand this point here? That I applied in a particular box, I applied ut. I applied a bounded input signal. I applied bounded input signal. I received unbounded output signal. Is this bounded or unbounded? This is unbounded output signal. We are not talking about stability here. We are talking about whether this signal is bounded or unbounded. Our first slide, these were the bounded, but this was unbounded. Because at any point of time, if your signal is going towards infinity, then that would be unbounded signal only. When we studied stability, at that time I said that at any point of xt, if my yt is going to infinity, then I don't have any problem. Because for an infinite value of xt, your output is being infinite. But here, if any value of t, if any value of t is making your output go to infinity, then I have an issue. That means when I applied a bounded input, you are getting an unbounded output signal. Okay, so this is an unstable system. Did you understand the point? First thing is that we could not make the graph. Then I have to follow this process. Then I applied a bounded input signal. I got to know that my output is unbounded. So I hope you are not getting confused with this particular scenario and this particular scenario. Both are different. See the graph, yt, xt. Here yt versus t. Okay, and this output we are getting for a particular input, but this is the universal graph between ut, this is the universal graph between yt and xt, but this we are getting for a particular input. So when I applied that particular input, I got to know that I am receiving an unbounded output signal. That means this is an unstable system. I hope the concept is crystal clear. People will study whole signal system, but this is the topic where they struggle the most. Stability, instability, and invertibility and non-invertibility. That is the topic where a lot of students struggle, and question also come from here. Okay, so whatever the examples that we are taking, that would be more than enough for you. From there only, if they want to frame a question, from these examples only the question would come. Most of the times, what will happen is that you will be able to make the graph, and if you are able to make the graph, your job is done, right? E to the power t xt. Can you draw the graph? Again, this is of ft into xt. I cannot draw the graph, right? So again, there you go. What you need to do? Apply a random xt. Not random xt. It should be bounded. It should be bounded. Look, yt equals to xt. What did I tell you? That this is a stable system, right? This is a stable system. Now someone will say that, sir, what if I apply xt equals to rt? Then what is my yt? That is also rt, sir. So this is your unbounded. So sir, I am receiving unbounded output. This is a unbounded output signal, no? Yt equals to rt. RT is the unbounded output signal. So sir, I am receiving an unbounded output signal. So it should be unstable. No, I told you unbounded output signal you should not receive for a bounded input signal. But what you are applying? You are already applying unbounded input signal. So if you are receiving unbounded output signal for an unbounded input signal, then there is no issue. Like you cannot even comment now. If I say, sir, on a particular box, here I am applying unbounded input signal. My output is unbounded. No issue. Actually, I cannot even comment whether it is stable or unstable. For commenting, here I need to apply bounded signal only. This has to be bounded. And here I will check whether I received unbounded output signal or bounded output signal. So for bounded input, I am receiving bounded output. For again bounded input, again bounded output, again bounded input, again bounded output. So yes, now I can say it is stable. But if I am applying unbounded input, then I cannot even comment, no matter whatever the output is. So I don't know for an unbounded input, whatever the output is, I am not interested in that particular output. I hope the concept is being clear to you now. Okay, and the other method is simply the graph. In the graph, you will get to know that for a finite value of input, are you getting infinite output? If you are getting infinite output, then case closed. But for xt equals to infinity, if you are getting yt equals to infinity, then there is no issue. Because for infinite value of input, I am receiving infinite output. So there is no issue. Then it will be stable only. So I am repeating all these things again and again because the point is people find it difficult. So I am clearing all the doubts. I am taking all the doubts, whatever you can receive. Okay. So yeah, xt equals to ut. So if your xt is equals to ut, what will be your yt? Yt will be equals to e to the power t ut. And it can be written as e to the power t for t greater than 0. And for t less than 0, ut will be 0. So it would be 0 only. So what kind of graph you are getting? What is the graph of yt? Yt versus t. So graph of yt will be at 0 the value will be 1 and then it will be going towards infinity. So is it bounded or unbounded? Is this signal bounded or unbounded? You will say, sir, at t equals to infinity, yt is going to infinity. So it is bounded? No. At any point of time, if your yt is going to infinity, that means it is an unbounded signal. Unbounded signal. So I applied a bounded input signal. I applied a bounded input signal. I receive unbounded output signal. What does that mean? Unstable, right? Let's go to the next one. X2 D2 running integration. Can you draw the graph? No. So you will say, sir, it is linear system. I will draw the graph. No, you cannot draw the graph directly, like sin xt, e to the power xt, ln xt. If these kind of functions are there that you have already studied, y equals to ln x, y equals to ln x. So it can be written as yt equals to ln xt. Then only you will draw the graph. Y equals to e to the power x, then yt equals to e to the power xt. So then only you will draw the graph. If these kind of things are coming, then you don't need to draw the graph. Okay, basically y equals to minus infinity, or I can say y equals to any integration x dot dx. So will you draw the graph here? No, right? So directly between y and x, like someone will say that, sir, I will do this particular thing and then I will draw the graph. You can draw the graph after that, but directly here you cannot draw the graph. So that's why for differentiation integration we will not draw the graph. Okay, so again we need to put the values. Xt equals to ut I will put. So what will be my yt? Minus infinity to t u of tau d tau. What is this equals to? RT. So what was this? Bounded. And what is this? Unbounded. What does that mean? Unstable. That's it. For a bounded input signal, you are receiving unbounded output signal. Unstable. Very easy, right? Sine of xt. In between I took this example. I can draw the graph, right? Yt equals to sine of xt. This is your yt xt. Basically it is y equals to sine x. So what will be the graph? This will be the graph. Although this example we have already seen. Right? Yt equals to sine of xt. So yt equals to sine of xt. So this is the graph. So what we can see here, yt is never going to infinity. For any value of xt, for any finite value of xt, yt is never going to infinity. That means it is stable only. Stable system. What is the graph of y equals to x square? Y equals to x square. Or you can say yt equals to x square t. So this will be the graph of yt equals to x square t. Right? So is it ever going to infinity? Yes, it is going to infinity, but when xt is infinity. So for infinite value of xt, when xt is infinity, then only your yt is tending to infinity. Then only your yt is tending to infinity. So for infinite value of xt, your output is infinite. So if that is the scene, then I don't have any issue. For finite value of xt, I am receiving finite output. For finite value of xt, I am receiving finite output. For finite value of xt, I am receiving finite output. So if that is the case, then it is fine for me. That means it is also stable. Okay. This is also stable. This is also stable. Try this one. Can you draw the graph? No. So what you will do? Assume x of k. Oh, sorry, not x of k. X of n is equals to u of n. So what will be your y of n? That will be the running integration. What is the answer? Do you remember? Running integration of u of k. That is r of n plus 1. What this was? This was bounded input signal. What you are receiving? Unbounded output signal, unbounded output signal, bounded input signal, unbounded output signal we are receiving, right? What does that mean? Unstable. Right? Think about it. Yn equals to x of 2n. Yn equals to x of 2n. Can I draw the graph? No. Yn equals to xn I can draw. X of 2n is there, no? Inside whatever that is there, that has changed. So I cannot draw the graph. So what do you think? What should be the answer? We need to put the functions. If I put x of un, if I put xn equals to un, then what will be my yn? Yn will be u of 2n. One thing I know that u of 2n will be certainly bounded only. This was a bounded input. Oh, sorry, here what I wrote. Yeah, sorry. Yeah, no, nothing. So what I was saying, this is a bounded input signal. So this is also a bounded output signal, right? For a bounded input signal, u of 2n, whatever the graph would be there, I don't care. But certainly I know that it would be bounded. U of 2n, this would be the graph, no? Again, this would be the graph. Like whatever the values will be there here, 0 and 2, 4, 6, that values I don't care, but certainly it will be bounded only. So for a bounded input, I am receiving a bounded output only. But only looking at one only, we will never tell our final answer. For our final answer, I will look at signum n as well. So what will be my yn? That would be signum of 2n. So again, the graph would be like this only. Like whatever the samples are getting destroyed, that I don't care, but I know that it will be bounded only. Samples are getting destroyed in between, but I don't care about that. If it is bounded input signal, it will be bounded output signal. Because what 2n will do, 2n will just destroy some particular, what 2n will do, 2n will just destroy some sequences, right? Some samples it will destroy. If this is your x of n, let's just say if this is your x of n, this is bounded only. So what it will do, it will just cancel this one. It will just cancel this one. Because what is the job of x of 2n? X of 2n means it will be cutting the samples. Your signal will be, your sequence will be having some samples less. X of 2n, I hope you remember. What was the meaning of x of 2n? X of n by 2. N by 2 means your signal will be expanded. And what is the meaning of x of 2n? X of 2n means your signal will be, your sequence will be shrinked, right? X of n by 2, your sequence will be expanded. X of 2n means your sequence will be shrinked. So it is being shrinked here. So this is being cancelled, this is being cancelled, right? So basically, if it is bounded, then your output will also be bounded only. Even if you apply square sequence, even if you apply square sequence here, then what will be your yn? It will be square only. So this was bounded. So here also your sequence are getting cancelled. But if your input was bounded, your output is bounded only. So for a bounded input, we are receiving bounded output only. That means it is stable. Are you getting this point or not? So x of 2n is doing nothing, but it is just cancelling out some samples. And if samples are being cancelled out, that will not change our bounded. If input was bounded only, then our output will be bounded only. So that will be stable. Okay, we will see more example, but let me take a break. So try thinking about it. Try thinking about the differentiator, whether it will be stable or unstable. Okay, try thinking about it. Yeah, so did you try this one? So can I make the graph? No, I cannot make the graph. So what I need to do? I need to apply a bounded input and I need to check whether it will be, output will be bounded or not. So what bounded input you will apply? First we will try with ut. So xt is equals to ut. So my first signal will be xt equals to ut. So bounded input I am applying. What will be your output yt? Your output yt will be d by dt of ut. That would be equals to delta t. So your output is unbounded. You applied a bounded input signal. What you are receiving? Unbounded output signal. What does that mean? Unstable. That's it. Very easy, right? Very straightforward. It is a Unstable system. What about this one? X of tau sin tau d tau. Very good question. I would say best question of stability. This is the best question. So what did I tell you? That apply a bounded input and you see whether the output will be bounded or not. You cannot make the graph, right? You need to apply the inputs. So apply a bounded input and you see whether the output will be bounded or not. So what I applied first? I applied x of t will be equals to ut. So what will be my yt? Minus infinity to t u of tau sin tau d tau. And one thing I know, since there is u tau means the function will be starting sin tau u tau. What is sin tau u tau? The graph of sin tau u tau. What that would be? This would be the graph of sin tau u tau. That means I need to take the integration from 0 to t, considering the fact that t is greater than 0, right? So I can change the limit something like this: 0 to t sin tau d tau, considering the fact that your t is greater than equals to 0. So when I solve it, what I will be getting? So it would be cos tau. Integration of sin tau is minus cos tau, so I am changing the limit. Cos 0 is 1, 1 minus cos t into ut as well. So people will be saying that, sir, this value will be between, cos t value will be between minus 1 to 1, right? This value will be between minus 1 to 1. That means this particular value will be between 2 to 0. So you applied a bounded input signal, and what you are receiving? Bounded output signal, right? You applied a bounded input signal and you are receiving a bounded output signal. So this is a stable system. This is what people will be saying, that, sir, this is a stable system. And a lot of students, if this question is coming in the examination hall, a lot of students will be marking this particular thing. But this is wrong. What did I tell you? Check at square as well. Like you checked at ut. Secondly, we will check at square, not signum t. Signum t you can check later on. But check at square as well. Why I am checking at square t? What I mean to say is that xt is equals to sqt. What is your sqt? Let's do it on the next page. Always check at sqt as well. What if I put my xt equals to something like this? So is this a bounded signal? Surely it is a bounded signal, right? This is a bounded signal. Same goes for negative side as well. Same goes for negative side as well. So what I am saying, this is my x of t. This is my x of t. And this signal is being multiplied with sin tau. This signal is being multiplied with sin tau, or you can say sin t. So can you draw the graph of sin t? Certainly I can draw. This will be the graph of sin t. This is the graph of sin t. Right. Now if this is multiplied with this particular signal, what will happen? What is the scenario? The scenario is your yt is minus infinity to t. This is your sin t versus t. So the scenario is x of tau sin tau. This multiplication you need to do, and then you need to take the area. X of tau sin tau you need to do, and you need to take the area from minus infinity to a particular value t. This is what this particular yt is saying. Yt is saying that you multiply x of tau with sin tau. Let's change them to tau. X of tau sin tau. So I told you one thing. First we will check at ut. At ut I am getting, for bounded input I am getting bounded output only. But only by looking at one I cannot comment. I need to look at other cases as well. So now I am checking at square. So now if I multiply both of these signal, what will happen? This is the positive value, 1 will be multiplied with sin tau. It will remain as it is. But minus 1 will be multiplied with the negative value. So what will happen? The negative value will go to the positive one. So what will be the resultant graph? X of tau sin tau. What will be the resultant graph of x of tau sin tau? x of tau sin tau. This will be the resultant graph of x of tau sin tau. Say yes or no, right? This is the resultant graph, right? And now this is going to minus infinity. Now you are calculating the area from minus infinity to a particular value t. So how many such lobes will be there? Infinite lobes will be there, right? And if it is infinite lobes, what you are doing, you are calculating the area from minus infinity to a particular value t, and in between there will be infinite lobes like this. And what is the area of one lobe? That is 2 Vm into pi. That we don't need to care, like 2 Vm into alpha, 2 Vm into alpha. That we have already seen in our basics. So that we don't care, but I know that there will be one particular area, and that area will be just adding up for infinite times. That means, what is the value of yt? What is the value of yt? Yt will be equal to infinity. Say yes or no. Did you understand the point? That's why I always told you to consider three signals: ut, signum t, and this square. If ut is satisfied, then there is very high chance that signum t will also be satisfied. So forget about signum t, then you check this square as well. And why did I thought of square? Because I know that there is sinusoid and then there is area. There is integration, that means there is area. So a particular input is there is a sinusoid, you multiply both and then you need to calculate the area. This is the process that we are doing. So sinusoid area, in the sinusoid there is a lobe. In sinusoid there are lobes, right? So it can add up to infinite area for sure. These lobes can add up to infinite area for sure. But my target is here, this particular area is cancelling out this area. So there is an issue. This positive area is cancelling out this negative area. My target is to make this particular area positive. And can I make this area positive with a finite input? Yes. If this is my finite input, then this will make this particular area positive. And if it is being positive, that means all these negative area will be positive and all the areas will be adding up. And if all these areas are adding up, then it will add up to infinity. So that's why in the first slide only we wrote down that we need three kind of bounded input. So that was the reason. That's why I taught you those three kind of bounded input. First one, ut, signum t, and then this square signal. Is that clear to you or not? So always check in this particular manner. Okay, so this was a very good example. Although in last examples, only by ut you are able to tell it is unstable. Here also, whatever the result un is given, same result signum and square n is given, right? Here also only by un you are able to tell it is unstable. Here you can make the graph. Here also only by ut you are able to tell it is unstable. Here also by ut only you are able to tell it is unstable. So here also by only ut you are able to tell it is unstable. So what did you get to know? In most of the examples, only by ut we are able to get to know. But in the examination, or if they want to frame a good question, then you need to have some patience there. That here ut is giving us for bounded input, we are getting bounded output. But at the input, at the block, I can apply any number of input. So when I applied this particular input, this is also bounded because it is giving you 1 and minus 1. That's it. It is never going to infinity. So this is also a bounded input. And for this bounded input, sinusoid area will be positive and all will be added up and will be going towards infinity. So in that manner, I need to think in the examination hall. If they want to frame a good question, then ditto same example will come. Okay, ditto same example will come. Like sinusoid multiply with the particular function and then they are calculating the area. Otherwise, if they want to frame an easy question, they will frame that particular question where you can draw the graph. So if you can draw the graph, then you don't need to follow any process. You will just get to know it is stable or not. Just by drawing the graph, you can tell, okay, value is not going to infinity. Here it is going to infinity, but xt equals to infinity. So it is stable. This is also stable. But if they want to frame a question where you cannot draw the graph, then they will frame some good question like this. So have the patience there, and in that manner you need to solve. Okay. What about this one? Sin inverse xt. Can you draw the graph y equals to sin inverse x? Just let me know what this y will be. This x will be somewhat between -1 to 1, right? And this y will be an angle. Basically, if I write any trigo inverse x, so this will be some value that I don't care. Value of x can go from -infinity to infinity. It is going from -1 to 1. I don't care about that. But this y will be an angle, no? This thing you already know, right? This will be an angle. And angle can never go to infinity. So here yt can never go to infinity. It can never be infinity. Did you understand this point? If yt equals to sine inverse xt, or any trigo function is there, any inverse trigo function is there, trigo inverse x. So here x can go from minus infinity to infinity, because if there was tan, then x can be minus infinity as well, it can be plus infinity as well. In case of sinusoid, it can be minus 1 to 1, but in case of tan inverse, it would be from minus infinity to infinity. But one thing I know, y will be an angle can never be infinity. There will be a particular domain. For sinusoid, what is the value of sine inverse minus 1? Sine inverse minus 1. Sine inverse minus 1. So sine inverse minus 1 is minus pi by 2, right? So here you will get minus pi by 2. And here you will get, what is sine inverse 1? When do you get 1? At pi by 2 angle. So this value is pi by 2. This value is pi by 2. Okay. So kind of such graph we get, although it is not proper, but this kind of graph only we get, because sine inverse 0 will be 0 as well. So this kind of graph we will get. So what do you see here? Actually your yt can never be equals to infinity. Yt will always be finite. So with respect to xt, yt is always finite. Can you put xt equals to infinity here? No, you cannot even put. Xt you can put from minus 1 to 1 only. So with respect to xt, your yt is always finite, because yt is an angle can never go to infinity, that means it has to be stable. So every inverse trigonometric system is stable only. Basically, you are applying a xt, you are getting some output yt. You are applying a xt, you are getting some output yt. Here there is any inverse trigonometric function, okay? There is any inverse trigonometric function. So job of this particular system is, whatever the input is there, that will put it into inverse trigo and will receive some output. So that will always be stable. Okay, this system will always be stable. I should mark on the system. So this system will always be stable. What if this is given? Tan yt equals to xt. So what you will do? Yt equals to tan inverse xt. Now let's just say in the worst case you don't know how to draw the graph of yt equals to tan inverse xt. In the worst case you don't know how to draw the graph of yt equals to tan inverse xt. But one thing you know, that xt can have any value from minus infinity to infinity, but yt will be an angle, and angle can never be infinity. That means certainly it will be stable. Say yes or no. Or you can draw the graph as well. Basically here the xt can go from minus infinity to infinity, but the range of yt will be from minus pi by 2 to pi by 2, because tan inverse minus infinity is minus pi by 2. So this point is minus pi by 2, and tan inverse infinity is pi by 2. So this point is pi by 2. So basically kind of such graph we get, as far as I remember. This kind of graph we get. Later on it like starts saturating. So this kind of graph we get. So yt is always between minus pi by 2 to pi by 2 only. So yt is never going to infinity. For any value of xt, yt is never going to infinity. That means it is also a stable system. Okay, this is also stable. Well and good. So that's it about the stability, stable system and unstable system. When we study Laplace transform and when we study jet transform, we will again come back to this topic. After studying Laplace transform and jet transform, it will be a cakewalk for you. You will not even have to do this process. But as of now, you need to remember this process and you need to solve the problem using this process only. In the Laplace transform and jet transform, I will tell you another method. Using that particular method, it will become more easy. So this is what I am saying. In signal system, once you are done with the whole chapter, once you are done with the whole subject, you will be comfortable in all kind of topics. You will be comfortable in all kind of questions as well, because you will be having at least two approaches there. For every question, there will be at least two approaches. So you will be more comfortable after completing the whole subject. So yeah, I know that this stability, this part is a bit typical for a lot of students. They find it a bit typical. Although I have given enough intuition, I would not say enough intuition, although I have given enough way of solving a particular problem, because if you see this particular topic, it is taught in a very complex manner. Like either they will teach this particular topic very short, like one or two example they will take and that's it, or they will teach it in a very complex manner. But here we have simplified it, that when we can draw the graph, if we are not able to draw the graph, then how we will proceed, what kind of input signal we will take. So everything is crystal clear. I hope you are having a good idea about stable system and unstable system. And stable system is oftenly called as bounded input, bounded output stable system. So BIBO stable word can also be used. Let's meet in the next lecture. In the next lecture, we will be studying about invertible and non-invertible systems. Okay. Yeah. Thank you very much. Hi everyone. Welcome back. So in the last lecture, we studied about bounded input, bounded output stable system and unstable system. In this video, we need to study about invertible and non-invertible system. So this is going to be the last type. So what is the meaning of invertible system? So let's just say this is a particular invertible system. I am applying an input xt, I am getting output yt. Now I am applying an input alpha 1t. I applied the input alpha 1t, and with respect to this alpha 1t, I received beta t output. Okay. With respect to alpha 1t, I am receiving beta 1t output. Beta 1t output. Now if I apply input alpha 2t, if I apply the input to be alpha 2t, my output should be beta 2t. It cannot be equals to beta 1t. Are you getting this point? That means at two different inputs, you cannot get the same output. Let's just say this is my box, this is my system. I applied input to be 2, I received the output to be 4. Then I applied input to be minus 2, I received the output to be again 4. So for two different input, I am receiving the same output. So this will be non-invertible. Non-invertible. But here in place of 4, if I had got minus 4, then it would be invertible. So for different input, there will be different output, then it would be invertible. But for two different inputs, if there is a same output, then it would be non-invertible. Okay, well and good, very easy definition. So what kind of graph we can get? Let's try making some graph. Between yt and xt, I am drawing this graph. Is this invertible? Surely it is invertible. Because let's just say xt equals to 1. At xt equals to 1, yt is equals to some value. It could be 1 only. Xt equals to 2, yt is equals to 2. Xt equals to 3, yt is equals to 3. At xt equals to minus 1, yt is equals to minus 1. At xt equals to minus 2, yt is equals to minus 2. So at different values of xt, I am having different values of yt. Say yes or no. Or the graph could be somewhat like this. The graph could be somewhat like this. This is how the graph could be there. So here also at different value of xt is 0, yt is 0, xt is 1, yt is some 1, xt is 2, yt is 4, xt is 2, yt is 4, xt is 3, yt is 9, or it could be anything. But at different values, and here what do we see? At xt equals to minus 1, yt is equals to minus 1, at xt equals to minus 2, yt is equals to minus 2, whatever it is. Basically at different values of x, you are getting different values of y, right? And what is the meaning of a non-invertible system? So I applied the input xt, I got the output yt. If I apply the input alpha 1t, what I am receiving? Output beta 1t. And when I applied the input alpha 2t, again my output is beta 1t only. So what I am getting? Same output for different values of input. I am writing different inputs. So for different inputs, you are getting the same output. What do you mean by that? Let's just make this graph. At xt equals to 1, let's just call it xt equals to 1. At xt equals to 1, you are having this value of yt. You are having this value of yt. At xt equals to minus 1, again you are having the same value of yt, right? That means at 1 and minus 1, you are having the same values. What do I mean to say is that yt equals to mod of xt. When xt is equals to 1, yt is equals to 1. And when xt is equals to minus 1, so mod of minus 1 will be what? 1 only. So yt is equals to 1. So at both these points, at both of the points, you are having the same output. So input was 1, output is 1. Input is minus 1, output is 1. So this is non-invertible system. You cannot invert this particular system. Well and good. So this is known as non-invertible system. I will tell you a method as well that how to determine whether it is invertible or non-invertible. This kind of graph. So here also you can see what you can see here. One thing you can see, what is that? that whatever, I don't know what is the value of xt here. At that particular xt value you are having the same yt value, and I don't know what is the value of xt here. Let's just call this value as alpha and this value as beta. So at beta you are having the value to be gamma, and at alpha as well you are having the value to be gamma only. So when xt is equals to alpha, the value is gamma. When xt is equals to alpha, yt is equals to gamma. When xt equals to beta, yt is equals to gamma. What does that mean? This is also non-invertible. So for different input you are getting the same output, then it is non-invertible. For different inputs, here for different input you are getting the different output. For different input you are getting a different output. So for different input, if you are getting the different output, then it is invertible. And for different inputs you are getting the same output, then it is non-invertible. Well and good. Let's see this particular question. From the given graph you need to find whether the system is invertible or non-invertible. So directly I can see here that for different value of xt there is different value of yt. So this is invertible. Invertible. Okay. Here what do I see? If your xt is equals to alpha, what is the value? This value I am calling as gamma. If xt is equals to alpha, the value is gamma. And if xt equals to beta, then also the value is gamma. You can directly see here, right? When xt is equals to alpha, then the value is 1. Let's just say this is 1. And when xt is equals to beta, then also value is 1 only. So you can see that at two different values of input, you are getting same output of, you are getting the same value of output. At two different value of input, you are getting the same value of output. That means this is non-invertible. What about here? At xt equals to 1, your output is 1. At xt equals to 2, your output is again 1. At xt equals to 3, output is 1. At xt equals to minus 1, output is minus 1. At xt equals to minus 2, output is minus 1. Basically, xt equals to 1 is giving you output to be 1. Xt equals to minus 1, sorry, not minus 1, xt equals to 2 is giving you output to be 1 only. What does that mean? That for two different values of input, you are getting the same output. So this is also non-invertible. Non-invertible. So what is the concept? The concept says that you need to draw an imaginary line parallel to x-axis. What I am gonna do? I am gonna draw an imaginary line parallel to x-axis. Parallel to x-axis, I am gonna draw an imaginary line. More lines I can draw. Now this line is cutting the curve only on one point. This line is cutting the curve only on one point. So if the line is cutting the curve only on one point, that means it is invertible. But in this particular question, if I draw the line, if I draw these lines, so at how many places it is cutting? 1, 2, 3, 4, 5, 6. So it is cutting the curve at different points, right? More than one point. If you draw a line parallel to x-axis, if you draw a line parallel to x-axis and that cuts the curve at more than one point, that means it will be non-invertible. I don't need to write down this thing in statement because you would have seen these kind of things in JEE as well. Yeah, sorry for the interruption, guys. So what I was saying, so we will draw a line parallel to x-axis, and if it is cutting on the curve more than once, that means it is non-invertible, and if it is cutting the curve only once, then it is invertible. Okay, so here if I draw the line like this, if I draw the line like this, so what you will say? That's that it is cutting the curve only once only. No, you need to draw the line in a manner that you just need to find a point where it will cut more than once. So that is the point is this. I will draw the line like this. So it is cutting the curve once, twice, thrice, 4 times, 5 times, 6 times, 7 times. Basically, I have drawn the line. This was my graph, right? So I have drawn the line on this particular line only. So it is cutting the curve infinite times. So I will draw a line parallel to x-axis and then I will check how many times it is cutting the curve. So it is cutting the curve infinite times. Here also I can draw the line, no? It is cutting the curve infinite times. Cutting the curves infinite time. That means it is non-invertible. What about this one? You cut here, you draw here, you draw here, you draw here as well. Everywhere it is cutting the curve only once. Only once. I draw this line only once, I draw this line only once, I draw this line only once, I draw this line only once. So it is cutting the curve only once. What does that mean? Spelling invertible. What does that mean? This is invertible. Okay, same goes here as well. I can draw the line like this. So how many times it is cutting the curve? Twice. So if it is cutting the curve twice, what does that mean? Non-invertible. This simply means that if I am drawing this line, what does that mean? That with respect to the xt value alpha, you are getting this particular output, and with respect to xt value beta, you are getting this particular output. That means for two different values of input, you are getting same output. So this is the meaning of drawing this line. Okay, so this is non-invertible. What about this one? Yt equals to this kind of graph is there. So what I will do? Again, draw as many lines as you can. It is cutting the curve only once, cutting the curve only once, cutting the curve only once. So this is invertible, right? Or I can draw any random function. Let's draw a very random function. I am drawing this kind of graph. I am drawing. Okay, so this is the relation between yt and xt. This is what I am saying. This is the relation between yt and xt. So here what someone will do, that sir, I drew the line like this. It is cutting the curve only once. It is cutting the curve only once. No, you have to draw the line here as well. So how many times it is cutting? It is cutting the curve 2 times. And if it is cutting the curve 2 times, or I would have drawn the line here as well. Now it is cutting the curves infinite times. It is cutting the curve infinite times. So what does that mean? Non-invertible. So first way is that always draw the graph. What will be the procedure? That I will draw the graph between yt and xt. Good. Okay. Really sorry for the bad sound. For last 4 minutes the sound was bad because mic was not connected. So what you can understand from here? You can understand the concept of amplification. If you are not giving the supply from computer, then no matter whatever the small signal input I am applying, it will never be amplified. But if I give the supply from the laptop, that means mic is turned on. After turning on the mic, I am applying my voice, that is a small signal, and that is being amplified. So your amplifier will work only when you have given it the DC supply. After that, your small signal will be amplified. So whenever I teach small signal, this one example I always give, so you can understand from here. Okay, yeah. So now mic is connected. Now my voice is also pretty good, right? So what is the procedure? Procedure is that I will draw the graph. And if I am not able to draw the graph, then what I will do, I will randomly put values of xt, and I will try to get the same output for different values of xt. Are you getting this point? Okay, we will take the example, it will be more clear to you. By, let's just say I am not able to draw the graph, then randomly I will put the values of xt, and I will try to get same output yt, right? And if it is a pattern of yt equals to ft dot xt, that means two functions are multiplied. Okay, this is the input signal, this is a random signal. So two signals are multiplied. So for that, what I will do, I will try different kind of impulse function. So this example we will see. As of now, you are not going to understand anything. So let's see the example. With the example, you will get the proper problem solving approach. Okay, so what I am doing, yt equals to x square t. Can I draw the graph? Yes, surely I can draw the graph. There you go. I will draw the graph. If I am able to draw the graph, this is the graph of yt equals to x square t. If I am able to draw the graph, then what is my task? My task is to draw the line perpendicular to x-axis. When I draw the line perpendicular to x-axis, what do I get to know? That it is cutting twice. And if it is cutting twice, what does that mean? Non-invertible. Non-invertible. Or what I could have done? That sir, if I put xt equals to 1, then my yt is equals to 1. And sir, if I put xt equals to minus 1, then my yt is equals to 1. So for different values of input, you are having the same output. That means it is non-invertible. Yt equals to 1 by xt. Yt equals to 1 by xt. Can you draw the graph? Let's just say if you are not able to draw the graph, then what you will do? You will put different values of xt like this. And you can draw the graph like these are very basic graph. After studying mathematics, you will be very comfortable with this kind of graph. Okay, this is hyperbola. So these are very standard graphs. So at xt equals to 0, what it will be? Infinity. At xt equals to 0, it will be infinity. At x equals to infinity, it will be 0. And what about the negative? At 0 minus, it will be minus infinity, and at minus infinity, it would be 0 only. So this kind of graph you will get. So this is the graph. Now nowhere it is cutting twice. If you draw the line once, here also once, here also once, no matter how many lines you draw, it is cutting once only, once only, once only, once only. So it is cutting once only. What does that mean? That means it is invertible. Or you put the values. Put the value xt equals to 1, yt will be 1. Put the value xt equals to 2, yt will be 1 by 2. Put the value xt equals to 3, yt will be 1 by 3. Minus 1, value will be minus 1. Xt equals to 2, value will be minus 1 by 2. Xt equals to 3, value will be minus 1 by 3. So no chances are there that at two different values of xt you are getting the same output. At every different value of xt you are getting the different output. That means it is invertible. What about this one? A to the power xt. Exponential. So at a to the power minus infinity, it would be 0. At a to the power infinity, it would be infinity only. A to the power xt. So yt equals to a to the power xt. So this will be the graph. I hope you are able to draw these kind of graphs. So what you need to do? Again, I will draw the curve. Like this. Again, I will draw the line. So basically here as well, it will cut only once. Again, I am drawing the line. So I am drawing a line parallel to x-axis. It is cutting the y-axis. It is cutting the curve only once. And you can try as well. Xt equals to 1, value will be e to the power 1. Xt equals to 2, yt value will be e to the power 2. Xt equals to minus 1, value will be e to the power minus 1. Xt equals to minus 2, value will be e to the power minus 2. So for different value of xt, you will get different values of yt. What does that mean? Invertible. This is a very straightforward concept. Yt equals to d by dt xt. Can you draw the graph? No, I cannot draw the graph. So here I will have to put random values. Can I draw the graph here? Yt equals to dy dt of xt. I cannot draw the graph. So now I need to put random values. And what is the first thing that will come into my mind? What will be the first thing that will come into my mind? That would be xt equals to 1. If I put xt equals to 1, what will be my yt? Dy dt of 1. Constant value will give you 0. Let's put xt equals to 5. What will be your yt? Differentiation of a constant value. What that would be? 0 only. Applied xt equals to 1, output is 0. Xt equals to 5, output is 0. So for two different values of input, you are getting the same output. Same output. What does that mean? Non-invertible. Right? What about the integrator? In integration, you can never get the same value. No matter how much you try, you will never get the same value. You put x2 equals to 1. If you put xt equals to 1, if I put xt equals to 1, what will be my yt? That would be, okay, this is, this kind of things you will get basically. Although this will not convert, so how do I write down? Or let's put xt equals to ut. Better, let's put xt equals to ut. So if I put xt equals to ut, what will be my yt? Yt will be rt. If I put xt equals to delta t, what will be my yt? Here, if I put xt equals to delta t, your yt would be ut. So for different values, you are getting different output. Always you will get different. Xt equals to 1, 2, 3, any random function you get, every function will have different integration. Let's just say this is my input. Then what will be the integrating output? Basically, integration means calculating the area. So area will keep on increasing. So this is the input and this would be the output. So every different function will have a different kind of area, and in a different manner it will rise. So the integrator is invertible. Okay, integrator is invertible. Here what we can do, integration and summation both goes same only, right? Here in continuous time integration and in discrete time it is summation. So both goes like same only. So again here as well, if you put x of n equals to delta of n, what you will get? Y of n is un. Let's just say I put xn equals to 2 delta of n. So what will be y of n? 2 u of n. Now someone will say that, sir, I will put xt equals to delta of 2n, but that would be equals to delta of n only, no? So again you are applying the same input, so there is no meaning of that. I will not apply delta of 2n, right? If someone will say that, sir, I will put xn equals to u of n, then what will be my y of n? That would be r of n plus 1. So surely that is also same. Summation, you are doing the summation. Let's just say there is a random signal like this, random signal like this, random signal like this. So what you will do, you will start doing the summation. Here the amplitude is 1, so amplitude will be 1. Then 1 plus 1, amplitude will be 2. Then 1 plus 1 minus 1, amplitude will be again 1. 1 plus 1 minus 1 plus 1, amplitude will be 2. Then here amplitude is 2, 2 plus 2, amplitude will be 4. Then 4 minus 1, again amplitude will be 3, and always it will remain 3 only. So this will be the summation. I hope you understand the meaning of summation. Like just as I keep moving forward, I am going from minus infinity to n. So just as I increase the value of n, I will keep on adding up these values. 1, then 1 plus 1, 2, 2 minus 1, 1, then 1 plus 1, 2, 2 plus 2, 4, 4 minus 1, 3, and it will always be 3 after that, because after that everything is 0. So 0 added with anything would be that particular value only. So 3, 3, 3, 3, 3 will remain there as it is. So different kind of signal will have different kind of summation. A different kind of waveform you will get for different signal. You will never get the same waveform for two different signals, right? So if you are not getting the same waveform, that means for different input you are getting different output. That means it is invertible. This is invertible. Well and good. Cos inverse xt, yt equals to cos inverse xt. Can I draw the graph? Yes. One thing I know, the value of xt can go from -1 to 1. Cos inverse -1, what is the value? Pi, right? The value is pi. Cos inverse -1 is pi. And what is cos inverse 0? Cos inverse 0 is pi by 2. Cos inverse 0 is pi by 2. And what is cos inverse 1? Cos inverse 1 is 0. So this kind of graph you will get. Roughly this kind of graph would be there. So this is the graph of yt equals to cos inverse xt. What I am gonna do? Again, right, where it is cutting only once, only once. So if it is only cutting only once, what does that mean? Invertible. Yt equals to xt dot xt minus 1. Will you be able to draw the graph? Can you draw the graph yt equals to xt dot xt minus 1? No. Yt equals to xt I can draw. but yt equals to xt dot xt minus 1, I cannot draw the graph. So I need to think of signals now. First thing, always whenever I need to think of signals, I will think of impulsive first. So what if I put xt equals to delta t? Xt equals to delta t. So what will be my yt? Yt will be delta t dot delta t minus 1. Multiplication of impulse at 0 and the multiplication of impulse at 1. Multiply of both of them. 0 only, no? Because this impulse will be multiplied with 0 and this impulse will be multiplied with 0. This particular impulse, what is this? This is delta t. And what is this? Delta of t minus 1. So this impulse will be multiplied with 0, answer will be 0. And this impulse will be multiplied with 0, answer will be again 0. So what will be the answer? 0. So yt is coming out to be 0. If I put xt equals to delta of t minus 1, what will be my yt? Xt equals to delta of t minus 1. Here x of t minus 1, so this will be delta of t minus 2. So what is the meaning of this? The impulse is there at t equals to 1. And what is the meaning of this? The impulse is there at t equals to 2. So this impulse will be multiplied with 0, answer will be 0. This impulse will be multiplied with 0, answer will again be 0. So what is the answer? 0 only. So whenever I put impulse and I get the 0 answer, I should be happy, because there will be very high chance that it will be non-invertible only. What did I say? I cannot draw the graph. So second thing what I will think is that in place of xt I will put impulse function. So I put impulse function there. I am getting to know that my answer is 0. I should be happy there, because now anyway I can do something that again I can get the 0 output. First I am getting the 0 output. Again I applied two different input. I am getting the same outputs. So for two different inputs you are getting the same output. Right? So whenever I get 0, I should be happy. When I am solving a problem based on invertible and non-invertible, and if I am getting 0, I should be happy. Putting the impulse, then what I will do? I will take some shift in the impulse, and then I will get to know that here also I am getting 0 only. So these kind of examples we are going to solve now, although this is non-invertible. Non-invertible. Right? So these kind of examples we are going to solve now. Now your yt is equals to ft dot xt. Xt is the input, yt is the output. So for different values of ft, you need to tell whether they are invertible or not. What do I mean to say is that basically this is your first question, that your yt is equals to sin t dot xt. Is this signal invertible or not? Sorry, is this system invertible or not? So what I am gonna do? First I am gonna put xt equals to delta t. What I will get? Yt equals to sin t dot delta t. What is the meaning of this sin t dot delta t? Xt dot delta t, t minus 0, x of 0 dot delta t. Say you remember this thing, yeah, right? Xt dot delta t minus 0. So this 0 comes here in place of this, and delta t remains there as it is. So here also the 0 comes here, sine of 0 delta t. What is the value of sine 0? That is 0 only. Now what I put? Xt equals to delta of t minus pi. What will be my yt? Sin t into delta of t minus pi. What that would be? Sin pi into delta of t minus pi. What is the value of sin pi? 0. Sin pi is 0 only, right? Sin pi is 0. So 0 multiplied with anything will be 0 only. So for two different values of input, you are getting the same output. What is the meaning of this? Invertible. Sorry, non-invertible. Non-invertible. Now the point would be coming into your mind that, sir, how will I think that, sir, first I will put delta t, but how will I think that, sir, now I need to put delta t minus pi? What if I have thought I would put delta of t minus 1, then t minus 2, then t minus 3? Then I would not be getting the same output. What do I mean to say is that, let's just say some guy would have put delta of t minus 1. In place of xt, he would have put delta of t minus 1. Then what output he would be getting? Sir, sin t into delta of t minus 1. Then 1 goes here. So it would be sine of 1 into delta of t minus 1. So this value and 0 both are not same. So sir, I am getting a different output. So how will I think that, sir, I can get the same output? How will I think that, sir? So for that, what you need to do is that you draw the graph of this ft. You draw the graph of this ft. What is our ft? Sin t. So what I do in rough work, I will draw the graph of xt. Sorry, I will draw the graph of ft. What I am drawing? I am drawing ft versus t. ft versus t. That is sin t. I have drawn this graph. When I draw this graph, I get to know that this particular function ft has the ability of giving the same output at two different values. That means at 0 and at pi, this particular function ft has the ability of giving the same output. I am not making any conclusion out of it. What I saw, yt equals to ft dot xt. Okay. Now I know that I need to put some impulse function here. In place of xt, I need to put impulse function. What kind of impulse function I will put? So for that, what I will do, I will draw the graph of ft. I got to know that my ft has the ability of giving the same output at different values of t, not of xt, at different values of t. It has the ability of giving the same output at different values of t. So first thing I will put, that would be delta t. Second, I will put delta of t minus pi. You could have put delta of t minus 2 pi as well. Again, you would get the same output. You could have put delta of t minus 3 pi as well. So if I am not able to think that what values of impulse function I should put, then I will draw the graph of ft, and from there I will get idea that delta of t minus pi. This method is taught everywhere, but students are always confused that, sir, how will I determine what I need to put? So for that, what you need to do, make the graph of ft, make the graph of ft, make the graph of ft. So solve the other two problems on your own and let me know whether they are invertible or non-invertible. You should be able to solve it now. Okay, I have given you the approach that how to think of a impulse function, right? So solve it on your own. I will take a break and then I will come back. I hope you will be able to answer B and C. That is very, very easy, very, very straightforward. Yeah, so let's do the second question now. Yt equals to t square xt, right? So what I will do, first I will draw the graph of t square versus t, right? T square versus t, because I know that this is the form of ft dot xt. So I will draw the graph of t square versus t. What I will notice here is that it will have the ability of giving two outputs. Sorry, it has the ability of giving one output at two different values of input. That would be t equals to 1 and minus 1, 1 and minus 1, right? So let's just put xt equals to delta of t minus 1. So what will be your yt? Yt would be t square into delta of t minus 1. So 1 goes here. What it would be? 1 square into delta of t minus 1. That would be equals to delta of t minus 1. If I put xt equals to delta of t plus 1, yt would be equals to t square delta of t plus 1. So 1 goes here, minus 1 goes here actually. This would be minus 1, no? T minus t naught we see. What is the value of t naught here? Minus 1. So minus 1 goes here. So minus 1 square into delta of t plus 1. So what that would be equivalent to delta of t plus 1. So when you applied the input to be delta of t minus 1, your output is delta of t minus 1. When you applied the input to be delta of t plus 1, your output is delta of t plus 1. Both outputs are not same. Here it felt like that if I apply t minus 1, I will get this output, and here also I will get the same output. So it feels like that it will be non-invertible. But the important point is, in the previous case, what really happened was this became 0 into delta t. So 0 multiplied with anything, output was 0. But if output is coming a certain value, you cannot do anything about it. Are you getting this point? So till this point, it feels like that it is invertible, right? This is what it feels like. But what if I apply xt equals to delta t? What I will get? Yt equals to t square delta t. What that would be? T minus 0, 0 into delta t. That would be 0 only. Now what if I apply xt equals to delta of 2t? This is different, right? This is xt, this is delta of 2t. Can I write it down in this manner? 1 by 2 delta of t. So what will be my yt? t square into 1 by 2 delta t. What will be the output? T minus 0, 0 goes here, 0 into 1 by 2 delta t, 0 multiply with anything, output is again 0. Right? So for different values of input, you are getting the same output. Delta t, delta 2t, both are different, but here you are having the same output. Same output. So you will draw the graph of ft, you will see where the output is becoming 0. Now your matter of concern would be 0 only. Your thoughts would be going around only 0. That's it. Nowhere else. Are you getting this point? And now in the previous example, you would get started confusion that, sir, what if I put delta t and delta of 2t here? Here you can directly draw the graph. You will get to know that this is the simplest thing. And here xt can go from -1 to 1 only. This is also one of the requirement. In these graphs, you got to know that it is non-invertible. Here in this case, you put delta t, delta of 2t. You will get the different answer. Delta of t, if you do the time domain if you do the running integration of delta t and delta of 2t, both will give you different answer only. Are you getting this point? But here you will say that, sir, I will apply delta n and delta of 2n. So delta of n and delta of 2n are same thing. Delta of n and delta of 2n are same thing. But delta of t and delta of 2t both are not same. Delta of n and delta of 2n both are the same thing. So here if I apply delta of 2n, here I told about this point as well, that if I apply delta of 2n, that doesn't mean this is the different input. This is the same input I am applying. Our target is to apply different input. So here I cannot do this process. But in this particular thing, if I apply delta t, my output will be ut. And if I apply delta of 2t, my output will be 1 by 2 ut. So for different input, I am getting different output. So it is invertible only. Are you getting this point? Okay. Let's see more cases. If I apply delta t here and delta of 2t, again I will get the different output. E to the power delta t. If I apply delta t, I am getting e to the power delta t. And if I apply delta 2t, then I will get e to the power 1 by 2 delta t. What I mean to say is that if I apply delta xt equals to delta t here, what I am getting? E to the power delta t. And if I apply xt equals to delta of 2t here, so that would be 1 by 2 delta t. So what is the output I am getting? E to the power delta t by 2. So e to the power delta t, e to the power delta t by 2. Both are the different outputs. So for different input, you are getting again different output only. So whenever I teach this example, I feel like that people will be having the confusion in the previous examples. Now you put delta t here, what will be the output you will get? Delta square t. If you put delta of 2t, what will be the output you will get? 1 by 4 delta square t. Delta of 2t whole square. What that would be? 2 comes outward. 1 by 2 delta t whole square. So what that would be? 1 by 4 delta square t. So yeah, again it is, okay, here it is non-invertible only. I don't need to put a delta of t or whatever it is. I just need to see the values here. Xt equals to 1, xt equals to -1. This is invertible. This is invertible. So here I may have confusion. So for this particular thing, what I need to do? This was already non-invertible, no issue. This is invertible. So here what student will be thinking that, sir, I will put xt equals to delta t. So this will be the output I will be getting. Now I will put xt equals to delta of 2t. So this is the output I am getting. Are both of them same? No. Here 2 comes outward, 1 by 2, then 2 goes upward actually. So this is your 1 by delta t, this is the output 2 by delta t. So for different values of input, you are getting different output actually. So all the examples you can check. Only in ft dt, only in ft dt, in ft dot xt, only in ft dot xt, you will have this kind of issues. That you apply delta t, you apply delta 2t, you will get same output. So whenever ft dot xt pattern is coming, you should be very aware that this will be a good question based on invertible and non-invertible. So if it is a good question, what I need to do? I need to have the patience. I will draw the graph of ft versus t. What I will do? Ft versus t I will draw. Ft versus t I will draw. And there I will check when it is becoming 0. It is becoming 0 at one point only. Right? So what I need to put? Delta t and delta 2t. Now if it is becoming 0 at multiple points, 0, pi, 2 pi, 3 pi, then what I can do? Then I can apply delta of t minus pi, delta of t minus 2 pi. Next is e to the power t xt. What is the next? E to the power t xt. So next example is yt goes to e to the power t xt. Now I will draw the graph of e to the power t versus t. Is it ever becoming 0? It is becoming 0 but at infinity. It is becoming 0 but at infinity, right? On a finite value of t, this is the graph of e to the power t. At t equals to 0 it is 1, at t equals to infinity it is infinity, at t equals to minus infinity it is 0. So at a finite value of t it is never becoming 0, right? So you put delta t, you put delta of 2t, let's see what answers we will get. Okay, so if I put xt equals to delta t, I tried thinking about it. I know that here the value is 1 but it is not becoming 0 anywhere, so some input I need to put. So let's put that particular input. So yt equals to e to the power t delta t. What I will get? E to the power 0 into delta t. E to the power 0 is 1, so it would be delta t only. Now you put xt equals to delta of 2t. So what will be your yt? Yt will be e to the power t delta of 2t. So what can happen? 2 can come outward. So 1 by 2 e to the power t delta t. So t minus 0 e to the power 0, that would be equals to 1 by 2 delta t. So when applied input was delta t, this was the output. When applied input was delta 2t, this is the output. So output is different here. For different value of input, outputs are different. So you cannot say it is non-invertible. It is invertible only. No matter whatever the input you put, it will always be invertible. And how you can verify this particular thing? You can verify this particular thing by seeing the graph of e to the power t versus t. It is becoming 0 nowhere. It is becoming 0 at t equals to minus infinity, which is not a finite value of t. So this particular graph is becoming 0 nowhere, right? What does that mean? That means that this will be surely invertible. Invertible. Okay, let me frame another question out of it. What I'm gonna do? I'm gonna frame another question. So yt equals to ft dot xt, where the graph of ft is mentioned. Graph of ft is mentioned with respect to t. Ft versus t is mentioned. This graph is also given in the question itself. Let us call this value as 2. This is the graph of ft versus t. Yt is equals to ft dot xt. Okay, you need to tell whether it is invertible or not. Invertible or not. So what you can judge from here? That at delta of at t equals to 2, ft will become 0. So what I will do? I will apply xt equals to delta of t minus 2. Right? So for that, what will be your output? Yt will be equals to f of t dot delta of t minus 2. So this 2 goes here. F of 2 dot delta of t minus 2. F of 2 dot delta of t minus 2. What is the value of f of 2? F of 2 is 0. Yes, if I am getting 0, now I am happy. If I have got 0, now I am happy. What kind of next input I can apply? Delta of 2t minus 4 I can apply. Can this be written as 1 by 2 delta of t minus 2? Both inputs are different. I could have directly applied 1 by 2 delta of t minus 2. Why to do all this process? I could have directly applied 1 by 2 delta of t minus 2. So yt equals to ft dot 1 by 2 delta of t minus 2. So this 2 goes here. So f of 2 1 by 2 delta of t minus 2. What is the value of f of 2? 0. Two different input, same output. So now the conclusion is clear. I hope I have given enough example. I hope I have given enough intuition as well that how I am gonna check. So ft dot xt, a very interesting question. If they want to frame a good question on invertible and non-invertible, they will frame the question based on ft.xt only. That's it. So you need to draw the graph of ft versus t. Then you check if your ft is becoming 0 anywhere. If it is becoming 0 anywhere, then your job is done. You check at delta t minus, here it was becoming 0 at 2. So I checked at delta of t minus 2, then 1 by 2 delta of t minus 2. Same output I am getting, non-invertible. Okay. In this example, never becoming 0, invertible. In this example, becoming 0 at t equals to 0. Yes, that's why it is. Here I did not even write non-invertible. And here becoming 0 at a lot of places, so surely non-invertible. I hope all these conclusion is clear to you, right? Let's see this question. In discrete time we are checking. So same concept, same goes. This will become non-zero at a lot of places. Sorry, this will become 0 at a lot of places. Like n equals to 3 you put, you will get it 0 only. And n equals to 6 you put, you will get sine 2 pi, again 0. What I mean to say is that I will put x of n equals to delta of n. What I am putting, x of n equals to delta of n. So what will be my y of n? That would be sine pi by 3n into delta of n minus 0 it is. So this 0 goes here. So sine 0 is 0 only. So 0 dot delta of n will be 0. Now if I put xn equals to delta of n minus 3, I could have directly put 1 by 2 delta n. Why to put x of n minus 3? Sorry, why to put delta of n minus 3? I could have put 1 by 2 delta n. These are also two different input, no? 1 by 2 delta n. What output I am getting? Sine of pi by 3 into 1 by 2 delta of n minus 0. Then this 0 goes here. Sine 0 is 0 only. Again you are getting 0. So delta of n you put, 1 by 2 delta of n you put, you are getting the same output. What does that mean? Non-invertible. Next one you will try. Next one you will try on your own. A to the power minus n x of n. What do you think? What will be the answer? A to the power minus n x of n. Will it ever be 0? A to the power minus n. What will be the graph of a to the power minus n? At n equals to infinity, it will be infinity only. So it will kind of start like this. Very high, then low, then more low. Okay, we cannot make it. Then here. So in that manner, it will keep on going. Basically, at n equals to 0, it is e to the power 1. At n equals to 0, it is e to the power 0. At n equals to minus 1, it is e to the power 1. At n equals to minus 2, it is e to the power 2. At n equals to minus 3, it is e to the power 3. At n equals to 1, it is e to the power minus 1. At n equals to 2, it is e to the power minus 2. In that manner, the values are there. Okay, so this is your f of n. F of n versus n. So when it is becoming 0, at n equals to infinity, when n equals to infinity, it is becoming 0. But that doesn't count, right? So if you put delta n, if you put a delta of 2n, sorry, if you put delta of n or 1 by 2 delta of n, both will be different. What I mean to say is that I put x of n equals to delta of n. So what will be the output? A to the power minus n delta of n. 0 goes here, delta of n. What I put? 1 by 2 delta of n. What will be y of n? E to the power minus n into 1 by 2 delta of n. So what happens? 0 goes here, 1 by 2 delta of n. So different output only you are getting, or from the graph of f of n also you can analyze that it will give you 0 value at n equals to infinity, and that doesn't count. So for a finite value of n, you are never getting the 0 value. That means it is invertible. Well and good. So these examples were there. Do we have more examples? No. So let's revise all the examples. So these were the examples of f of n dot xn. So in that you need to draw the graph and you will get to know, right? Here you can draw the graph versus yt versus xt, yt versus xt. So yt versus xt, if I can draw, then I just have to draw the parallel line. Will have to draw the line parallel to x-axis if it is cutting only once, invertible, otherwise non-invertible. In these kind of examples, delta of t minus 1. Whenever I am not able to think, delta of t will come into action. That's it. Okay. So this was non-invertible. These were invertible, integrator and summation. Here I can draw the graph. Here 1, 5 random values I can put. Here also I can draw the graph. Here also I can draw the graph. Okay. So in that manner I checked the examples. I hope this particular concept is very confusing for a lot of students, especially that stable unstable that we saw in the previous video, and this invertibility and non-invertibility. Those are very confusing topic for the students. I hope now we have a clear idea, and whatever the kind of questions they can ask, that we are already seeing. Okay, so no need to worry. Every particular pattern of the problem will be from the class notes only. That's my sure guarantee. Right? Let's go to the next topic. You can say you need to find the inverse of a particular invertible system. So what I mean to say is that this is a system, right? This is a system. I applied xt, what I get? Output yt. So I am saying that this particular system is invertible. This particular system is invertible. I applied input xt, I got output yt. Now here what I am gonna do, I am gonna apply the inverse of invertible system. What does that mean? That here I need to frame a system in a manner that again I can get my input. So I applied input xt, I got the output yt, then here I framed a system which is the inverse of this particular system, and again I am getting my output xt only. So yt equals to cos of xt. What will be the inverse system of that? Yt equals to cos of xt. So what you are going to do? Applied input is xt. Yt equals to cos of xt. So what it is doing? Whatever the input is coming, it is making cos of that. So yt equals to cos of xt. Now again I need to get xt. What does that mean? That I need to do the cos inverse of yt, cos inverse of yt. And what is yt? Cos of xt. Yt is cos of xt. So cos inverse of cos of xt will give you xt. Wrong. Everything is wrong here. Why is that so? All this process is wrong. Inverse system you need to find. Inverse system you can find only for invertible system. Very important point. So it has to be an invertible system. Cos of xt is not an invertible system. Cos of xt is not an invertible system. So this system is non-invertible. So for non-invertible system, you cannot find the inverse system. For finding the inverse system, the given first system, this has to be invertible. So let's see the next example, e to the power xt. Is it invertible? Yes. You can draw the graph between yt and xt. You will get to yt and xt. If you draw the graph, this kind of graph you will get. No matter how many parallel lines you draw, it will cut only once. So yeah, this is invertible system. Invertible system. So what it is doing? This was your particular system. Applied input is xt. So whatever the input you get, it will do the exponential of that. So output will be e to the power xt. After that, another system I need to apply. And what is my target? My target should be that my output should be xt only. So what I can do? To remove this e to the power, to remove this e, what I can do? ln. Right? I am calling this as yt. So if my xt is ln yt, if my xt is ln yt, this is my xt. So what is the value of yt? Yt is e to the power xt. So ln and e will cancel out each other. What is this? Xt only. So what is the characteristics of inverse system here? The characteristics of inverse system is, this is the characteristics, that if your applied input is alpha t, and output is beta t, if your applied input is alpha t and output is beta t, then what it is doing, it is taking the ln of input. So beta t is equals to ln alpha t. So this is the characteristics. Okay, and how I could have directly found it? I don't need to do all this process. So first thing I will get to know that it is invertible system. So yt equals to e to the power xt. So from here I will find xt in terms of yt. So xt in terms of yt I have found out. There you go. Are you getting this point? Xt in terms of yt I have found out. So xt equals to ln yt. Now if I am saying that my input xt equals to ln yt, so this is the output here now, and this is the input. This is the output, this is the input for my inverse system. For this inverse system, this is your inverse system. So in this inverse system, what is the input? Input is yt, and what is the output? Output is xt. Input is yt, output is xt. So this is the inverse system I am having. So in this inverse system, if I apply my input to be yt, then my output will be ln yt. Is that clear to you? So this is the characteristics of your inverse system, or this is the equation of your inverse system, input output equation of your inverse system. Or you can write down in this manner that if my input was alpha t, then my output will be beta t. So my output will be beta t equals to ln alpha t. Well and good, very easy thing, right? Yt equals to x square t, non-invertible, no? This is non-invertible. Invertible. That means inverse system doesn't exist. So always the first task would be, to find out whether the given system is invertible or not. If it is non-invertible, inverse system doesn't exist. Okay. Yt equals to txt. What kind of form is there? Yt equals to txt. What kind of form is there? ft dot xt. Right? And for that, what I need to do? I need to draw the graph of ft versus t. ft versus t I need to draw. So graph of t I need to draw basically. This is the graph of t. This is the graph of t. So here I get to know that it is becoming 0 at t equals to 0. So what does that mean? That if I put xt equals to delta t, then yt would be equals to t delta t. So t minus 0 would be 0 only. And if I apply xt equals to 1 by 2 delta t, what will be my yt? Yt will be t into 1 by 2 delta t. So t minus 0, again it will be 0 only. So delta t 1 by 2 delta t. What you are getting? You are getting the same output. So for different input you are getting the same output. What does that mean? Again it is non-invertible. So again there will be no inverse system. Okay. So this is a very simple process. Basically you need to find out your xt in terms of yt. That's it, nothing else. What they are saying? Prove that inverse of an invertible system is not needlessly. What you need to prove? Inverse system of an invertible system need not to be invertible always. Did you understand the meaning of this? Let's get back here. So is this an invertible system? Yes, invertible. Then what is the inverse system we are getting? Beta t equals to ln alpha t. So is this an invertible system? Yes, this is also invertible. There was an invertible system, you find out the inverse of that particular invertible system, you got to know that this particular inverse is also invertible. There was an inverse system, there was an invertible system, you find out the inverse system of that particular invertible system, and whatever the system that you are getting here, that is also invertible. But it is not always necessary that this particular system has to be invertible. This is not always necessary. Let's understand this by an example. So what I am saying, yt equals to cos inverse xt. Is this invertible? Yes, we have seen this is an invertible system, right? So what I'm gonna do, I'm gonna apply input xt. What is the output I'm getting? What is the job of this? Cos inverse. So what is the output I'm getting? Cos inverse xt. This is the output I'm getting. Now I need to find the inverse system. What I need to find? I need to find the inverse system. So yt equals to cos inverse xt. So I need to denote xt in terms of yt. So what will be my xt? Xt will be cos of yt. So the input of this particular system is yt. Input of this particular system is yt. And what is my target? My target is getting xt out of it. So here what I need to do? Cos of yt, that would be equals to xt. So cos inverse of xt. Xt will be equals to cos inverse of xt. Right? So what will be your output? What will be the input output relationship? What is your inverse system? Basically your inverse system is, if I am saying that my beta t is my output, beta t is my output. So my inverse system is cos of alpha t. This is my inverse system. Is this invertible or not? Is this system, this is your inverse system, but this inverse system is invertible or not? Cos of xt, yt equals to cos of xt. Can you draw the graph? Yes. So if I draw the graph, what do I see? If I draw a line, so it is cutting on multiple points. So this is not invertible. So this was invertible. This was invertible. If this was invertible, that's why we could find the inverse of that particular invertible system. But the inverse that we found out, this is non-invertible. So here in these cases, here in this cases, the inverse system was also invertible. The inverse system was also invertible, but here in last case, the inverse system is non-invertible. So what is the statement? The inverse system of an invertible system need not to be invertible always. So these kind of questions can be asked in statement wise true or false. So inverse system of an invertible system. So conclusion is, you can always find the inverse of an invertible system. You can always find inverse of an invertible system. But the inverse of the invertible system need not to be invertible always. There you go. That's it. That's the complete conclusion. And this is the complete classification of systems. Okay. So the classification of system is done. Now what we have studied? We started with LTI system. Then we went to causal, non-causal. Sorry, started with LTI, then we studied static dynamic, causal, non-causal, stable, unstable, and invertible, non-invertible. So starting was done with LTI, right? Linear and time invariant. Again, now we will be going back to LTI. So now what we need to study? We need to study the properties of LTI system. That means if your LTI system is causal, then how will the impulse response behave? If your LTI system is causal, then what will be the characteristics of HT? If your LTI system is invertible, then what will be the characteristics of HT? If LTI system is stable, then what will be the characteristics of HT? So in that particular LTI system, we had the HT. What was HT? Impulse response of LTI system. So if your LTI system is stable, unstable, or it is causal, non-causal, or it is static, dynamic, or it is invertible and non-invertible, then what will happen to that particular HT? That we need to study. So I hope the flow of this complete chapter is clear to you. We started with what we started with convolution. Convolution is something that is related with LTI system, but I did not want to teach this with respect to the systems only. Here we are just seeing the properties of system. In between, if I had started convolution, then it would be just a complete mess up. So I taught convolution separately. I did not even teach about systems there. We got to know what is a convolution. Then we came to LTI system. In LTI system, we studied about what is the meaning of linearity, non-linearity, and then we studied about time invariance and then time variance. Then we know where the convolution is used. After that, we went to the other type of system that were static dynamic, causal, non-causal, stable, unstable, invertible and non-invertible. Now what we are going to do, these 4 type of system we are going to apply in the LTI system. That if your LTI system is causal, then what will be the property? If your LTI system is non-causal, then what will be the property of HT? If your LTI system is stable or invertible, what will be the property of HT? So this was the flow. I hope you understood the flow. I hope you have enjoyed the flow as well, because the problem with this particular chapter is the systems become very complex for a lot of students. This particular chapter, systems become very complex for a lot of students. The reason is the flow is not clear. Sometimes we study LTI, then we study causal, non-causal. So flow becomes very strange. But now our major target here was to maintain the flow. Now everything is being crystal clear to you. So next video, we are going to study about the properties of LTI system. Thank you very much. Hi everyone. So in this video we need to study about properties of LTI system. Like if your LTI system is causal, then what will be the impulse response? If it is stable, then what will be the impulse response? If it is invertible, then what will be the impulse response? If it is static, then what will be the impulse response? So these kind of things we need to see. But before that we will see some basic concept of signals, okay, which is required for this particular video. So that I forgot when we were studying basics of signal. So this is the concept related to basics of signal. It has nothing to do with systems. So there is something called absolutely integrable signal. What is the word? Absolutely integrable signal. So what is the meaning of absolutely integrable signal? That means, let's just say xt is a absolutely integrable signal. So from minus infinity to infinity, mode of xt dot dt, mode of xt, okay, mode of xt dot dt should be finite. So the whole area should be finite, but mode of xt. First you need to take the mode of that particular signal and then you need to calculate the whole area. That whole area should give you finite value. That is known as absolutely integrable signal. And same goes for discrete time as well, absolutely summable signal. So what you need to do? First you need to take the mode of xn and then you need to, here what I should write? Yeah, xn is fine. So first you need to take the mode of xn and then you need to do the whole sum from minus infinity to plus infinity. So whatever the samples are there, you just need to, first you need to take the mode of those sample and then you need to add them up. So if this is coming finite, then it is absolutely summable. Okay, in the word there is written absolutely, and absolutely goes for mode. If I ask you what do you mean by integrable signal, so that we have studied in elementary classes, like in 11th 12th classes, this is integrable signal. This is the meaning of integrable signal. But if I am saying absolutely integrable signal, that means I need to take the mode. So first you take the mode and then you calculate the area. Here also first you take the mode and then you do the summation. So let's see some questions. This is the signal given, xt is given 1 by under root t ut minus u of t minus 1. Is it an energy signal? And is xt is absolutely integrable? So can you find out the energy signal just by drawing the graph? If I draw the graph, can you let me know whether it is energy signal or not? So if I draw the graph, this is there between 0 to 1 only, because ut minus u of t minus 1. That means the signal will be non-zero from 0 to 1. 0 to 1. At t equals to 0, what will be the value? At t equals to 0, value will be infinity. At t equals to 1, what will be the value? It will be 1 only. So from infinity to 1 it will go. From infinity to 1, roughly somewhat like this it will go from infinity to 1, and after that everything is 0. So this kind of graph we will get. Right, xt versus t I am drawing. It cannot be negative, t value cannot be negative because there is under root. So is it a bounded function? No, right? It is an unbounded signal because it is giving you infinite value. So energy cannot be trapped, right? What thing I have told? For energy signal, either it should be finite duration signal. Is it finite duration? Yes, it is finite duration. It exists from 0 to 1 only. It is finite duration signal, but it is not bounded. If it is unbounded, no matter if any point of the time, if your xt is going to infinity, then it can never be energy signal. So not an energy. Is xt an energy signal? No. So it is not an energy signal, and you can check as well. How you will check? What is the energy? Minus infinity to infinity, mode of xt square dt. So minus infinity to infinity, mode of xt square. That means 1 by t. 1 by under root t square would be 1 by t only, dot dt. And the limit will go from 0 to 1. So this limit will go from 0 to 1. What is the integration of 1 by t? that is ln t. It will go from 0 to 1. So ln 1 minus ln 0. So ln 1 is 0, ln 0 is minus infinity. So what is the answer we are getting? Infinity. So what is the energy? Energy is coming out to be infinity. So certainly it is not an energy signal. Or by just looking at the graph, you could have told that it is not an energy signal. So this was A. Let's talk about absolutely integrable or not. So what I need to find? Minus infinity to infinity mod of xt dot dt. Here I don't need to do the square. So minus infinity to infinity 1 by under root t dot dt. But the limit will go from 0 to 1. Limit will go from 0 to 1. So what is the integration of 1 by under root t? That is 2 under root t. Goes from 0 to 1. So if I put 1 here, it will be 2. 2 minus 1. What is the answer? 2. So this integration you can solve on your own. T equals to 1 you put, t equals to 0 you will put. So what is the answer you are getting? 2. Is it finite? Yes. So what did you see here? Minus infinity to infinity mod of xt dot dt. What it is coming out to be? Finite. What does that mean? That means it is absolutely integrable. So what is the conclusion you are making from here? That just by looking at the graph, you can never tell whether it is absolutely integrable or not. Just by looking at the graph, can you tell it is energy signal or not? Yes, I can tell. We have spent roughly around 2 to 3 hours just on this particular topic, energy signal and power signal. So just by looking at the graph, you can certainly tell whether it is energy signal or not. But just by looking at the graph, can you tell if it is absolutely integrable or not? You cannot tell, because it feels like that it will not be absolutely integrable. It feels like that it will give you infinite result. But when you calculated, it is coming out to be finite. So it is absolutely integrable. So it was not an energy signal, but it is absolutely integrable signal. Let's check the other example. Is it an energy signal and is it absolutely integrable or not? So let's check it. Can I draw the graph? Yes. 1 by t it is, right? 1 by t. So at from where to where it will be non-zero? It will start from 1. It will start from 1 and it will go till infinity. So from 1 to infinity it will be non-zero. At t equals to 1 value will be 1, at t equals to infinity value will be 0. So at t equals to 1 the value will be 1. T equals to 1 value will be 1, at t equals to infinity value will be 0. At t equals to infinity value will be 0. So is it a bounded signal? Yes, it is a bounded signal, bounded. Is it finite duration? No. But is it vanishing? Yes, it is a vanishing signal, right? It is not there, it is not staying, or it is not rising. That means it is vanishing. That means at t equals to infinity, your xt is 0. When t is tending to infinity, your xt is 0. So yes, it is an energy signal and energy can be trapped here. Since it is vanishing and bounded, energy can be trapped. That means certainly it is an energy signal, right? So is it an energy signal? Yes. I don't need to do the differential. I don't need to do this particular energy calculation, or I can do the energy calculation as well. How will I do? Minus infinity to infinity mod of xt square dt. The limit will go from 1 to infinity 1 by t square dt, right? So what will happen? Minus 1 by t. So minus 1 by t minus sign I am eating up and I am interchanging the limit. So what is the answer we are getting? 1. So energy is coming out to be finite. So certainly it is an energy signal, or just by looking at the graph also I would have told that it is an energy signal. What about absolutely integrable or not? So minus infinity to infinity mod of xt dot dt. So limit will go from 1 to infinity only. Limit will go from 1 to infinity 1 by t dt. Here I don't need to do the square. So ln t 1 to infinity ln infinity minus ln 1. What is the value of ln infinity? It is infinity only. What is ln 1? 0. So what you are getting? Infinity. That means it is not finite. what we are getting, it is not finite. So energy is 1, but this value is not finite. So if it is not finite, then it is not absolutely integrable. So here it was not energy signal but absolutely integrable. It is not absolutely integrable but energy signal. So they are not related to each other. This is the conclusion I wanted to make. People will feel like that, sir, if it is absolutely integrable, that means it will be energy signal. And if it is not an energy signal, that means it will not be absolutely integrable. No, both are complete different thing. Both are complete different thing. Just by looking at the graph, you can tell it is an energy signal or not. But just by looking at the graph, you can never tell whether it is absolutely integrable or not. You have to calculate. And how will you tell energy signal is there or not? By looking at the graph that we have already studied in our basics of signal. Say yes or no. So this was a very, very important conclusion. What about this one, e to the power minus t ut? Is it an energy signal? Yes. I don't need to calculate the energy. I know the energy will be 1 by 2a, right? Yes, it is an energy signal. And what will be the energy? I told you to remember 1 by 2a. A value is 1. So this will be the energy. Energy will be 1 by 2 joule. Is it absolutely integrable as well? So let's check. Minus infinity to infinity mod of xt dot dt. Mod of xt dot dt. So minus infinity to infinity e to the power minus t dot dt, but the limit will go from 0 to infinity. Limit will go from 0 to infinity. So e to the power minus t, minus sign will come, but I am interchanging the limit. So that would be 1. So what it is coming out to be? It is coming out to be finite. So if it is finite, that means it is absolutely integrable as well. So in the first question, no, yes. In the second question, yes, no. In the third question, yes, yes. In the last question, no, no would be there. Is it an energy signal? No. Directly I can tell it is non-vanishing signal. At t goes to infinity, it is going to infinity as well. So it is unbounded signal as well. So nothing is matching. Certainly it is not an energy signal. And you can check by formula as well. I don't need to apply the formula. This we have already seen. It is not an energy signal. Let's talk about absolutely integrable or not. So let's talk about that. Minus infinity to infinity mod of xt dot dt. Limit will go from 0 to infinity e to the power t dt. E to the power t will be the answer. 0 to infinity e to the power infinity minus e to the power 0. Infinite minus 1 will be infinite only. So is it finite? Not finite. So here the answer is no, no. So there is no relation. There is absolutely no relation between energy signal and absolutely integrable. Okay, so this is the point that I wanted to deliver. And if you need to calculate whether it is absolutely integrable or not, so simply apply this formula, and your job will be done. Why we are studying it? Because it will be used somewhere. Okay, so let's start our topic, properties of LTI system. First we need to study causality, that if your LTI system is causal, then find the condition what will happen to the impulse response of LTI system. Why we are interested in impulse response? Because XT user will be applying, right? Let's just say someone is telling you design this particular LTI system. So HT is in my hand. If I'm asked to design this particular system, someone is saying that go and design this particular system. So HT is there in my hand. XT someone user will apply, and YT is the output that user will see. So applying the input and collecting the output is the job of user. What is my job? My job is to design this particular HT. I can design this HT in this manner. That, sir, this is my HT. You apply some input and get some output. You apply some input here, get some output here. This HT I can design. In place of R, I can put 2R. Then I can do something in place of R, I can put a capacitance. So whatever that I can do, I will do it. But HT is there in my hand, right? So let's write down YT now. So what will be your YT? YT is minus infinity, or first write down this particular thing. YT is equals to XT convolution with HT. Or what I can write down? YT is minus infinity to infinity x of tau h of minus tau plus t d tau. This is your YT. Say yes or no, right? What you need? You need it to be causal. Causal means your output at present time should be depending on the input at present time or past time. Basically, if I say my t is equals to 1 and tau is equals to 3, will it work for me? If I say t is equals to 1 So y1 will be minus infinity to infinity x of 3 h of minus 3 plus t d2. So forget about this h. I don't need to look at this h. If I am checking the causality, where I will look, for getting the output at t equals to 1, for getting the output at t equals to 1, you need the value of input at t equals to 3. For getting the output at t equals to 1, you need the input value at t equals to 3. Is it causal? No. It is depending on the future value of input. It is depending on the future value of input. So it is not causal. Right? Are you getting this point? So it is not causal. Now if I say my t is equals to 2 and tau is equals to 1. T is equals to 2, tau is equals to 1. So y2 will be equals to minus infinity to infinity x of t is equals to 2, t is equals to 2, x of 1, h of minus tau, tau is 1 only. But I don't care about this h, right? I only care here. So output at t equals to 2 second is depending on the input at t equals to 1 second. That means previously it is depending on the past input. So it is fine. Yes, this is causal. Are you getting this point? So from here, what is the conclusion you are making? That your t, what is the conclusion you have made from here? That your t should be greater than or equals to tau. This is the conclusion we have made for causal system. You can shortly write down these values, that if I put t equals to 1, then if I put t equals to 1 and tau equals to 3, then what is the issue? If I put t equals to 2 and tau equals to 1, then why it is causal? So all these things you can write down in rough work here. Okay, this is the space I am putting for you. You can write down here in the rough work, or what I do, I keep it here. So the rough work you can write down here. You are having enough space, or if you are able to remember, then you will be able to remember as well. So the condition that we have arrived at, that t should be greater than or equals to tau. What is in our hand? In our hand, this is there. I can design my h of minus tau plus t. I can design this ht. So what I will do? H of minus tau plus t. In this, what I need? That if your t is greater than or equals to tau, if your t is greater than or equals to tau, then it can be non-zero. It can be non-zero or anything. What will happen is that some input will come, then it will be multiplied with this particular value and some output will be produced. So it could be non-zero or 0, whatever it is. But if your t is less than 2, if your t is less than 2, if my t is less than 2, if my t is less than 2, then there is chance that my system can become non-causal. If my t is less than 2, then certainly my system will become non-causal. So what I will do, when t is less than 2, at that particular time, I will put this equals to 0. H of minus tau plus t should be equals to 0. So if your t is less than tau, then h of minus tau plus t is less than 0. So anything convolved with 0, xt convolution with 0, what that would be? 0 only. If this particular thing is 0, then whole every integration and everything will become 0. So if my t is less than tau, if t is greater than tau, then I am not saying that certainly it should be non-zero. It can be 0 as well. If t is greater than tau, then for some time it can be 0 as well. For some time it is some finite value, and for some time it can be 0 as well. But if t is less than tau, then certainly it has to be 0. What I am saying, h of t minus tau plus t is t minus tau. H of t minus tau should be 0 for t less than tau. Or what you can write down, t minus tau is less than 0. So if your t minus tau is less than 0, then h of t minus tau should be equals to 0. H of t minus tau should be equals to 0 when t minus tau is less than 0. In place of t minus tau, can I put alpha? H of alpha should be 0 when alpha is less than 0. Then in place of alpha, can I again put t? That h of t should be 0 if t less than 0. This is the condition for causality. Did you understand the point? From here I got to know that if my t is greater than or equals to tau, then only it will be causal. So if your t is less than tau, then there is xt is not in my hand, yt is not in my hand. In my hand, h of minus tau plus t is there. This is there in my hand. So if your t is less than tau, then I thought that this should be equals to 0. So this is what I have written. If your t minus tau is less than 0, or you can say if t is less than tau, then this particular thing should be equals to 0. So there I got to know that this bracket thing and this bracket thing are same. So in place of t minus tau I put alpha, then alpha I replace with t. So h of t should be equals to 0 for t less than 0. For t greater than 0, it can be non-zero for some time, it can be 0 for some time, whatever it is, that I don't care. But for t less than 0, h of t should be 0 for your LTI system to be causal. So this is what we have written. For an LTI system to be causal, your h of t should be 0 for t less than 0 and your h of n should be 0 for n less than 0. Is that clear to you or not? So what kind of question will be coming? The impulse response of an LTI system is given. All these systems are LTI system only, but which of them will be causal? So is it 0 for t less than 0? Yes. So it is causal. Is it 0 for t less than 0? No. It is non-causal. Is it 0 for t less than 0? Yes. Here it is 0. Here also it is 0. This was also 0. But I don't need to see for t greater than 0. I need to see for t less than 0. Is it 0 there? Yes. That means it is causal. Is it 0? No. That means it is non-causal. What about this one? For t less than 0, it is non-zero. No, the graph of h of minus t is given. No, I need to draw the graph of h of t. So from here, how do I draw the graph of h of t? So this is the graph of h of minus t. So what will be the graph of h of t? H of t will be somewhat like this. What I need to do, I need to take the mirror image. I need to take the mirror image. One, two. H of t, t. This is the causal, right? H of minus t is given, no? But what will be the graph of h of t? So it is 0 for t less than 0. H of t is 0 for t less than 0. If it is 0 for t less than 0, then it is causal only. What about h of 2t plus 4? So h of 2t plus 4 is given. What you need to draw? You need to draw ht. So have you seen this kind of question in basics of signal? Yes. So how h of 2t plus 4 would have been drawn? You would have started your journey from h of t, then you would have gone to h of t plus 4, and then you would have gone to h of 2t plus 4. So whatever the limit was, let's just say it was there from, it was non-zero from alpha to beta. Then t plus 4, that means it would have been shifted backward. So shifted backward, t plus 4, that means shifted backward. So alpha minus 4 to beta minus 4, right? And then 2. So your time domain is being multiplied by 2, that means your time axis will be divided by 2. So alpha minus 4 divided by 2 to beta minus 4 divided by 2. So it will be non-zero between alpha minus 4 divided by 2 to beta minus 4 divided by 2. So what is alpha minus 4 divided by 2? That is equals to minus 1. So what is the alpha? 2. And beta minus 4 divided by 2, that is equals to minus 1 by 2. So what is the value of beta? That is 3. That means it was non-zero between 2 to 3. So whatever the graph was there, but I got to know that it was non-zero between 2 to 3. That's for sure. This is your ht. So it was non-zero between 2 to 3. So t plus 4, that means 4 backward. So minus 2 to minus 1 and then divided by 2. Yeah, it is getting the same graph. Basically from h of t I was going to h of t plus 4 and then I was going to h of 2t plus 4 just to check that if my calculation was correct or not. So yeah, it is correct. So this is the h of t I am getting. Here it feels like that it will be non-causal. But when I draw the h of t, I got to know that it is 0 for t less than 0. That means it is non-causal. Okay. So that's it. This is the complete conclusion. So basically the conclusion is if your LTI system is causal, then h of t should be equals to 0 for t less than 0. H of t should be equal to 0 and h of n should be equal to 0 for n less than 0. Otherwise, it will not be causal. So this was non-causal and this was also non-causal because for n less than 0, it was non-zero, right? Here both of the cases were causal only. Why I am writing non-causal? Great. I am really sorry. It was causal only, no? Why I wrote non-causal? Just a brain fade. We call it brain fade. These kind of things happen in the examination also sometimes with the students. Everything you did right, all concept is clear, but at some time something happened that you wrote down non-causal there, and you would have clicked in the examination all on non-causal. Everything you did correct, but what you can do about these minor mistakes, right? It would be causal. This is also causal, no? For t less than 0, it is 0 only. So if for t less than 0, if it is 0, then it would be causal only. That's it, right? Static. What you need? You need the system to be static. So I need to take a break. I will drink some water and then I will come back. So you write down the condition on your own. What should be the? How will your impulse response look like? Why I am caring about impulse response? Because what is there in my hand? In my hand only HT is there. So what will be the nature of HT such that your system is static? So you write down on your own. Okay, try doing it on your own. Yeah, so let's start again. So you let me know some system which are LTI as well and which are static as well. Yt equals to sine of xt. If you say yt equals to sine of xt, is it static? Yes. At t is equals to t. Basically, whatever the output you get at t equals to 1, the same output you will get at, whatever the output you get at t equals to 1. So output at t equals to 1 will depend on input at t equals to 1 only. Output at t equals to 2 will depend on input at t equals to 2 only. So it is static. But is it LTI? No. Non-LTI. So you need to tell me those systems which are static as well and LTI as well. Yt equals to 5 by 3 xt. Is it LTI? Surely yes. It is LTI. Is it static? Yes. So there is only one kind of system. There is only one kind of system which is LTI and static, which is this. There is only one kind of system which is LTI plus static. Nothing else is there. Can you let me know any other signal which is static as well and LTI as well? Someone will say that, sir, y equals to x square t. It is static, but is it LTI? No. What is the condition of LTI? That f of xt is not acceptable. Right? F of xt is not acceptable. So there could be no function here. And what is the condition of static? That inside I don't want any function. This I don't want. This will be LTI, right? This will be LTI. Sorry, this will also not be LTI because this will be linear, but it will not be time invariant. So there is also an issue. Everywhere is the issue. Only this is acceptable, right? So this is LTI plus static. So what I need to make? I need to make somewhat like this. My Yt is xt convolution with ht, but I need somewhat like this output. What I need? I need a of xt. My Yt should be equal to a of xt. So what do you think? What should be your impulse response? It should be a delta t, right? Because a will be constant, and xt convolution with delta t, what it will throw? Xt only. So what is your ht here? A delta t. So for an LTI system to be static, ht should be a delta t and hn should be a delta. So in one line they can ask these kind of questions. Okay, if your LTI system is static, then what would be the nature of your impulse response? Your impulse response will be a kind of impulse signal, and your impulse response for discrete time, it will be an impulse sequence. So in one liner these kind of questions can be asked, nothing else. So for static we have got to know that it should be impulsive, having any kind of area, and for LTI we got to know that it should be like a causal signal. Is this the property of causal signal? Although I have always said that h of t is not a signal, it is the impulse response of LTI system. So h of t is not a signal, but kind of can you relate what was causal signal and non-causal signal? Causal signal was, sorry, causal and anti-causal. So what was the meaning of causal signal? We draw these kind of diagram, that it would be 0 for t less than 0, that's it. What about anti-causal? It would be 0 for t greater than 0. And what about non-causal, which are neither causal nor anti-causal, they are non-causal. So forget about all these things. Just remember causal. So if you want your LTI system to be causal, then your impulse response should be a causal signal. Can you remember this statement? Although this statement is wrong, that's why I did not write it down, because HT is not a signal. HT is not a signal. It is impulse response of LTI system. So that's why I did not write it down in statement that HT should be causal signal, because that doesn't make any sense. Because HT is not even a signal. We have spent roughly around 30 minutes on this discussion that HT is not a signal. What is the meaning of HT? So that's why I am not writing down in the statement, but kind of can you remember in that manner that if you want your LTI system to be causal, then it should be 0 for t less than 0. It should be 0 for t less than 0. That means it is a kind of causal signal only, right? Otherwise it will be non-causal. Otherwise your LTI system will be non-causal. So just by looking at HT, you can comment whether your LTI system will be causal or non-causal. Okay. So all the discussion is revolving around LTI system only. Now you want your LTI system to be stable. So what is the condition for that? So you don't need to derive it. Simply the condition is for an LTI system to be stable, h of t should be absolutely integrable. So that's why we studied absolutely integrable signal. H of t should be absolutely integrable. Okay, and h of n should be absolutely summable. What does that mean? That minus infinity to infinity mod of ht dot dt should be finite, and mod of hn n goes from minus infinity to infinity should be finite. Well and good. All fine. Okay. For an LTI system, the impulse response is given whether it is stable or unstable system, that you need to tell. So if you add all of them, what will be the summation? What will be the value of this particular thing? Mod of hn n goes from minus infinity to infinity. What that would be? 1 plus 1 plus 2. This minus 1 will become plus 1 because you need to take mod. So 1 plus 1 plus 2. What that would be? 4. But what about this case? What is this? N goes from minus infinity to infinity. Mod of hn. So mod of hn is un actually, right? Or what you need to do? You need to add till infinity only. So 1 plus 1 plus 1, it will be added till infinity. So what will be the answer? Infinity. So what was this? Stable. But this is coming to be not infinite. Sorry, this is not coming to be finite. This is not coming to be finite. This is infinite. That means it is unstable. What about this one? What will be the graph of this particular thing? H of t ut. So what will be the graph? This will be the graph h of t. So if you do the integration, what will happen? Area will keep on adding up. Basically, if you do this particular thing, what will be the integration here? Certainly it will be infinity only, no? You can check as well. The limit will go from 0 to infinity. What will be the value of ut? That would be 1 dot dt. So what is the integration? T, 0 to infinity. Or just here, looking at here only, you can tell that if I keep on adding up, it will keep on adding up. So area will go to infinity only, or from here also you can tell that it will be infinity only. What about 2u of t plus 2 minus 1 minus t minus 2? So can you draw this kind of graph? First there will be a jump of 2. Basically what you need to see, first there will be a jump of 2. Then there will be a decay of 1. Then there will be decay of another 1. So 2, then there is a decay of 1. Then there is a decay of another 1. So what is this? This is a finite duration signal. That means this area will be finite only. You don't need to draw the exact graph. Although here I am drawing the exact graph, but can you think intuitively that first increase of 2 will be there at minus 2. Increase of 2 is there at minus 2. Then there is a decay of 1. Then another decay of 1 is there. And after that it will remain as it is. So minus 2, then there is a decay of 1, then another decay of 1. So there is a increase of 2, then decay of 1, that means you are coming at 1 and then you are going to 0. So this is your h of t. So here if you calculate this particular thing, I don't care about the value, whatever the area I am getting, but one thing I am pretty sure that this would be finite only. So this was unstable because the area was coming infinite, but this would be stable. Now can you think about it intuitively? Yes. First there will be a jump of 2. So first there will be a jump of 2 and then there will be a decrement of 1, but that remains as it is. So this kind of graph you will get. So what will be this area? You can keep on adding up this area, it will go to infinity only, or you can draw the graph as well. At 2 there will be a jump of 2 and then there will be a decay of 1. Jump of 2 and then decay of 1. Then you calculate this area, minus infinity to infinity mod of ht dot dt. What will be this area? This area will be infinity only. You can check here, this area I will keep on adding up, so that will go to infinity. So what do you understand from here? This will be unstable. So very easy question. If these kind of questions are coming in the examination hall, you should be happy that if your LTI system is stable or not, if your LTI system is causal or not, if your LTI system is static or not. So you should be happy. These kind of questions can be solved very easily, right? Let's move to the next one, invertible and non-invertible. So this concept will be again introduced when we study Laplace transform and Fourier transform. Okay, but here also you can very easily understand it. This is my invertible LTI system. What I am saying, this is my invertible LTI system. So if I apply a input xt, I am saying that impulse response of this invertible LTI system is ht. Okay, so if it is invertible, can I find the inverse? Yes, you can find the inverse. So what will be the impulse response of this particular inverse system? That is h inverse t. So first there is the invertible system, then there is inverse of that particular invertible system. So what will be your final output? Will be xt only. I told you there is one particular input, then there is a invertible system, then there is inverse of that particular invertible system. So what will be the final output after that? xt only. So xt convolution with ht. What will be the output here? xt convolution with ht. And what will be the output after this? xt convolution with xt convolution with h invertible t should be equals to xt. Say yes or no. So what do you understand from here? ht convolution with h invertible t should be equals to delta t. Say yes or no. Or what you can write down, h of n convolution with h inverse of n should be equals to delta of n. Okay, basically in Laplace transform the convolution will be interchanged to multiplication. So this can be written as h of s dot h invertible of s would be equals to, what is the Laplace transform of delta of t? That would be 1. So hs should be equals to 1 by h 1 h invertible s. So what will be the, basically what kind of questions will be asked? That what will be the impulse response of this particular invertible system? This is what they will be asking. That what will be the impulse response of inverse of the invertible LTI system? Impulse response of inverse of the invertible LTI system. Inverse of the invertible LTI system. So they will be asking this particular inverse, they will be asking h inverse t. These kind of questions will come. So although as of now we will not solve it with the Laplace transform or Z transform, this can be replaced as h of z dot with h invertible z is equals to 1. H inverse z is equals to 1. Although we are not going to solve it as of now with the Laplace transform and Z transform, because you don't even know what is Laplace transform, what is Z transform. But when we study Laplace transform and Z transform, all these things will come back. Okay. So let's solve the question as of now. So impulse response of invertible LTI system is given, h of n is given. Find the impulse response of inverse of the given LTI system. So inverse of this particular LTI system. So what I need to find? I need to find this particular thing. This is what I need to find. What do I know? That h of n convolution with h inverse n is equals to delta of n. So h of n is given. convolution with h inverse of n is equals to delta of n. Yeah, sorry for the interruption. So this equation we got, right? This is your h of n, h inverse of n is equals to delta of n. So now what you need to do, you need to put the options. Now I need to put all these options, because what I need to find, I need to find this h inverse of n. This is what I need to find. So for that I need to put the option that if my h inverse of n is this, will I be getting delta of n? If my h inverse of this, will I be getting delta of n? So this is what you need to do. But in the examination hall, you will be solving it with Z transform. It would be very easy there. There you don't need to check the options. Basically what you will do there, Z transform of this is Z upon Z minus 1 by 2. Then this remains as it is. This will be Z inverse Z, and Z transform of this is 1. So Z minus 1 by 2 divided by Z. So 1 minus 1 by 2 Z inverse. So 1 is delta n, and 1 by 2 Z inverse is 1 by 2 delta of n minus 1. So this option you will be checking 1 by 2 delta of n minus 1 or plus 1. What is the issue here? Delta of n minus 1. It should be n minus 1 here, right? This should be n minus 1. Okay, so this is how you will be doing in the examination hall, but as of now you don't know anything. So what you will do? You will have to check by the options. At 1 by 2 u of n convolution with delta of n minus 1 by 2 delta of n minus 1. So let's check what I am getting. 1 by 2 to the power n un convolution with delta n, that will be as it is. So 1 by 2 un minus 1 by 2 to the power n convolution with 1 by 2 delta n minus 1. So whatever the shift is there, that will be replaced here as well. So 1 by 2 1 by 2 constant, then 1 by 2. In place of n, you need to put n minus 1, u of n minus 1, right? So from here, what do you see? 1 by 2 to the power n u of n minus 1 by 2 into 2, because what is this? 1 by 2 to the power n minus 1. So can I break it down like this? 1 by 2 to the power n into 1 by 2 to the power minus 1. So what this will be? This will be equal to 2. So 2 into 1 by 2 to the power n. So I can write down it as 2 into 1 by 2 to the power n, right? U of n minus 1. So this 2 and 2 is getting cancelled. So what you are getting, 1 by 2 to the power n is common. U of n minus u of n minus 1. So what is this u of n minus u of n minus 1? What is that? That is equals to delta of n only. I hope you know this thing. This is equals to delta of n. What is the graph of u of n? What is the graph of u of n minus 1? Till this point everything should be comfortable. Then this thing will be separated. Only this delta of n will be remaining. So what you are getting? 1 by 2 to the power n delta of n. So n minus 0, that 0 you will put here. So what you will get? 1 by 2 to the power 0 delta of n. That would be equals to delta of n. Yes. So by option A only you are getting that it is coming out to be delta of n. That means what is the answer? Option A. You can check option B, you will not get the correct answer. And both and none, there is no chance of that. Okay. So although as of now we are solving in this manner, but in the examination hall we will be solving with respect to our Z transform only. Okay. So using the Z transform, we would be very easily able to solve. We wouldn't have to check the options. So that's it about the invertible system as well. So let's write down all the conclusion that if your LTI system is causal, then your h of t should be 0 for t less than 0, or you can write down h of n should be 0 for n less than 0. What is the meaning of static? H of t should be equals to a delta t, h of n should be equals to a delta n. What is the meaning of stability? Minus infinity to infinity mod of ht dot dt should be finite, or I can say less than infinity, should be finite, right? Or n goes from minus infinity to infinity, h of n should be less than infinity, or I can say should be finite, or you can say less than infinity. What do you mean by invertible? So ht convolution with h invertible t should be equals to delta t, or hn convolution with h invertible n should be equals to delta of n. So this is the complete condition. These are the complete conclusion. If you just remember this slide, then your job is done. Last 40 hours of last 40 minutes of discussion just depend on this particular slide only. Okay, well and good. Now the video is not completed. One more small concept we need to see. That would be kind of discussion only, or some questions only will be there. But we have completed 2 chapters now. Roughly we have completed 2 chapters, basics of signal and system. Only 10 minutes of concept is remaining. Ideally there should be assignment after this, but I am waiting for Fourier series as well, because Fourier series will also come on YouTube only. So once we are done with Fourier series, after that I will frame very good questions that will involve basics of signal as well, that will involve basics of system as well, and Fourier series as well. So collectively we can solve the questions. Ideally what I want is that what I wanted actually, that once we are done with the complete chapter, once we are done with the complete subject, after that I will frame assignments, because this is the beauty of signal system, that everything is interrelated. But as of now, what I feel like that after Fourier series I will frame 2 to 3 assignments, and then we can solve the problems. So ideally, yeah, you guys would be waiting for the assignment, but in the lecture itself we are solving a lot of problems. So some good level of problems we will solve after Fourier series. Okay, so that will be the flow. Now one small concept we need to see, or kind of questions only we need to see. So this is a LTI system having an impulse response of h of t, and output is y of t. So what is your y of t? Y of t is xt convolution with ht. Now if I ask you to prove that this is a linear system, will you be able to prove? Yes. What you will do? I will throw x1t, I will throw x2t, then I will throw x1t plus x2t. Basically, if I throw x1t, what will be my output? y1t. x1t convolution with ht. ht remains as it is. Here I am throwing x1t. If I throw x2t, what will be the output? This will be the output. If I throw x1t plus x2t, x1t plus x2t, what will be the output? Y alpha t. Can I write it down in this manner? x1t convolution with ht plus x2t convolution with ht. What this will be equivalent to? y1t. And what this will be equivalent to? y2t. So your y alpha t is coming out to be y1t plus y2t. That means additivity is followed, right? Additivity is followed. So what about homogeneity? So for homogeneity, what I will throw? I will throw 3x1t, right? So 3x1t convolution with ht. So 3 I can take outside, x1t convolution with ht, and what this is equivalent to? 3y1t. So your y beta t is coming out to be 3y1t. That means homogeneity is also followed. So certainly it is linear. I already know it is LTI, but I am just inverse proving that yes, it is coming out to be linear only. Now what about time variance? So for time variance, what I will do? What I need to do for time variance? In the input, I need to do a shift. In the input, I need to do a shift. I will not do anything with ht. ht remains as it is. So have we seen this property in convolution? That whatever the shift you are doing to this particular signal, then the same shift will be produced in the output as well. So basically, if you, in place of xt, if you are applying xt, then your output was yt. When you applied x of t minus t naught, what is the output? Y of t minus t naught. So whatever the shift you gave to the input side, the same shift is given in the output side as well. Here I am not doing any method here. What I am doing, this is my LTI system. I applied xt, I got yt. I applied x of t minus t naught. So whatever the shift I get here whatever the shift was there, if there was shift here as well, so that will also come in the output. But I am not doing any shift in ht. ht remains as it is. If I just give the shift in input, then I observe that in my output also there is a shift. So yes, it is an LTI system. Inverse proof I have done. They have said that it is LTI system. Now I am saying that you prove it if it is an LTI system. Why we are doing all these things, sir? It feels like we are doing nonsense. No, we are not doing nonsense. We are going to see very, very important conclusion. Very, very important conclusion. Okay. Let's do this thing. What will be my yt? Yt would be equals to, first what will be the output here? This is also LTI system, this is also LTI system. xt convolution with ht. And what will be the output here? xt convolution with ht convolution with h2t. So xt convolution with ht convolution with h2t. So how you are getting your output? xt convolution h1t convolution with h2t. So this whole system, this particular whole system, is it LTI or not? What I am saying, two LTI systems are cascaded. One is having an impulse response of h1t, another one is having the impulse response of h2t. So this whole system, this whole new system, is it LTI or not? Yes, it is LTI only. What you will do? You will throw x1t, you will throw x2t, you will throw x1t plus x2t, and then you will throw 3x1t. Directly you can check there, additivity and homogeneity both will be followed. Do I need to write it down? No. What I will do? I will throw x1t. So my y1t will be equals to x1t convolution with h1t convolution h2t. Then I will throw x2t. My y2t will be equals to x2t convolution with h1t convolution h2t, because I am not doing anything with these two. I am not doing anything with these. Only I can change xt and yt. Then I will throw x1t plus x2t. What I will get? x1t and x1t plus x2t I will throw. What I will get? x1t plus x2t convolution with this I will write down. So what will be my y alpha t? Y alpha t would be, I am throwing x1t plus x2t. It will be convolved with h1t convolution with h2t. So basically it is a plus b convolution with c. So it can be written as a convolution c, b convolution c. So what I can write down? x1t convolution with h1t convolution h2t plus x2t convolved with h1t convolution with h2t. So what was this? y1t. And what is this? y2t. So additivity is followed. What about homogeneity? Homogeneity also you can check. Very easily you can check homogeneity as well. For homogeneity you will throw 3x1t convolution with h1t convolution with h2t. So this is equals to 3y1t. Right? So here homogeneity is also followed. So linearities, there is no doubt about linearity. What about time variance? Only I can change the input. What I will do? T minus T naught. Just I am changing the input, nothing else I am doing. This shift remains there as it is. Here there is no shift. This also remains there as it is. So if there is only one shift of T naught, so in the output as well there will be a shift of T naught only. So when you shifted your input, your output is also shifted. So from here what do you get to know? That it is time invariant as well. Here, from here what did you get to know? Linear as well. So this whole system is also LTI, right? This was an LTI system, this was an LTI system, this was an LTI system. Is the whole system LTI? Yes. And what is the impulse response of the whole system? Because your output is interrelated like this, xt convolution with something. So what is the inverse, what is the impulse response of the whole new system? That is h1t convolution with h2t. This is an LTI system, so I can find out the impulse response of this particular LTI system, that is h1t convolution with h2t. Well and good. Let's go to the next one. So will this new system be LTI? So let's check. What is this? This is adder. Okay. So what you will get here? What you will get here? You will get xt. First I will get xt convolution with h1t convolution with h2t. h1t convolution with h2t. So this is what I am getting here. What about this? This xt goes here. This xt goes here. This xt goes here. So here I am getting xt convolution with ht3, h3t, and then both are added, plus xt convolution with h3t. then both are added and you receive your output yt. So what is yt? Yt is xt convolution with h1t convolution with h2t plus h3t. What you will do? Throw x1, throw x2, throw x1 plus x2, throw 3x1. You will realize that it is linear. There is no doubt about that. Right? There is no doubt about that. It will be linear only. x1t you will throw, x2t you will throw, x1t plus x2t you will throw. What will happen? x1t convolution with this particular thing plus x2t convolution with this particular thing. This is in convolution with anything. This is like A multiplication with B into C plus D. So can I break it down? A dot B dot C plus A dot D. So x1t you throw, x2t you throw, in that manner you throw. If I am throwing x1t plus x2t, what I am saying, if I am throwing x1t plus x2t, it's like A1 plus A2 dot B dot C plus D. So A1 is being multiplied with this particular thing, A1 dot B dot C plus D, plus A2 is being multiplied with the other thing, B dot C plus D. So this is your y1t, this is your y2t. So y alpha t is equals to y1t plus y2t. Same goes if I throw 3x1t. If I throw 3x1t, then homogeneity will also be followed. So you can check very easily, it is linear for sure. What about time invariance or time variant? So just in the input I am doing the shift. It is being convolved with some particular random function. I am calling this function as h of t. So only one shift I am making, so in the output as well only one shift would be there. Say yes or no. So if you applied x of t minus t naught, your output has changed to y of t minus t naught. So is this LTI? Yes. So yeah, I have proved linear already, I have proved, and time invariance here I have proved. So this is also LTI. And if it is LTI, can you write down its impulse response? Yes. h1t convolution with h2t plus h3t. This is the impulse response. Try this one. H1t LTI system, H2t LTI system, then there is something added, alpha of delta t is equals to yt. Will this whole new system, will it be LTI, will it be linear, non-linear, time invariant or time variant? Try this on your own. Okay, have the patience and try this on your own. So what will be your yt? First here xt convolution with h1t, then here xt convolution with h1t convolution with h2t plus alpha delta t. What will be the output? Your yt would be equals to, here what you will be getting, xt convolution with h1t convolution with h2t. So xt convolution with h1t convolution with h2t plus alpha delta t. This is your output yt. That's it. Whatever that you get here plus alpha delta t is your yt. Is it linear? You will throw x1t, you will throw x2t, you will throw x1t plus x2t. Let's throw x1t plus x2t. So what will be your yt? x1t plus x2t convolution with h1t convolution with h2t plus alpha delta t. What you are getting? x1t convolution with h1t convolution with h2t plus x2t convolution with h1t convolution with h2t plus alpha delta t. What is your x1t? What was your x1t? Sorry, what was your y1t? Y1t would have been x1t convolution with h1t convolution with h2t plus alpha delta t. And what was your y2t? Quite similar, just in place of x1t it would be x2t. Everything would be same. If you add both of them, here should be 2 alpha delta t, right? If you add both of them, 2 alpha delta t should be there, but here there is only 1 alpha delta t. What does that mean? That it is not equals to y1t plus y2t. So surely it is non-linear. What is the major issue? Major issue is this guy. It is surely non-linear. But will it be time variant or invariant? A very good point. How will I check for time variance and invariance? What I will apply? X of t minus t naught. So here what I will do? I will put x of t minus t naught. Rest everything remains as it is. h1t convolution with h2t plus alpha delta t. Everything remains as it is. So if I am doing a shift of t minus t naught here, then whatever this convolution result it was giving, let's just say this convolution result was z of t. So here what I will get? Z of t minus t naught. But this alpha delta t remains as it is. So can I call this is equals to y of t minus t naught? Absolutely not. This is not equals to y of t minus t naught. What is the meaning of y of t minus t naught? That what is my yt? I should have used the other page. Let me use another page. What I am writing down? Let's write down this equation. Let's copy all this, whatever that is copied. This was your yt. So what I am saying, my yt is equals to zt plus alpha delta t. Then what you did? In place of t, sorry, in place of xt, you put x of t minus t naught. That means you gave a shift. You gave a shift of t minus t naught here. So what really happened? This was shifted by t naught, because if there is a shift in one, then the same shift will be given in this particular thing as well. But here there was nothing changed. This was alpha delta t. This is alpha delta t only. So what is the other thing you are getting? What would have been your y of t minus t naught? Y of t minus t naught. That would be in place of t you put t minus t naught, and here you put t minus t naught. This would have been your y of t minus t naught. But what you are getting here? You are getting this particular thing. Is it equals to y of t minus t naught? Absolutely not. Right? So when you gave the shift in the input side, the output is not shifted. It is not exactly shifted, because here you are getting alpha delta t. So when I applied x of t minus t naught, I am not getting y of t minus t naught. What does that mean? It is time variant as well. So very good conclusion and a very good discussion, that this alpha delta t came and it just mashed up everything. Previously it was LTI, till this point it was LTI. But if there is another function added, if another function ft is added, what was this? Here it was LTI. In LTI, if another function ft is added, then it can create issues for you, right? And it has created the issues. Our output is now, our system is neither linear nor time invariant. So it is time variant and non-linear. And how did we check it? Here 2 alpha delta t should be there, so there is an issue. And here when I did a shift, then only this convolution was shifted. This remained as it is. There was nothing happening with this particular thing. So that's why it was time variant. Okay, but if you needed y of t minus t naught, that means this should have been shifted, this should have been shifted. But how will you shift this particular thing? Just by shifting the input. So just by shifting the input, we cannot do this process. That's why it is non-LTI. What about this one? What is happening here? xt convolution with, first xt convolution with h1t plus b delta t. Then that will be convolved with h2t. I hope you are getting the point. xt convolution with xt convolution with h1t. Then it will be added with b delta t, convolution with h2t. This is what we will get here. Then minus b delta t. That would be equals to yt. So let's solve it. xt convolution h1t convolution with h2t plus b delta t convolution with h2t. So b h2t minus b delta t, that is equals to yt. So this is the yt we are getting. right? This is the yt we are getting. Is it linear? Directly you can see it is not linear. What I will do, I will apply x1t, then I will apply x2t, then I will apply x1t plus x2t, then I will apply 3x1t. So when I apply x1t plus x2t, what I will see, that till this point everything is fine, but these things will be added once only. These things will be added once only. But when you do y1t plus y2t, these will be added twice. So certainly it is non-linear. That's for sure. Will it be time variant? So what I am doing, I am calling this as zt. This as zt. This remains as it is, bh2t, and this remains b delta t only. So this is my yt. If I apply a shift in the input, what I do, if I apply a shift in the input, what will happen? This remains as it is, h1t remains as it is, h2 remains as it is. So z will be replaced with t minus t naught. So if I apply a shift in the input, what is the output we are getting? Output. If I apply a shift in the input, output we are getting it z t minus t naught plus all these remains as it is. Nothing will happen to all these. bh2t, bh2t minus b delta t. But what would have been your y of t minus t naught? What is the meaning of y of t minus t naught? Z of t minus t naught, z of t minus t naught plus bh2 t minus t naught, bh2 t minus t naught minus b delta t minus t naught. So both are different, right? So whenever you give a shift in the t naught, sorry, whenever you give the shift in input, in place of xt, when I applied x of t minus t naught, at the output I did not get y of t minus t naught, because y of t naught, t minus t naught would have looked something like this, but this is the output I am getting. So this is not time invariant as well, that means this is time variant. So this was time variant and non-linear. And that's it. This is the complete end of the chapter. So everything that was required for basics of signals and systems that we have covered. Now the most interesting part will start, that is the Fourier series, and you will enjoy it a lot. That's my promise to you. Okay, so very interesting part is going to start, that is Fourier series. Problem solving we will see after Fourier series, but I hope you enjoyed this lecture series till systems. And in system is considered one of the most complex topic of signals and systems, because here there are a lot of concept, but I hope I have broken down concept in a good manner, and the flow of the chapter you liked in a very good manner. I hope this is what these are your reviews. So I would like to know your reviews in the comment section. Okay, thank you very much. Let's meet in the Fourier series.